We've now reached a critical point in the development. A lot of the skills that we've been learning so far are now going to start consolidating, and we're going to turn it into a little bit more of a singular system. Those fundamental techniques, those techniques that you learn in the previous stages, they're all going to start complementing each other. And instead of having 20 different things going on, we're going to try to funnel them into a single system that you can continue to refine and continue to do your cobes on. So before we jump into that, let's do a very quick recap in terms of some of the most important points, as well as what you should be familiar with by now to know that you're ready to learn this system. We've covered the idea that your brain processes information, and depending on how you process it, it affects the quality of encoding. If we do it poorly, we forget lots. We have to make up for that with more time and effort on relearning and more retrieval. Whereas if we do it very well with a high quality, we're able to hold on to that information for longer, it's stickier, and we're able to then use that information at higher orders with more complex needs, and we're able to retrieve it in more diverse situations like complex problem solving. And by now we should be familiar with some of those processes that produce high quality learning, higher order learning and higher order thinking, a lot of that comparing, evaluative learning where we're integrating knowledge, and we're even starting to experiment with the usage of mind maps and nonlinear notes to represent that nonlinear thought process on paper or on our tablet. There should be a connection between the notes that we're writing and the activities that we're doing and the processes that we're trying to activate. And so this is an important part of self-regulation. We're aware of what process we should be using cognitively, and we're able to match that with the process physically that is meant to help that cognitive process. Adding on to that, we've added little parts of inquiry-based learning using traffic light system. We're getting used to forming a backbone, which is really honing in on our ability to do an even higher level of higher order learning, where we're not just finding groups, we're not just representing it non-linearly, we're not just finding relationships, but we're now prioritizing and truly evaluating to see which relationships and group structures, aka relationships plus groups, make the most sense and seem to be the best at scaffolding the entire topic. And of course, we can't forget that we should have some experience with the interleaving as well, so that we are re-encoding, that we are retrieving, that we are having that safety net for things that do fall through as we continue to develop that encoding skill. And we have a strong focus on experimental, experiential learning. We're doing that code cycle to track our marginal gains along, including whatever self-management skills like time management or task management or stress management or goal setting, whatever it is that we need to be able to enable us to use these learning skills in the first place. We should have pretty decent competency for most of those things, definitely well and truly in the realm of conscious competency of varying levels of effort and consistency, as we've talked about. So now what we'll do is we'll put that into a singular system, a structure, a series of steps that we can follow, and we call this the bear hunter system. And don't worry, there are no bears harmed in the making of the system, and you will not harm bears either, unless you are learning how to hunt bears using the bear hunter system, which is kind of a different thing. But the idea is that just like how when we were back living in caves and the way that our brain adapted to learn, we are using a system that makes use of those biological tendencies, except we're not using it to hunt bears, presumably. We're using it to learn biology, chemistry, maths, physics, accounting, finance, economics, politics, legal studies, whatever it is that you're learning. And the bear hunter system is divided into 3 key steps. The first step is aim, which leads to shoot, which leads to skin, which sounds a little bit morbid, but it does make sense. In the first part, the aim step, we are pointing our brain, we're aiming our brain at the topic in a way to maximize relevance. The objectives of the aim step are to scope the topic, to identify the most pertinent areas and the keywords that we want to focus on, and to build that backbone so that we're priming our brain for maximum relevance and therefore maximum retention, and making all of that higher order learning much easier to do. When we're able to do the AIM step really well, it means that that higher order learning, that evaluative thinking, we're able to handle that overwhelm much more easily. We should be able to do it for bigger topics and in a shorter amount of time. So it's improving our efficiency with that. Obviously, if at this stage you're still not comfortable with just doing that basic evaluation and creating some priorities and groups and non-linear note-taking and things like that, then you probably want to slow down a little bit before you enter into this phase. After we've aimed, what do we do? Well, naturally, after we've aimed, we've got to shoot. So shoot refers to then really analyzing the resources, the text, the lectures, the videos, whatever resources that we're learning from. And we've primed our brain. So now we're going to give our brain the material to really dive in and learn it. So this is where we're going through the material in much more detail. We're really filling in our understanding of it. We're truly building up that mastery process using the scaffold and the priming that we created in the AIM step. And the final step, which is the skin step, this is allowing us to clean up the structures that we've created. Because the nature of the bear hunter system allows us to work with large volumes of information in a relatively short period of time, it means that there will be some inevitable back and forth. You're not going to create the best relationship or the best structure straight away. There's too much volume to work with. And it's not efficient to try to get them perfect at every step of the way either. We should be allowing a little bit of error because that's more efficient. We can move a little bit faster if we're not too careful about getting everything perfect. That's why the skin step is there, so that any of the additional relationships we figured out later on, maybe in a 5th hour of studying, we realized, we probably should have put this thing here instead of here. The skin step gives us the opportunity to clean all of that up and consolidate it. The good thing is that the skin step in itself can be a form of interleaving, which means that you can schedule it in just like how you would schedule in any other form of interleaving. And the AIM step can also be used as a form of pre-study as well. I'll talk a little bit more about the difference between the AIM step and pre-study when I teach the AIM step properly though. As you move forward working through the bear hunter system, the idea is that you'll now have 3 key pillars. The first one will be your pillar for encoding effectively. That will be the bear hunter system. You use the bear hunter system to encode new knowledge at any time. For any type of subject, you can use this system. And then for retrieval and optimizing that performance, we're going to be using our interleaving, spaced interleaved retrieval. That fundamental still exists. We'll learn a few ways that we can upgrade that later on, but it's still just as powerful as it was when you first learned it. We're going to keep that going strong, but you'll find that those sessions are easier because your original encoding is of a higher quality. You probably already realize that now, in fact, and you'll also be able to space things out with longer gaps. Again, because our base encoding is higher. And again, you probably also started to notice that already anyway. The third pillar will be our pillars around self-management, the enablers that allow us to engage in these learning skills in the first place. And this will be the combination of different time and task and other types of prioritization and procrastination reduction and goal setting and planning and all those other skills that we taught you, the system that you're developing with that. And of course, we can't forget the thing that binds all of them together, that will always be there, will be there for the rest of your life, which is COBES, allowing us to develop these skills and continue to refine them, all to do the AIM step correctly. You'll notice that there are similarities between the previous techniques that you've learned. And just remember that once you learn how to do this, a lot of those previous techniques will actually be replaced by the bear hunter system. Remember, it becomes that pillar for all of your encoding that you need to do. So once you learn this, you don't need the traffic light system anymore. I mean, certainly by now you should have moved away from just collecting and processing. If you ended up needing to use that step, the normal method of nonlinear note-taking and things, we're going to start replacing that in Ascent 2. For now, whatever method of note-taking and mind mapping that you are using, continue to use that, continue to refine that, continue to do your COBES on it. In the next stage, we will actually learn how to refine that even further to completely augment the AIM step. However, for now, just do your best with whatever technique that you have. As long as you're doing your COBES, you're probably doing fairly well. And if you haven't been doing your COBES, then let this serve as a reminder for you to jump back into it. So the aim step. Let's go through what you're meant to do step by step. So the aim step is rather simple, and you should have already a lot of the core competencies necessary to do this relatively accurately already. We're already used to the idea of collecting the information that we need first, isolating out the keywords, and scoping the information for what we need. And we should also be used to using our questions to help us find relationships, and therefore also help us trigger that evaluative higher order learning, which in turn allows us to not only prioritize our relationships, but also form groups, otherwise known as chunks, and of course relate the chunks to each other to create a chunk structure, which is essentially our network of groups, which is essentially our knowledge schema that we are forming, that multi-relational integrated knowledge schema. What we're doing in the aim step is we're actually working at this step over here. So the idea is that if the relationships that you're discovering depend on the questions that you are asking, because it points your brain to think in a certain way, just like how, for example, if I ask you, what did you have for dinner? You're going to think in a different way to if I ask you, what is your mother's name? The questions affect everything that happens after this. If you ask the right question, then you think in a certain way that allows you to find certain relationships, and that therefore means that you're evaluating different ideas and different concepts and different relationships against each other. So naturally, what you end up forming as chunks and what you're prioritizing also changes, and so your entire chunk structure then changes as well. So we naturally already know that not all questions are as effective. So some questions are more predisposed to triggering lower order learning. So these types of questions, for example, just asking, what is something? What is the definition of something? All of these questions that are very isolated. These are all lower order learning questions, right? And then there are some questions that are higher order. For example, these comparative questions. The ones that make us compare two concepts against each other and to find similarities and differences. And of course, the ones that make us prioritize them. And so what we're going to do in this aim step is introduce two key questions that you should be asking yourself. And these two questions can replace pretty much every other question that you'd normally ask. In the traffic light system, you're used to asking a variety of questions that are driven by curiosity. And the reason that we were doing that was because we wanted you to get used to using that process of inquiry to fuel the way that you think, the connection between question and relationships, and therefore the higher order learning that you do as a result of that. We wanted you to become familiar with that process. And so by being familiar with that process, we can then start refining that process. Back in the day, I used to not have that original step. I used to go straight away to trying to teach people the best types of questions that we can use. There are many possible ways that we can interpret that, and not all of the ways are actually accurate. And so we're going to cover some of that in this lesson. So what are these two questions? Well, the two questions are, why is this important? And how does this relate to blank? And each of these questions serve a very specific purpose. Now, it might seem like these two questions are simply just two random questions, but it took me years to figure out that these two questions are really the ones that you want to land on. Because if you've got too many questions you're asking, it can be very multi-directional. So yes, you do get relationships, but it increases the chances of sort of going down a rabbit hole or going down in the way too out of scope. A little bit out of scope is fine, but you go too out of scope, it makes it a bit of a messier process. And so overall, what I found was that if you're able to focus your attention on just a couple of key characteristic questions, then we can focus the thinking process as well. And it means that it's much more predictable in terms of the type of relationships we come to, and eventually the type of chunk structure we come to as well. It also made it much easier for coaching because it meant that we are able to standardize the type of thinking process that people are doing and help you work through your problems a lot more effectively compared to if you had 100 different questions of all these different varieties. And we found that actually asking these types of questions created a better knowledge structure that was more practically useful, easier to retrieve, and easier to really reach that higher level of thinking compared to a lot of the alternative questions. And so this is why these two questions are the core of the aim step. So what's so hard about asking 2 questions? Okay, well, there are a lot of ways the questions can be interpreted. Knowing how to answer these questions, that is a skill. And you'll see that with lots of demonstrations about how this looks in different contexts as well. And you'll see the different variations of how we can do the aim step, but the underlying trend remains the same. And I'll break down that process in this video. So once we've got these questions asked, we're then going to go through, skim through the resources, read through the material to gain a general understanding about why it is important or how it relates to blank, whatever else, other concepts or keywords that there are. And following from that, we're going to hypothesize some structures. And the important thing here is that we're hypothesizing the structures. We're not saying, oh, this is definitely the chunk structure that I'm going to get to. This is definitely the backbone that I'm going to get to. We're saying this is possibly the backbone that I'll get to. It might work, maybe it doesn't. And so we're always open to coming back to this hypothesis and constantly testing this as we continue to learn more, not only throughout the aim step, but also later in the shoot step, maybe even up to the skin step. We're constantly willing to review this chunk structure to see if there's a better way that we can do it that makes most sense for us. Because that is the goal. It is to make learning make sense to us, to make it logical and to make it intuitive. So let's see how these steps look in action. Again, it is very simple procedurally. The devil is in the details in terms of the nuance of how we're answering these 2 important questions. So step 1, we're going to collect the keywords. So let's say, for example, we have a mix of resources. We have a video that we're watching. We have maybe a book that we're learning from with just normal sort of linear notes. Maybe we have a series of slides as well that have been provided to us in a course guide or something like that. And maybe we've also got a big, thick textbook as well. And of course, we might have something like Google or potentially some alternative form like an AI search solution. Basically some resource that you're able to tap into to get answers that are hard to find or don't seem to exist within the ones that above that we're potentially prescribed to or that you otherwise have access to. And so what we'll do here is that we will quickly skim through these to find and collect a list of keywords. And you can type these keywords out. It doesn't matter. It doesn't have to be in order. In fact, it's sometimes better to do it out of order, because what we want to avoid is we want to avoid chunking it in just the same way it was taught to us. Often when we're reading something that is in a linear format, because of the fact that knowledge is not linear, when it's transformed into a linear format, and remember, things like videos are also in a linear format because it's delivered to you in a certain progression, in a certain order. Obviously, written text down the page like this is the most linear format. Textbooks are very linear often. Actually, even slides are very linear. Diagrams, flowcharts, these things may not be as linear, but most of the time we're dealing with linear information. And linear information was the transformed version of information. If you think about knowledge in and of itself, inherently, knowledge is not linear. So in order for you to have perceived it to begin with, someone had to transform their non-linear knowledge into something that is now linear for you to then learn off of. Your job as a learner is not to just learn the linear form of that knowledge. Your job as a learner is to turn it back into closer to the original mastery of the person that gave you that information, which is non-linear, which is structured in a multi-relational integrated knowledge schema. So that's what your goal is. And so we have to deconstruct the information in order to reconstruct it in the most accurate way. Often the headings, the titles, the hierarchies, and the way that it is taught to us in a linear format is not the same way that we should encode that information and hold on to that information. Even if you're being tested in a linear format, it's still not advisable to learn it linearly to begin with. You can always learn it in the way that is cognitively most optimal, and then you can retrieve and practice retrieving it in a linear format. It's much easier to manipulate strong knowledge that's encoded well, that you're not forgetting very easily, than it is to compromise the quality at which you're learning it, forget all the time, just because you know that you need to output it in that same way. The way you need to retrieve information and the way you encode information often are not going to be the same. Sometimes they are the same, but often, especially with academic learning, like prescribed linear notes and things like that, often it's very, very different. So we don't want our chunk structure to really follow the same way that it was presented to us. And to prevent us from the cognitive bias of thinking about it only in the way it was given, with these headings and these subheadings, and then that becomes the chunk and this becomes a sub-chunk, it can actually be useful to deliberately collect the keywords in a different order than it was given. The other thing that we can do is make keywords that aren't necessarily plain and obviously given to us. So it may not be a bold word or a heading or in the table of contents or something. You may skim through a paragraph and feel like it's talking about some kind of concept. You can make your own keyword for it. You can look at a diagram, and maybe that diagram doesn't have a particular keyword that is given for it, but you think it seems like an important concept that you want to note down. You can make your own keyword for what that diagram is trying to tell you. So don't spend too long on this step. We are just trying to get a list of keywords. It doesn't have to be 100% comprehensive. It might take you, let's say, 2 hours to comprehensively get 100% of all the main concepts. It might take you 25 minutes to do this for 80% of the ones. Don't worry about the small, little, tiny terminology that might be missing in all the little cracks. Just focus on getting the ones that you think are the most important. For most topics, let's say you're doing a couple chapters of a textbook, or if you're a secondary school student, maybe this is a few weeks of class material or something, you're not normally going to have more than 20 or 30 of these major concepts. In some cases, you've got actually even a lot less. You might even have sort of 15 to 20. So you don't have to have pages and pages of concepts. Being 100% completionist is not the name of the game. The name of the game for this task is to just get what you think is the most important ideas, that if you were to miss this, you're probably missing something that's very important. And you can get a sense for that with a very, very quick skim read. So again, for this step, we're trying to be relatively quick here. There's a picture of a clock just to show that we want to have a certain level of pace. Right? Don't worry too much about those details. We're really just picking through, getting some of these concepts. Now, what do you do if you encounter a word that you have absolutely no idea what it means? If you encounter a brand new terminology, you've never heard of it, and you can't even guess what it means, read a little bit about it so that you understand what it means. Just enough to have a general idea of it when you look at it again later. Don't go into it too much in detail. Don't really try to understand it too fully. Just enough so that when you read the word, it's not completely foreign. You have a general idea about how to think about it. I personally wouldn't spend more than 30 to 40 seconds to try to understand what a new word means. If it takes after 30 seconds, it feels like you still don't understand it, I would then ask that question in Google, in an AI, ask it, what does this word mean? Tell me in, like a single paragraph. You really just want to have that general, very, very basic scope. So this process shouldn't take too long, and if it's taking you too long, you're probably trying to collect too many words, or the volume of information you're working with is too high for your skill level, or you're getting too anchored down into all of those details. After you've collected all of these keywords, you're then going to move on to asking that question, using that inquiry process. And the questions we're asking is, why is this important, and how does it relate to blank? Notably, we're not asking the question of what something is at all. The idea here is that when your brain tries to engage in higher order learning, the lower order learning requirements are met by default. It's impossible to compare two ideas against each other when we don't even know what the ideas are. In trying to compare it, we will have to learn what it means in the first place. And even though that is a lower order process technically because we're just trying to understand it, it is actually going to have a higher order advantage because the intention, the purpose behind why we are learning what it is so that we can do the evaluation. And so it's different to just saying, I'm going to learn what it is, and then maybe later coming back to it. That's a completely different story. If we start by just saying, what is it? And then collecting all of these keywords, and let's say we've got 10 keywords and we ask, what does this mean? What is it? 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 And then we try to create the relationships afterwards. We're actually doing ourselves a disservice because we've probably already forgotten half of that stuff because it wasn't integrated to begin with. And our short-term memory only lasts seconds to a couple of minutes. So unless you're really integrating all of that within seconds to a couple of minutes, we've just wasted that time. So at the time where we are actually doing the inquiry, we want to be creating that integration as quickly as possible. So we've got this list of keywords and we're going to do our questioning process. We're going to ask, why is it important? And this is a process through which we call importance-based chunking. And you'll see us talk about this all of the time. You'll see coaches talk about this. You'll see it get thrown around in the community all the time as well. Importance-based chunking is the idea that the chunk structure we end up forming is based on its importance. And this is because when we ask why something is important, it tends to make us do a type of higher order learning and a type of evaluative thinking that is very beneficial for most retrieval needs. I found that when we can answer this question very accurately, the chunk structures that we form are often very transferable, very applicable for most types of retrieval needs. Basically, you can do this for any different topic. And really, it supersedes every other type of question that you can ask of this subject. When you ask this question, all the other questions seem to be included within it. It's weirdly the most important question to ask, which is why it is important, which is a coincidence, I think. But of course, we can't forget the second question, which is asking, how is it related? Now, when we're first starting, it's going to be a very step-by-step process. We're going to start by collecting the keywords, and then we're going to go through each of the keywords, and we're going to simply say, well, why is this important? And then how is this keyword related to the other keywords? So obviously, when you're first starting, you're not going to be able to say why the first keyword is related to the second keyword because you may not have really explored the second keyword enough. So when you're first starting, you're not really going to have a lot to work with there. However, as you get to your third and fourth keyword, now you've got 3 or 4 keywords to work with. So when you say, how is it related? You've got these other keywords that you've already covered. And then as you're asking the question, why is it important? You're going to start relating it to the other keywords as well. So you'll start probably, usually you'd start at the top of the list and then you work your way down. But as you continue to ask these 2 questions, you find that you're covering the later concepts as well. And then that's where that curiosity can lead you. So once you get partway through the list, you can just start going out of order. And remember that the list might be out of order to begin with because you literally wrote it out of order to prevent framing bias. So really what we're doing is we are taking control of the order. We're doing our order control. We are deciding to learn it in the order that we feel is potentially the most relevant for us, that we are directing, we are leading. And so we ask these questions, we develop these relationships, we hypothesize on some of these structures, and then we let our curiosity take us in terms of what word we should do next. And again, for the first part, it's probably going to be just down the list because you don't have enough to work with. But once you start having a few possible maps starting to form, then you'll be able to bounce around back and forth a lot more organically. And again, you'll see exactly what this looks like in the demonstration as well with some more context. Now, I'm going to go through this point in a little bit more detail in terms of how we actually answer this question correctly, because there are many ways to answer why something is important, but not every way of answering it is actually correct. Remember, the purpose of asking this question, why is it important, is so that it generates higher order learning, which involves the evaluation and the comparison. So if the question you're asking doesn't create this higher order learning, it hasn't done its job. So one of the things that we often see is that people will do something that we call importance checklisting, where they have the right question. They'll say, why is this keyword or concept important? But instead of finding multiple possible relationships, they'll simply answer it with like a singular 1-sentence or 1-word answer. So when you say, well, why is this important? They'll say, because of this. And they'll move on to the next one. Why is this important? Because of this. But that's not really the case. There's usually multiple reasons why something is important. Some of those reasons may be more significant than others or more applicable in different contexts, but that's actually the point. We want to understand the relationships that it has with all these other things, using the question of importance as a trigger. So even if you can superficially answer why something is important, it doesn't actually mean that you've done the step correctly unless that has led you to identify multiple relationships and then compare those relationships with each other. So you can see that in the beginning, you might say that, well, this first thing is related to this second thing, and it leads to maybe this part, and that's the reason it's important. And then when you do the second keyword, you might say, well, actually, no, this first reason was actually wrong. It's not important because of that. It's actually important because both of these things contribute to this thing here, and this is a pre-step before that. And at this point, you might think, well, I'm quite interested in this particular concept. So you might go into that and say, well, why is this one important? And then how does that relate to these top two and maybe another concept? And then you'd go back and forth between these, discovering new concepts, finding new networks, correcting mistakes, finding new mistakes, back and forth. And this is the idea of hypothesizing those relationships. As you go, you'll have certain ideas about how you might be able to structure it. So I'm just going to use letters of the alphabet. Each letter will represent one keyword. And then you'll see what this looks like in context in the subject examples later. So let's say that we have these concepts, A, B, C, D, and E. As we're going through, we might say, okay, well, A might be important because of its relationship to B, but we're not sure. We'll just keep going through. B is important because of its relationship to A. Yep, that's definitely correct, but it seems to maybe be involved in something else around here, but I'm not quite sure about that. Let's leave that for now. Let's go through to C. Okay, C seems to be related to both A and B. Okay, so both A and B create C in the first place. And actually, now that I've learned about C, there's actually another feedback relationship where C then influences something that happens at B, and maybe something over at E. So we'll go to E now. How is that important? Okay, that's a back and forth relationship, and then that might be related to D. And so we've got this general idea. At the moment, it's just a list, but we could represent this like this instead. We could say A is going to be, which leads to C, which then feeds back to B with an input back and forth from E that also leads to D. And so you see now that I use my spatial arrangement to represent this with non-linear note-taking, it starts to take a life of its own. It's a lot more clear what the relationships are and what the general backbone and the structure of the information might be. But in the aim step, we're not going to be sure about this. These are all going to be just potential ideas. We could be completely wrong. And so what's more realistic is that we're not going to be able to say, yes, this is how it is. We'll be able to say, well, maybe it's this, but it could also be that maybe A and also C should actually be grouped together, and then that is actually leading to B. I wonder if that's an idea. And is it possible that we could potentially group E and D together as well, and then that could actually have a relationship to C? And this is more realistic of what the notes would look like. You'd have these multiple possible ideas sort of sprawled around as you're considering them. And then as you go through to learn more, you go through the other keywords in the aim step, you might say, oh, this doesn't actually make sense, and this doesn't make sense, but actually I could combine the two and form something else instead. So you're constantly going back and forth to revise your hypothesis. And this will continue all the way through in the shoot step as well. So we never want to be completely solid on the structure that we create with these main ideas to begin with, because we might be wrong. We don't want to overcommit and then bias ourselves to sticking with that structure because we spent all this time and effort to figure out that this structure seems right. And then we realize, oh, maybe it's not, but then, oh, I spent all that time and effort. I sort of don't want to break the structure and make a new one. It feels like I can't be bothered to do that. This is what we call the sunk cost fallacy, where we've already sunk a lot of cost into doing this, and that's going to affect our decision for whether we want to rework it. We want to avoid that. So everything is very hypothetical. We're just playing with a few ideas, and we should have something that feels like a good big picture backbone level understanding. Doesn't have to have any of those key details, just a general understanding about the main ideas, the main groups of ideas, aka the main chunks, and then the main concepts within them. So how do you know you're doing this step correctly? Because number one, you should feel you are doing a lot of higher order learning, or rather, you're doing a lot of higher order thinking to generate these higher order learning structures. That's a lot of that evaluation, a lot of that comparison. You will probably be doing a lot of back and forth. When you ask the question of why is it important, you will find that you are generating lots of relationships, not just a single answer. You're creating multiple possible hypotheses. And these hypotheses could be in terms of relationships that you think might be important or maybe aren't important. And they could also be in terms of the actual chunks you're creating as well. Could I chunk them this way? Could I group them this way? Or should I group them another way? Which way would make most sense for me? If you're doing all of these things, you're probably doing it right. If even one of these steps is missing, you're probably not either holding yourself to a high enough standard or thinking deeply about it enough, or potentially if you are trying to do this, but it's just taking forever, you're probably just getting sucked into the details too much. Remember, we do have a list of keywords, but if you go through this in maximum depth for every single keyword, it's going to take a long time. Keep it hypothetical, play with the ideas, group things in terms of how you think it might be important. Remember, the objective of the AIM step is to prime our brain for relevance. Just figuring out what we think the main ideas are and scaffolding that out, and then layering on what we think the main concepts are, is perfectly fine. That in itself is going to be enough. We don't have to be completely accurate, and we don't have to be completely certain. In fact, it's probably a bad thing to be that certain so early on in the studying process. And so there are a couple of common questions that arise about this technique. The first is, what is so special about it? It just seems like it's asking a couple of questions. Yes and no. In fact, the fact that it seems so simple is part of the beauty of it. It sounds a little bit cliche, but we want our brain to be very, very focused. And when it comes to learning, as by now you probably should realize, learning is very complicated. It's a very complicated process. There's a lot of different types of thinking that can go on. Not all of those types of thinking are actually productive to producing the knowledge schema that we want. To work that way through mastery and develop expertise in as short of a time as possible, it requires a focused, directed effort. And the best way to focus and direct your effort is to give it a prompt, to make it clear what is the objective of what we're trying to achieve. And so ironing out this objective and figuring out exactly what do we need to prompt our brain with and what type of thinking do we need to engage in to generate the structure that is the most beneficial for us. This was the challenge that I set out to solve, that the AIM step solves. And the other thing is that because of the fact that what we're doing is scoping to find keywords first, whether it's scrubbing through and skimming a video and reading the captions, or what you can also do is you can chuck it into a transcription AI. It will transcribe the lecture or video or whatever it is for you, and then you can pick through that itself. Or you can check the transcript in another AI to break down in terms of figuring out what the keywords and concepts are from that. It can do the work for you. The keyword collection part is not the part that you need to worry about. That's the easiest part. The faster you can do that, the better, because the main benefit is using the keywords as a platform to do order control and higher order learning, both at the same time across multiple resources. So now it doesn't matter how many resources that you have. It doesn't matter how it was taught to you. It doesn't matter how good your teacher was. It doesn't even matter how interesting the subject seems, because you are completely at this stage in control of the learning. It is an entirely independent process. The only thing you need is raw data to pull the keywords from, a source of information to be able to answer the questions that you have, and the skill to be able to do that type of evaluative thinking and to build the knowledge structures. And that's the hardest part. That's the part that's going to be difficult, but that difficulty is desirable. The difficulty involved in doing this type of thinking here, this is desirable difficulty. So we want to be looking out for that. The second question that I often get is, how is the AIM step different from pre-study? This is a very good question. The AIM step is a cognitive process that you should do to prime your brain, but it might not happen in a single pre-study session, or you might be able to do even more in a pre-study session. Pre-study refers to the act of studying before a main learning event, such as, most cases, lectures or classes. If you have a lecture or a class you need to attend, pre-study is the study you do before that to make that time the most effective, or in some cases, so that you don't even need that. And so technically, it's possible to pre-study the entire topic to 100% level accuracy before you even attend the class or the lecture. Is that beneficial and advantageous? It could be, or it could not be. For example, if you have to, it's mandatory to attend class and to attend the lecture, then it's actually not time efficient to study everything to 100% beforehand, because now you're wasting the time in class. Let's say that you've got 4 to 5 hours of class per day. You have to spend 4 to 5 hours of time there. If you're not learning during that time, it's actually a waste of time. So it would have been better to put yourself in a position where that class time is maximally beneficial, because you're having to spend that time anyway. Whereas if you don't need to attend it and it's not mandatory, then maybe it is more beneficial to just study it at your own rhythm and your own pace completely. And any blanks that you need to fill, maybe you've got recordings that you can review to fill in all those blanks. Or maybe there's other people that you can ask, maybe there's office hours you can attend, there's other resources, whatever it is you've got access to. So that's the idea of pre-study. It's purely a chronology thing. What you're doing when you're studying and what order you do it in, that is where the bounty system comes in. The aim step should always be the first step of your studying. So what that means is that if you're doing your pre-study, but you've only got 20 minutes, you should be doing the aim step in that 20 minutes. You may not be able to do a full aim step in that 20 minutes. You may have to do part of the aim step during the lecture even, or you may have to just do some kind of hybrid collection, mini consolidation processing step in the class, and then you complete your aim step after class to make the most of it. And then you'd move on to the shoot and then to the skin. So you can see in this situation, you did pre-study, but you didn't do the whole aim. Or alternatively, maybe you've got more time to pre-study, and now you're able to do the full aim step, and you've actually got time maybe to do even part of the shoot step as well. So you could do that. You could do part of the aim and you could do part of the shoot before the lecture or the class starts. In this case, you've done the pre-study and you've done the aim, but it wasn't that pre-study and aim were the same thing. So again, aim, shoot, skin, the bounty system is the order in which you encode information. And it should always follow this order because this is designed to be cognitively optimal. However, when you do this in terms of the actual timing, that is what pre-study refers to. So you could do the aim step and not do pre-study at all. This would be an example where you didn't have time, and this is really not optimal. Like, you should always be doing your pre-study. But you're in class, you didn't pre-study anything, you're in there, in class, you're kind of frantically trying to just like process and piece together information. And then afterwards, you'd go through, and now the notes and the processing you did during class, that would actually form just one of the resources that you're using to scrape to start the aim step. Now, there will be some kind of advantage because you've already done some sort of processing and probably some basic grouping at that stage already. So we've started hypothesizing structures and things like that. But it's going to be very messy if we then decide to kind of skip the whole aim step instead, because then you're going to have gaps and you'll end up wasting more time refining the structure and correcting mistakes that you missed the first time. So actually, after the lecture would be when you do the aim step properly for the first time. So you see how this is actually quite different. In one situation where pre-study was there, the ideal situation, aim step forms at least part of that, if not all of it. Whereas in the unideal situation where you were just thrown into class or the lecture, then the aim step is kind of happening later. And again, that's not now the optimal order in which we should be encoding. So I want you now to progress through the rest of the stage, have a look at the examples, and really put this information and these steps in context. You'll see that when I'm doing the aim step, I'm not always doing it in exactly the same way. And for some subjects, it might look very different. But I want you to focus on the most important part, the trend, the similarity between them, which is that in every single instance, I'm scoping through the information, I'm exercising order control. I'm comparing and evaluating and prioritizing in order to hypothesize structures of learning. I'm building the scaffold. I'm building that basic relational network that net that provides me anchor points of relevance. So any new information that comes in from the aim step onwards is going to be more relevant because my brain is primed to connect with that information. As you get better and better at the aim step, you'll be able to do bigger and bigger topics. You want to aim to be able to do one entire topic in a single go. It will still take you time to do it, but it means that when you're pre-studying, when you're aiming, when you're priming yourself, you want to build a shallow but wide net because that gives you more possible anchor points and points of relevance. Your net is now wider. If you have a wide net that has holes in it and it's not too tight, and you try to catch some fish, yes, some fish will fall through, but you'll be able to catch a lot of fish if your net is very wide. But if you've got a very, very small net, but that net is like very, very tightly woven, nothing, not even plankton is going to escape that. When you put it in the water, you're actually not going to catch very much. Yes, you'll catch lots in just the point that you put the net into, but actually overall, you're not really going to catch much. And it's going to be a lot more work to try to do that. So we're always trying to build up that knowledge in layers. And this aim step is what creates that basic network. So consider that. Think about that and the type of thinking that I'm doing in each of the examples as I move through. Well done. You are on a roll. We're getting there. Trust me, these are so important to get as the foundations. And if you're just able to get this, things are going to get so much smoother for you. So if you're following along so far, even if you're struggling a little bit, well done at least for trying and getting that experience out there and getting some experience under your belt, because all of that is going to be great information and data for you to then crunch through and process and think, how can I make it better? And that's exactly the perfect formula for actually improving and getting there, okay? So good job for even getting this far. Now, let's really dig in to what makes the questions a higher level of quality. Because remember I said, not all problems and questions or applications are created equal. Well, there are definitely some types of questions and problems that produce much more learning than others. And in order to understand why these questions work, let's just do a little bit of a recap on something that we've already talked about, but framed a little bit differently, okay? So remember that knowledge, okay, information is only given meaning, is only given relevance, and therefore is only retained because of its relationship to other pieces of information, okay? It's the network effect here, right? The network, the web, that's what gives information meaning, right? This is what we call the structure. It's the structure of information that gives the information meaning and makes it highly retainable. Information without structure is easily forgotten. Without structure, you don't have memory, or at least you don't have good functioning memory, okay? And let's look at this in terms of a series of train stations, okay? So here we have a miscellaneous country or something, you know, this is land. And these red dots here represent cities or towns, places where people live. And let's say that each of these places, there is a train station, okay? Now, when you're learning passively, when we're learning passively, like the way that you might have been learning before this course, when you learn passively, you basically say, okay, this fact, this piece of information, this thing I've just learned, it's really important. It's going to come up in the test. So I'm going to focus on learning and memorizing this. And you invest a lot of resources, okay? You invest a lot of resources. What resources are we talking about? We're talking about the resources of time and energy, okay, and just calories to maintain that information. Precious, precious calories that your cave person brain treasures. We're investing it, and we're saying we're going to invest into this. And therefore, I want it to become a huge station. I want it to be such a well-developed station. I want this to be the next central station. I want people to go to the station just to take Instagram photos of it. We're going to invest all of that into making this station huge and awesome and extremely memorable and large. Okay, we want to develop that. But here's the thing. Let's have a look at this. Okay, let's say that these dots here, let's say these ones, these are the stations in major cities. Okay, these are the major cities. This is like the capital here, and then this is like the second capital. Okay, between these two cities, okay, there's going to be a lot of people moving back and forth, right? Definitely. And let's say here, this is like a beachside place, a really great holiday destination. So there's going to be connections going to and from there. Trains will want to go to there. Okay, everyone's want to go to this holiday destination, right? For sure, definitely. Let's say out here, there's like nothing. Okay, there's like one horse. Okay, and I'm sure it's an awesome horse. You know, I got nothing against horses, but that's kind of all it's got going for it. Weather's horrible. It's way too hot. There's nothing to do there. The people are all really unfriendly. You know, it's just there's no reason to go here. But you know, people still live here. It's a little local bakery. So yep, there's a connection that goes out from here to here. All right. And then over here is very similar. It's like a little rundown place, okay? And in order to get to there, you can take a connection there. All right, good. Good. All right, cool. So let's have a look at this. So we invested a bunch of resources into making this station really good. But who's going to come off at this station? Who's going to come off to see this one horse? Like I said, I got nothing against horses, but are we going to get a lot of traffic back and forth between this single line? Probably not, right? Probably not. And so those resources that we invested, they effectively went to waste. We had this huge station, 6 different bathrooms for 3 people to use at any given time. So it meant that we really overdeveloped it. We invested a lot, but we invested it and it went to waste. And it just doesn't get used. We can't afford to maintain this anymore. It doesn't have enough traction. We can't afford to maintain it. But we're not talking about money, right? We're talking about we can't afford the calories. We can't afford the energy to maintain this connection. So what will your brain do? Your brain, the resource manager, it's going to forget it. It's going to forget it, okay? Or at least it's not going to be as large. Which station, then, do you think your brain will invest more calories into? Which of these stations do you think your brain will invest more calories into? What station do you think your brain will say, this is worth it because of the fact, okay? It is worth keeping. It is worth developing and making it bigger because there are a high number of connections and there's a lot of traffic. Which station? Okay, these two for sure, right? These two, I mean, the major cities, right? There's a lot of connections to and from them. Definitely these two will be connected. And have you ever been to a major city where their main train station is like a tiny little shack? No, you don't. That doesn't happen. It develops because there are lots of connections going to and from it. They didn't create a massive station and therefore more people went there. It doesn't work that way. The station was big because of the fact there's lots of traffic to and from it. There's lots of connections. But what about this one? This one actually has quite a few lines going to it, right? So maybe this one will start developing a little bit as well. Maybe not quite as big as those major cities, but maybe this one will start getting bigger. So your brain is saying, look, because of the fact that there's so much traffic going to this, let's invest a little bit more resources into this station. And this really is exactly how your brain works when it comes to knowledge. Knowledge that is visited a lot, knowledge that is often used, okay? If the information is used often, if the pathway, okay, if it goes through that often, then it will develop that node, that train station of information, and it will get stronger and more memorable. Okay, it will get stronger and more memorable. So while most people think that you need to invest a lot of time and effort on developing a single station, it's not. What you need to spend time and effort on is developing the number of connections. So instead, let's say that we made a bunch more connections to this place is going to get much more traffic because there's a lot more connections to it. People are more incentivized to get there. As a result, this station will start getting bigger and better. And that's how it works, right? So it's actually the opposite. We don't have to focus on a single piece of information in order for that information to be more memorable. In fact, it's the opposite. We need to focus on how that information connects. How is it relevant to other pieces of information? And how can we make it so that we are able to use and go through these different nodes of information constantly, so we're getting a high amount of traction between every single node so that they're all reinforcing each other, okay? And they all become capital cities in a way. And this is where we can relate this to the types of questions that we ask. So the types of questions that we ask that are more like, what is this? Okay? When we're talking about what is the process? What is the definition? These superficial kind of what questions are much shallower, okay? Because you don't need to connect it to anything else. In order to learn what something is, it's very isolated, right? What is this? What is the definition of this? It's all very isolated. What questions don't tend to connect between different pieces of information or different concepts very often. Whereas questions that ask more about why, these tend to be more connected. So we ask questions like, why does this happen? Why is this important? Or even the direct question of, how does it relate to everything else? So these questions are really solid. They're really good questions to ask, because why does this happen? Why does this happen? Oh, it's because of this. Okay? It's because of this. Why is this important? Well, without this, you wouldn't be able to get this. Why is photosynthesis important? Because of, do you see how when you ask that question, we now need to think about the other aspects of a plant that make it important. Why does it happen? We now need to think about different aspects of the plant or chlorophyll in order to understand why it happens. How does it relate to everything else? See, these questions force us to think about the big picture. They force us to make these connections. And because we're spending most of our time and effort on the relationships, we're building a better structure, and therefore the information itself actually becomes more memorable. So in order for any individual fact to be more memorable, and I'm going to say this again, in order for any individual single fact or information to be more memorable, we need to actually not focus on each individual fact. We instead need to focus on the relationships. And as a result, as a byproduct, as a side effect of building such strong relationships, our brain will, I promise you, our brain will start retaining this information much more easily, much more naturally, and it will be even much more enjoyable, okay? So the thing with these what type questions, when I often ask students to make questions for the very first time, they tend to make questions that are just what. But on top of that, they tend to make questions that don't actually spark any curiosity. So remember before I said that there's a spectrum, a priority around the types of questions that your brain finds more relevant. The things that were emotional, personal, and you were genuinely curious about. Do you remember that? Those were the things that your brain finds higher priority. Those are the things that your brain finds higher priority, right? So things that were emotional, things that were genuinely that you found curious, okay, or things that were personal to you. These were the things that your brain found as higher priority. And it's just because simply your brain just cares more. And because it cares more, it's just more willing to make more connections easily. You're not fighting uphill. You're not like, make this connection with this fact. And your brain is like, but why? I just don't care. When you frame it in a way that just forces your brain to care, it just becomes easier. Okay. So these emotional, curious, personal questions, the skill required to make them is a skill that we need to learn. But when you're first starting, you don't have this skill, right? So what questions do you make instead? You tend to make questions that are more about just what is this answer? And we kind of already know the answer. So there's this TV show. It's actually a very famous show. You may have heard of it, you may not have. It's less popular now. And it's called Jeopardy. Okay, the show is called Jeopardy. And the way that the show works is that you've got a game show host that will ask you a certain piece of trivia, and you just have to guess the question correctly. Okay, really common format, right? They basically say like, this country is the largest land mass on Earth, and then the person who's guessing it has to make the right answer. Like, they're talking about the Antarctica or Russia, or So the way that this actually works, the game show, is that for whatever reason, the rule is that you can't say the answer as an answer. You have to, for whatever reason, you have to frame it as a question. So what the host does is they actually tell you the answer, and the the participants, they need to tell you what the question was in order for this to be the answer. Okay, so let's just say like, okay, George Orwell wrote the book 1984. Okay, so the game show host, they might say, this person wrote and authored the book 1984. That's what the game show host would say. And the contestants would buzz and they would say, not George Orwell. They would have to say, who is George Orwell? Okay, to which the answer would be the person that wrote 1984. So this is the kind of, I call it Jeopardy questions, where they know the answer already, but they're simply just turning an answer they already know into a question. It's really meaningless. So you might say, okay, photosynthesis is the process through which plants produce energy. So the question you'd have the keyword as photosynthesis. And the question would be, how do plants produce energy? And the answer is photosynthesis. So you can see that type of question, even though it's a question, it's actually not making you think about things in a different way. It's simply just repackaging your existing knowledge. And that doesn't make the brain think widely or think of relationships or think of connections or be curious, because you're not curious about something you already know the answer to, right? You're not curious about the question, what is your name? You're not going to be like, what is my name? What is my name? Tell me, what is my name? You're not going to have that type of thought, because you're genuinely not curious, because you know the answer already. So you don't solve problems to problems you already know the answer to. Okay? You don't activate the problem-solving mindset. Your brain, the checkbox, this solves a problem, it doesn't get ticked when the question is something you already know the answer to. So the best types of questions are ones that are why, asking how, and also that you genuinely don't know the answer to. So these types of questions, plus genuinely curious. This is the combination for questions that produce the highest amount of learning. So if we go back to that jigsaw example, you pick up the puzzle piece and you're saying, why is this puzzle piece important? Why do I need to know this? And how does this puzzle piece relate to everything else? You genuinely don't know. You're genuinely curious. You've got a picture that you need to fulfill. And therefore, you're going to
put it in place, as opposed to saying, what is this piece? Because that's just very focused on the piece. Did it help you put it on the picture? No. All you did is focus on what is it. And imagine if you picked up every single piece and tried to just memorize what that piece looked like. It would have no meaning. So it would actually be harder to memorize what that piece looks like compared to if you thought, how does it relate to the big picture and where can I fit it in? And by actually thinking about it that way, you would end up actually being able to memorize what the piece looked like. Even without trying, you would memorize what that piece looked like because you were looking at it so critically and constantly comparing it. You realize it doesn't fit here, it doesn't fit here, it doesn't fit here, it could fit here. The image doesn't fit here. It looks okay here. It looks even worse here. So in your mind, this has been connected from so many different angles. There's so many ways that you can remember it rather than just it in itself in isolation, just desperately trying to invest resources and turning this into a very high traffic station, a node in your brain. But your brain just doesn't work that way, okay? So these types of questions, the questions about why is this important? How does this relate to everything else? The ones that you genuinely don't know the answer to, these are the ones that are the best questions to ask. And actually, as a rule of thumb, I can say that if you ask these questions for pretty much every major concept, maybe not every single fact, but most facts, you will realize that initially, man, it takes quite a bit of effort to ask these questions. To get the answer to those, it takes quite a while. Okay, your learning is quite slow at the beginning because every single fact, you're like, why is it important? Why does it happen? How does it relate to everything else? And it just takes so long to learn that. And you're thinking, oh man, this is when you start to panic. You're like, oh, this is taking too long. It's taking too long. And this is usually where quitters will quit. Okay. But if you push through that, what you're going to see is that the next piece of information, you're like, oh, I know how that relates because I've got a really good connection, a good web, a good structure to base that on. And the next thing you learn, you're like, oh, that's actually really similar to the last thing I learned. And the next thing is, oh, that's actually really basically the same thing as what I learned over here. It's just a different example of it. Oh, and I can relate it to all these other points that you learned along the way. So what you realize is that eventually what happens is that it gets faster and faster and faster. So the more you think about these types of questions, your learning actually gets faster and faster and faster. And I can promise this to you, it's very, very consistent. But most people, they are in this part and they don't push through. They panic and then they just quit. They are too afraid to lose when they don't realize that the true risk, the true thing that they're losing is the opportunity to ride this extremely efficient curve. Okay, and so me knowing this and my students knowing that this is where you go to, this actually ends up being enjoyable because you realize you're just about to kick off. It's kind of that anticipation of the roller coaster before you plummet down. You get that feeling of anticipation where you're excited because you know that at any moment things are going to get much, much, much easier, and you will feel like you're really flying through the topic. It's a hugely liberating feeling academically, and it gives you a lot of confidence, and it just feels like learning is a lot more enjoyable and much more natural. And that type of feeling is something that I think every student should be able to feel. And this process of aiming correctly with asking these types of really good questions is the first step. It's the first step. And once you get on that first step, you're on the staircase, and all you have to do is keep climbing up. All right. So let's practice this a little bit more. Have a look at the ones that you've written, maybe questions you've written in the past even, and actually evaluate how many of the questions that I wrote were actually really high quality. Some students, despite everything that I've said about how effective it can be, would still not use the Bear Hunter system. And look, I get it. I get it because I was either in your shoes or I've worked with so many students that have been in your shoes. So here are the most common reasons and why it just doesn't make sense, okay? So the first most common reason is that it just takes too long. So often students will say, it takes so long to plan out my learning before I actually start studying. Okay? Now, here's the important thing. Again, I've mentioned this before, is that studying and learning is not the same thing. Studying and learning are not the same thing. So what do I mean by that? Studying is simply what you're doing. And if I read a book, if I write some notes, if I go to class, have I studied? Yes. If I read my notes again and write them out again, have I studied? Yes. Have I done meaningful learning? AKA, am I able to take that knowledge, have it in my head, recall that knowledge, and actually output it and express it fluently? Probably not. So which was the waste of time? You spent all this time doing this, and yet you still haven't actually learned it. It's not in your head. You can't use the knowledge. So this is a difference between calibrating yourself based on studying, the pages I've flicked, the words my eyes have seen, the number of words I've written down. Meaningless metrics like that versus calibrating yourself on things that really matter, the things that really matter to you. And what matters to you is that you actually learn it, because you need to actually have it in your brain in order to apply it in your exam. Otherwise, everyone that studies lots would just do well. And if it worked that way, okay, if just doing the more of what you've already been doing was the solution, you wouldn't be stressed out. You wouldn't feel so sometimes maybe even desperate or frustrated. You wouldn't feel like you don't know how to improve or break out of that spiral. And you would feel a lot more confident about moving forward. But if you don't, then that's a clear sign that the process you're using just doesn't work. You're focusing too much on the studying rather than the learning. And let me tell you is that the process of going through and finding keywords and then turning those keywords into questions that allow us to create curiosity that is going to make our brain a sponge so that when we fill that curiosity, our attention just goes through the roof. That process in itself is learning. We're not planning for learning. The aim step is not planning for learning. The aim step is part of learning itself. It's just the first part of learning. It's kind of like saying that turning on an engine is not part of driving a car. If you don't turn the car on, you are not driving anywhere. It doesn't matter how many hours you spend behind the wheel, holding the transmission, steering left and right, looking at your mirrors. It doesn't matter how long you spend doing that. You're not actually driving unless you've turned the car on. You're not actually learning unless you turn your brain on. So this is the first part of learning. So yes, it takes a long time, especially when it's new. But remember, just like any new skill, you wouldn't expect to be a professional soccer player after only practicing for a few hours. You wouldn't expect to be a professional violinist by only practicing a few hours. Heck, you wouldn't even expect to be a even moderately socially acceptable level of someone listening to you playing for violin after practicing for a few hours. You probably need to practice for months to get to the level where you think, you know what, I don't sound terrible now. And compared to that, this is much faster. Okay? So, does it take a long time to learn relative to other skills? Not particularly. Does it take a long time to start learning relative to mindless studying? Definitely not, because you could study for 20 hours before you actually start learning something the normal way. Does it take a long time to get used to? Again, relative to new skills that you've just learned? Not really. Does it take a long time compared to doing something that is mindless and takes no effort? Yes. But we don't want to do things mindlessly that take no effort because there's no point. Okay? So that's the first main common objection that students would have to using this, and this is a big reason why people would quit, is because they're too obsessed and fixed on these meaningless metrics of measuring progress by the classes and the pages and the papers and the words they read and the number of notes they write, and they look around and all their friends are writing lots of notes and they're like, oh, what do I do? I need to write more notes. And it's like, look, do they get perfect scores? Are they geniuses? because they've written the notes, do you think that they know everything that they've written? No. So you are even in a better position than them, because if you, who might not have written as many notes and gone as crazy as all of your friends, at least you know that it doesn't work. They don't even know that it doesn't work. You are one step higher than them on Maslow's hierarchy of competence. You have conscious incompetence. You're aware of the fact that you don't have the skill. They're not even aware of the fact that they don't have the skill, okay? So feel a little bit happier about that, okay? So that's the first thing. The second point, and the second concern that most people have or question is, why do I have to go through all of this effort? Why can't I just use existing past papers? Why do I have to put in the effort to make questions myself when I already have questions that are even in the exam format that I could use? You theoretically could, but it's a little bit of a nuanced answer, and I generally recommend, especially if you're just learning the skill, that you shouldn't. At least you shouldn't depend on past papers. And there's a couple reasons why, and they're both very important, okay? The first thing is that, I've mentioned this before, but the exam style and the way they ask you questions always changes. You never know the way they're going to ask you questions, okay? So if you're using practice exam papers to help you practice for the exam, if you already knew what was going to be in the exam, why are you not getting 100% for every test? Okay? The thing is, you don't know. And that's the point, is that you never know what they're actually going to test you on. So practicing based on past exams is just like an educated guess at the end of the day. The benefit of practice questions and past exams is that you get an idea of how they might test you. And years and years ago, that might have still been a pretty decent, safe strategy. But to be totally honest, more and more so these days. In fact, you can see it on the news sometimes even. Students are getting curveball questions, often worth lots of marks, that are very different to the ways that they have been assessed previously. And I've seen this internationally, so I'm not sure what's driving the change, but I think there's a shift in the way that people are trying to assess, and that they're trying to do more and more curveballs to see who has just memorized all the top layer stuff by doing hundreds of past papers, and who has actually really spent the time to learn it properly. And I think test creators are starting to get smart to that. So assessments are aggressively now changing in the way that they're being styled. So for me, I don't feel that it's safe anymore. 10 years ago, I probably would have said it was much safer, but with what I've witnessed over the last 10 years and what I predict moving forward, I don't believe that that's safe anymore. I do think past papers have a good utility in that they help you generally get a style of how they might ask you questions as a general ballpark, as a very general ballpark. But apart from that, I don't honestly think that they're very useful. And here's another reason how you know that it's not the solution. Because using past papers is a strategy that everyone uses. Like literally every single student, sometimes the only thing they do is just go through past papers. Some students, 99% of their learning is just from doing past papers. If past papers was a solution, everyone would do well, okay? It's the strategy that everyone uses. So if everyone uses that strategy and you're trying to be in the top 1%, how are you going to differentiate yourself? Okay, so it's just doesn't make sense from that point of view either. So it's a common strategy. If it really worked, then you would see everyone do really, really well. And that's obviously not the case. So that's one aspect of it, is that yes, it's common and it has been safe sometimes in the past, but really it's, I think, a very risky way to depend on. And, you know, if I say to you, there's a 20% chance that you're going to get questions that weren't in the past papers, that's a pretty high percentage. I don't know, like, do you feel comfortable putting all of your eggs in that basket and saying, oh, I'm not going to learn this incredibly effective skill because I could rely on that to 80% or so accuracy, and you're trying to get like top 99%? I don't know about that logic there. So the other aspect is that this ability to create questions is actually a skill in itself. So if you just keep relying on past paper questions, you don't actually develop the skill. Your brain, again, is very energy efficient. It tries not to invest in anything that it doesn't need to. So if it knows that there's past paper questions that you're using, it's not going to develop the skill of creating questions. It's kind of like if you live a really privileged, sheltered life, you've got butlers serving you. Every time you're hungry, you just say, food, deliver it to me. Okay, and within 15 seconds, you've got perfect meal in front of you. Every time you need to go to the toilet, you say, I need to toilet, and then you get swiveled over there. Okay, you wouldn't expect someone like that to be independent. You wouldn't expect them to have this huge ability to go out and live out there in the world by themselves, right? Because why would they have developed that skill of independence? Where would they have developed that from? Same thing is that if we have a crutch on past paper questions, if those questions aren't reliable or if they're not as available, and generally speaking, when you get into university, there is a lot less past paper questions and they're a lot less reliable. So you don't even want to be relying on them anyway for most degrees at most universities in the world. You actually don't have that option. And at that point, if you don't have the skill to create your own past paper questions and your own questions, you're really going to struggle, and you're probably not going to be able to develop the skill fast enough, and you simply just won't do as well. So that's another big weakness, and actually that's the most important one. You don't develop this really critical skill because the ability to create curiosity in things that even you might think is just really boring subjects, the ability to do that is actually a hallmark feature, as in it's a feature that is characteristic of a high-level learner. In fact, to the point where I'd say that I don't think it's possible to be a high-level learner, and certainly the research suggests this as well. I don't think it's possible to be a highly efficient learner if you don't have the ability to create curiosity, okay, and create and find curiosity. That is a skill in itself that you need to develop, and it honestly doesn't even take that long to develop it. It's just so worth it. And then the final aspect is because the questions that you cover in a past paper, if you already know the answer to the question, you're not getting more learning out of it, right? Like I said, if I ask you a question and you know the answer already, you get a little bit of benefit in that you're kind of just like reinforcing what you already knew. But you're learning the most in terms of the time you're spending. You're learning the most when you find a question that you don't already know the answer to. So you're kind of doing past paper questions in order to, number one, make sure that you know what you know. But the most important thing is to find the things you don't know, right? Like if you studied for like 2 hours and you had a big test coming up and you did some past papers and you're like, oh, I got everything right. You should be a little bit suspicious. You should be like, I only studied for 2 hours. How is it that I got everything right? Because you want to find gaps, right? You don't want to just be like, oh, therefore I must know everything. Because that's like probably unlikely. So you actually want to be in a position where you're finding gaps and weaknesses. And the thing is that our brain has a sensor, like a radar for gaps in knowledge and weaknesses and weak points, things that you don't know as strongly. And that radar is actually our sense of curiosity, okay? So the aim step, which is to create and find curiosity, is actually us tapping into our internal radar for where the gaps in our knowledge are. So it means that because we're deliberately creating questions and problems that we genuinely don't know the answer to, especially ones that are highly connected, it means that creating one question actually ends up making us revise multiple different points simultaneously because we're trying to make them connected. And because they're questions that we genuinely don't know the answer to, by nature, the questions we create are actually our weak points and our gaps and our limitations, which means that if we spend 1 hour answering the questions that we have made, that entire hour is spent purely on being better at our weakest points. If you spend 1 hour just doing practice papers and questions, you potentially would only encounter 1 or 2 gaps. And they may just be isolated gaps. They may not even connect to other things. So you might have a gap here and then a gap all around this, and you just would miss it completely if the question didn't ask it in that way. So it's very different. So it's much safer, and it's actually much more time efficient to go looking for the gap yourself and then study everything around it, because it's just a more efficient use of time, but also because it trains your brain to be able to find these gaps. The downside of that and it's a very small downside, is that sometimes you find a gap that's not really relevant for your course. So if you're studying like chemistry and you've got a certain type of reaction, and the thing you're curious about is, how do I use this reaction to diffuse a bomb? Then it's like, okay, it's great that you're curious about that, but that's probably not going to be assessed at all. So, if you were to then go pursuing that, it might not be a great use of your time. But the reason that's not a very big downside is, number one, we generally have an idea about what is and is not assessed. So we can, if we're way off, we can just kind of be like, maybe that's not a great question, and we can bring ourselves back. That's the first reason, is that we kind of have common sense. And the second thing is that it's actually good to go a little bit outside the scope of what's purely in your curriculum, because it actually helps you learn the things that are in scope a lot more. It's kind of like, if you need to know this much, if you know a little bit more, then the inside curriculum stuff just becomes that much easier. And if you sort of think about when you're making connections, you've got a connection here, and that connects to this thing. Okay, great. You've made a connection. Okay. And you've got a new piece of information, like a fact or a concept that comes in, and you're going to connect it from here. Okay. The more connections you can make, the better, right? So you want to connect it from this way, and you want to say, oh, it relates to this thing as well. And I remember last week's topic, we learned about this. Oh, that's also related to this. But when we get to the fringes of knowledge, the stuff that's like the most difficult or the most specific, then by only staying in scope, we limit the direction at which we can approach it. So we might only be able to make one or two connections. But if we let ourselves go out of scope a little bit, we can actually say, oh, we can actually connect it from this way. So we actually find more ways to connect it. And the time it would take to go a little bit outside of scope of curriculum, a little bit, like 10% outside the scope of your curriculum, the time it takes to go out of scope is actually less than the time it would take for you to just relearn it because you're forgetting it. Because when you go out of scope, you can actually make more connections that way. And so you learn it better. And so your retention goes up. And so your efficiency goes up, right? And so you're not forgetting it, and you're not wasting time relearning it. The time it would take to relearn that, if you were to forget it because you didn't have enough connections, because you stayed in your scope, that time is actually longer. So it's actually better to go a little bit out of scope in order to learn the material more strongly. It's actually faster. And that's counterintuitive. So I really dislike it when you ask a teacher a question and the teacher says, oh, that's not examinable, don't worry about that. Because I think teachers have a very strict kind of cutoff. Some teachers do, at least. But actually, and the research is consistent with this as well, it's actually better to go a little bit out of scope to learn the material, as long as you're not going way out of scope. And again, how do you know if it's way out of scope or kind of in scope? It doesn't actually matter so much. You just have to keep track of how much time you're spending outside of that scope. If you're spending 1 hour outside of scope just to consolidate one point, that's probably not a good use of time. If you're spending 5-10 minutes learning about something that's not examinable, that allows you to learn this, then yeah, that's probably worth the time. Okay. So again, we've got common sense. We can actually use this, okay, to our advantage. So it's a small downside, but ultimately, definitely well worth it. So those are two of the really common reasons why people wouldn't use this. But actually, neither of those reasons actually makes any sense, especially if you're trying to get more study done and get higher grades in a shorter period of time. Not doing it because of those reasons is exactly the reverse. It would actually make things much worse. So two really common issues, and also the reasons that it's completely illogical.
Let's now do another demonstration of the curriculum that we went through way back in fundamentals, but we're going to do it with our upgraded techniques. Now, before we jump into the demonstration, there are a few nuances about the technique that we really need to be aware of. First of all, back then, it was enough just to find some groups and to start chunking information in some basic ways. But now we've started to understand how questioning can affect the way that we view information and the type of processing that we can do. So it's no longer enough just to create groups and to have chunks. Instead, we need to have the best chunk possible. And that may not necessarily be the objective best chunk possible, but it needs to be the chunk that we feel the most comfortable with. And that means that the chunk needs to feel logical and intuitive. And I'm going to go through a flow chart in terms of how we know whether something is logical and intuitive, because those two words are actually very, very important. And a lot of people misunderstand them. So the goal here is to use that importance-based questioning in order to find the best possible chunk. And often you'll see that there are multiple possible chunk structures that are comparing against each other. And so what I'll do in this demonstration is I will go through and I will talk out loud my thought process. And you will see that I am comparing multiple chunk structures against each other. And note the wording I use there. I'm not just comparing different chunks with one another. I'm comparing different chunk structures with one another. And I'll go into that a little bit more later when you see it. Now, another thing is that because of the fact that this demonstration will have a lot of nuanced points in it, you'll get to see my thought process and how I process this information. But you're not going to pick up on a lot of those nuances if you don't already have some experience with this technique. So if you're coming to this video straight after watching the Ascent 1 videos and you're fresh off that boat, then I would recommend that you actually get a little bit of experience first using the technique the best way that you have understood it so far, at least just for a 2 or 3 hour practice block, and reflect and do at least just one code cycle on the pertinent issues and the problems and the difficulties that you faced, the areas that where you are uncertain about. Because if you watch this video without having done that, if it were me, if I know I've already watched the video and then I go through and I feel like, that video could actually be helpful again, I would feel a lot less likely to watch that 1 hour video all over again. So to get the most value out of your experience from watching this the first time round, it's going to be a lot better if you give it a go first, make a couple mistakes. You don't have to practice for like a whole week first, just maybe a couple of hours of making some good solid mistakes and reflecting, and then come back to this video and then you'll see how my thought process might be subtly very different from yours. But again, if you haven't made that mistake first, it might completely just fly under your radar, and the biggest value that this video can give you could just be completely lost. So if you've had that experience, feel free to go ahead. If you haven't, pause now, go back, and we'll see you again soon. And if you're still here, presumably you've already had that experience and we can keep going. The important part that I want to really focus this on is the standard to which I hold myself to when I'm comparing chunk structures. And that's the thing that I want you to really focus on, is the standard and the level to which I'm pursuing creating the ideal optimum chunk structure. I want you to pay close attention to not just the technique that I'm using, but how far I pursue and persist that logical and intuitive standard of chunking. Often when students are really struggling with the technique and they're feeling that their chunks are not giving them the retention or the mastery of knowledge that it's supposed to give them, and we do a deep diagnosis, then we find that in most cases, it's not that they didn't have the right technique, it's that they didn't use the technique extensively enough and they didn't compare enough chunk structures with each other. So I want you to pay attention to that when we get into this demonstration. So without further ado, let's get into it. So as before, we're just going to start here with the curriculum, and as you already know, we've got the concepts list that we can use. So before in fundamentals, we got that very basic concepts list, we got that very basic chunk structure, and now we're going to take that to the next level. So here's what I'm going to do. The first time around when I'm going through the information, this could be a pre-study or a priming session, I'm going to make sure that I have a good importance-based method of chunking. Now, I mentioned that it has to be logical and intuitive, the chunks that we end up with. If your chunks are not logical and intuitive, it means that you're going to have to spend more time and effort and cognitive resources to memorize them. So think about it this way. The way that you chunk the information either makes sense to you logically and intuitively, and therefore it aligns with your prior knowledge structures and networks, and therefore you will perceive it as being logical and intuitive, and therefore you won't have to exert so much effort to memorize it. However, if your chunk structure does not align very closely with your prior knowledge, then you now need to spend additional effort to remember the chunk structure. So now we're adding more things for us to memorize. And if we forget that chunk structure, then the benefit of chunking it is reduced somewhat. So how do we know whether something is logical or intuitive? Well, here's a very key point, is that just because something is logical doesn't mean that it's intuitive. The opposite of logical is obviously illogical. So if you think about an illogical chunk structure, that could be, for example, deciding to chunk it all based on the ones that have the letter G. So this one would have a letter G, this one's got a letter G, this one is G, oh, this one has a letter G too. So you can see that this is a very meaningless method of chunking. It's not very logical. I mean, I guess it is logical in a way, but it's very clear to see that that's not going to have much of a beneficial effect on our memory. The chunks that are often given to you in a textbook tend to be logical. They always tend to be logical, because if it wasn't, it would be illogical. You see where I'm getting at here is that most chunk structures you encounter are actually pretty logical. So it's not relevant really to think about whether the structure is logical or not. We have to think about it as whether it is logical and intuitive. So that word intuitive is key. What we're talking about there is what I just discussed, the idea that it seems so obvious that you don't even have to memorize it. So examples would be something like cause and effect, before versus, if you thought after, that means that that chunk structure was intuitive. If I said up versus, did you think down? In that case, that chunk structure is intuitive. We're always looking for chunk structures that make it seem as if it's so obvious that we don't even have to remember it. That's the ideal goal. It's not always possible to do that, especially for some subjects that are really, really technically heavy. However, it is possible in most cases, and you'd surprise yourself. Even with really technically heavy topics, you can also make things more logical and obvious by relying on your prior knowledge in that domain. So it may not be obvious to someone else, but it could be obvious to someone that has a reasonable level of domain knowledge. So going back to my background in medicine, if someone said to me, history versus investigation versus, then for a normal person, that may not really lead them anywhere. But for many medical people, there are only a few things that would logically and intuitively come after that. For example, management or treatment. And so this brings me to a very nuanced point. You'll notice that in the instructions on how to do the chunking, we talk about the idea that you should create chunks first. You should look through the information and try to create some of the most obvious chunks. However, what I've noticed is that people take this a little too far, and they're not just making the chunks that are really obvious, they are committing to chunks that may not actually be that obvious. So, for example, an obvious chunk structure like problem versus solution maybe, that would be something that is an obvious chunk structure. However, even though we could arrive at an obvious chunk structure, it doesn't mean that we need to, in fact we shouldn't, commit to it. Because that chunk is only a hypothesis that we are then going to validate through our inquiry anyway. If we commit to chunks based on the headings that are already in textbooks versus the chapter names and terminology that's already given to us, and we don't do the chunking independently, then that's going to make a chunk that is probably too technical, too terminology heavy, and therefore requires us to memorize it. It may not be intuitive enough, and therefore we'll just forget the chunk structure. And it probably will not really include all of the relationships we want to demonstrate either. So we're going to have all of those spider webbing, waterfalling kind of structures where there are lots of relationships going everywhere. And it's going to be a mess to try to consolidate because really they should have been chunked differently in the first place. This is something that is influenced by what we call framing bias. Framing bias being the way that the information is presented to you, affecting the conclusions and opinions that you have of that information. So if it's given to you in the textbook in a certain way, we're likely to think about it in a very similar way. And that's why with the concepts list, we do it out of order. You should be aware of that process by now. But we can create our own framing bias. If we take a list of words and then we chunk them too in depth with chunk structures that are not intuitive and obvious, then that is something that we call pre-chunking. And that is when chunks are created before the process of inquiry, before we ask the why is it important question. And the reason that that is an issue is because if you create the chunks before you asked the importance-based questions, then that is likely to make the chunks not importance-based. It's quite logical, right? However, now that you've already chunked it that way, it predisposes us to being biased, and now we think about it in those same chunks, even if those chunks are not actually optimal. Pre-chunking is not necessarily always a bad thing, and in some cases, it can be an effective tool, but we have to make sure we're not committing to those chunks, and we're only using the most obvious ones. So here is a bit of a flow chart. First, we ask, is the chunk that we're thinking about logical? If it's not, don't chunk it. If it is, then is it intuitive and obvious? Again, do we feel like we're going to have to spend any effort to actually memorize and remember this chunk? Or is it so intuitive and obvious that really anyone with either no prior knowledge or just a small amount of domain knowledge would be able to kind of predict and guess that chunk? Really, it has to be obvious. If the answer is no, it is not, do not chunk it. And if in doubt, do not chunk it. If it passes all of those checks, then we can move on to importance-based inquiry. However, even when we're going through and asking those importance-based questions, why is it important, how is it related, if we find that the way that we've chunked it is not aligned with the reason for importance, then we need to change the chunk. So when we're doing this, we will find that it is either aligned or it is not. And if it is not aligned, then we need to break the chunk. We need to re-chunk it a different way. And if it is aligned, then we can keep it. Most of the time, we will actually end up breaking it. So if we're going to break it most of the time, why do we even do this step in the first place? Why even give us the risk of pre-chunking in the first place? Because it can actually help us to think about things a little bit more deeply. And I'm going to demonstrate that very shortly. So let's start with the concepts list as usual, and I'll go through to make some of the obvious chunks that I feel like I could start with. Okay, so there are a few chunks that I think could be quite intuitive here. One is the idea of theory versus application. So going to application. And the other one, I could think about it in terms of practice, like practicing to get better at something. Practice leading to skills. And then I could think about I could potentially also add outcomes onto that as well. For example, retention and retrieval could be considered outcomes. I mean, it's a pretty small, if it is a chunk, it'd be a pretty small chunk because there's only two things in there. But it is quite logical. Practice to skills and then skills lead to outcomes. That seems really logical. So I think I'll leave that for now because I'm not so convinced that I want to keep that in there. And there's also the idea of sort of there's clearly sort of things here in terms of self-management. So that seems like a pretty good one. Now, even if I feel that self-management is a relatively intuitive chunk, why am I not committing that down? Or why am I not committing, but why am I not even writing that down? Because I'm not focused on chunks, I'm focused on chunk structures. A chunk in itself is not intuitive just by itself. So, for example, the chunk before is not in itself intuitive. But when we say there are two chunks, before versus after, that now becomes intuitive. You see, the intuitive logical nature of the chunk structure depends on the other things in that chunk structure. So for example, even the stupid example we gave at the beginning, like chunking everything with the letter G, that would actually be intuitive if the other chunks that you had, for whatever reason, if that actually made sense, were things that didn't have the letter G. Then things that did have the letter G would actually end up being an intuitive chunk structure. Now, whether that is actually meaningful in this situation definitely isn't, but maybe there are some situations where that type of chunk actually would be meaningful. But the idea here is that it's not enough just to say, this is a chunk that makes sense because it allows me to hold on to all of this information. The chunk can't be viewed in isolation. We have to be thinking about its relationship with other things to think about whether it's intuitive. So I know that these things are to do with self-management. So if that's self-management, what's another chunk? And it doesn't have to be everything else combined in another single chunk, but at least some other component of it. I want to see some other chunk structure. And I'm happy to put something down as long as I can see kind of 2 different chunk structures, or 3 if I'm lucky. So if we have self-management, and then another thing we could have, I guess, is, well, there's self-management, and then there's also kind of the more studying related skills. So there would be self-management skills, and then there's kind of learning related skills. So that'd be sort of self-management versus learning. Now, that's a chunk structure that for a lot of people probably wouldn't feel intuitive. For me personally, obviously, because of the fact that I teach this constantly, it is actually fairly intuitive. So for me, I'm actually quite happy to put that down. But if this particular chunk that didn't feel intuitive to you, then you wouldn't put it down. Remember, because this flowchart, is it intuitive and obvious? If it's not for you, then you wouldn't chunk it. So for me, it is. So I'm gonna put this down here as kind of like this general sort of hypothetical potential chunk structure. So I've got a few chunk structures that I feel I could work with. Now I have multiple, and this is already a step that most people don't do. I've got multiple chunk structures, and all of these are hypotheses. So what do I actually do with these? I'm not going to go ahead and build that backbone straight away. I'm not going to go ahead and create this elaborate mind map straight away. No, all I'm going to do is I'm going to use these as kind of just springboards for thinking, just to speed up my thought process and that higher order thinking when I'm going through each of the words. So now I'm going to go through that next step, which is really going through and asking, well, why is it important? How is it related? And I'm going to make sure that my chunks are importance based. It will either fit in with these different chunk structures that I've hypothesized and extend off of them, or I might end up combining them together, or I may end up discarding these altogether. And even if I were to discard these chunk structures altogether, it wouldn't have been a waste of time, because it allowed me to help facilitate higher order thinking. I was able to do that comparative thinking. Even just the thinking involved in thinking about these possible chunk structures, that's already starting to engage some higher order thinking. So it's a win-win situation here. Well, there is a way you can lose, and the way you can lose is if you commit to these chunk structures rather than truly going through proper importance-based questioning. So now let's start importance-based questioning. Now, I could really start anywhere that I want with this topic because I'm familiar with the topic. You're going to be familiar with different topics at a different level. So if you aren't familiar with the topic at all, and none of the keywords feel like you resonate with that a little bit more strongly, then you may as well just start at the beginning, because it's a logical place to start. But if there is a keyword that you feel you've got a little bit more knowledge about that, and you feel like you've got an understanding about some of those relationships already, then you can just start there. It doesn't really matter what order you're starting in, because at a certain point, if that starts to no longer make sense, well, then you can always go back and start at the beginning anyway, and you can just meet up in the middle. You can fill it in either way. Knowledge doesn't have a beginning or an end. It doesn't have a start and a finish. It's omnidirectional and it's non-linear. So it doesn't really matter where you start, because you're going to grow out organically anyway. And if there's anything that you missed, you can always go back and fine tooth. You can always go back with a fine-tooth comb to sweep through the information to see if there's anything that you missed. So you don't have to worry about missing anything, because especially right now, the main idea here is just to build this backbone. So I'm just going to start from the beginning, because it doesn't really matter for me, and I just feel like I may as well. So I'll start from the beginning here with the first word, which is the research practice gap. Now, I'm going to demonstrate what I would do if I had no idea what this is. However, I'm not going to do the same thing for every other keyword after this, because just to save a little bit of time. But for you, you would be doing this process basically every single time, unless you came across a keyword that you already pretty much knew what it meant, which can actually happen a lot of the time, especially for topics that you're stronger on. So research practice gap, let's assume I have no idea what it means. Okay, where did I see this? Where did I even collect the keyword? Obviously, we have given you the concepts list, but in real practice, where would I have collected that keyword from? Maybe I remember seeing it in a lecture. So I may go back to that particular point in the lecture and I may rewatch that. Or in reality, for me personally, if it's a long lecture and I can't exactly remember where it was, I'm not going to spend 3 minutes to figure out exactly when they talked about it and another 4 or 5 minutes watching, either side of it to get an understanding of it. This just takes too long. I'm going to look through the other types of documents. So here's the summary document. So I'm going to just search here for research practice gap, and it's not on the summary document. So I'm going to check on the textbook, the report on learning, and I'm going to search for research, and I can see that it is coming up here now. So there's a sentence here that talks about research practice gap. I'll just read that. So the idea I'm getting here is that there is, decades of delay between new research. There's a diagram here as well. I'm not going to read through the entire thing because, it's just too much. I mean, I know what's on it, obviously, because I wrote it, but assuming I didn't know what was on it, I'll just skim through. There seems to be there's some kind of problem, and there's just research ethic funding. I'm seeing the word funding in there. There's years in between. Okay, so I can see there's some time that's going on, blah, 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 and then mainstream practice changes in alignment with new recommendations. Okay, so there's this idea is that a problem is identified, and then practice is changing. So the research practice gap is basically talking about the gap between research happening and then practice happening. Okay, so now I understand it. So, and that's it. That's all I need to know, right? So that process of just looking through the resources to get a general understanding of what it meant, it will probably take you just as long, which is not very long. I don't know, what was that? Really, between looking through these resources, it's 30 seconds. In fact, it might even be faster for you because I had to actually speak out loud. So it's a very, very quick process. I wouldn't really be spending more than kind of a minute or two for each keyword. If you're having to spend more than 2 minutes for a keyword, you're probably just better off moving on and then coming back to it later if you really want to. I'm going to go back to the concept list. So now I know what research practice gap is. So why is the research practice gap important? Well, I guess it's important because if I look back at my chunk structures here, well, that could potentially explain some of the differences between theory and application. So could it be that research practice gap is sitting here somehow? There's not really anything else that I can think of there. And I mean, it's the first keyword anyway, so we're not going to get light bulb moments straight away. So let's just move on to the next one. Insight limiting. So just for the sake of the demonstration, I'm actually going to skip this, and I'll just show you that it's okay for me to skip this. Fade. In fact, I'll skip both of these just to show for this demonstration, and we can always come back to it. Knowledge schema. Okay, why is knowledge schema important? Now remember, I'm not going to go through that process of looking it up again or Googling it or whatever it is. I'm just going to, from this point, assume that for each keyword that you don't know what it means, you're going to go through, you're going to quickly look at it, spend a minute or 2 minutes at most, just getting a general understanding about it to wrap your head around it so that you can really answer the question, why is it important? But remember, you're never reading about something, you're never trying to consume information just for the sake of consuming information. Don't get sucked into the detail because otherwise it's going to take you forever to get through this list. Only read it for the sake of understanding why is it important and how could it possibly be related to everything else on the list. That's all you need to know. You don't need to know anything more in depth. So knowledge schema. Okay, so I've done my research. I know about it now. Why is that important? Okay, well, if I look back here at my chunk structures, knowledge schema. Well, I can imagine that knowledge schema is, well, it's important because of the fact that the knowledge schema affects the the retention that you have and the quality of the learning that you get. So that doesn't really fit in here specifically. So this is the genuine process. It's like I'm thinking about what I've got, and I'm thinking about whether it fits or whether it doesn't. And I'm thinking it doesn't really fit very cleanly, at least, but I've got some ideas. For example, I know that knowledge structure is going to affect your retention and your ability to retrieve it. And I know that those two words come up here as well from before because I scoped it. And I know that that's going to have some connection with the learning side of things, but really this chunk is actually talking about learning skills, and then these are self-management skills. So it's not really that same chunk. It's kind of a different chunk. So I'm just going to leave this idea. I'm just going to park it, and let's just continue to move on. Again, we've only covered 2 keywords at the moment. There's not going to be a lot. Analogous relationships is the next word. Why are analogous relationships important? Analogous relationships are important because they are a method through which it helps you to generate chunk structures, right? So analogous relationships. And now I'm thinking, well, how is it related to the other words? For example, how is it related to research practice gap? Well, it's not really related to research practice gap. Well, not directly at least. So there's nothing that I'm seeing there, and I'm looking at my chunk structures again, and I'm thinking, does that fit in here somewhere? Analogous, right? It kind of does, in that the ability to find analogous relationships and to utilize analogous relationships is kind of a learning skill. So it sort of fits into here, but it's a little weird. It's definitely not clean. I'm not really happy with it. So I'm just going to park that, and let's just carry on with the next one. The next one here is interleaving. So why is interleaving important? Well, interleaving is important because, well, I mean, it also helps to develop strong knowledge structures. And I guess in a way, it's also a learning skill. It's also a learning skill as well. And it's related to is it related to the research practice gap? It's not really, not in the sense of, like, not in the context of how this topic is framed. And it's obviously directly related to retention and retrieval, but I'm kind of already expressing that relationship because it's kind of passing through knowledge structures. So it's implicit. Like, I don't have to show, like, I don't have to do that unless it wasn't very obvious. But right now we've already got like this kind of pass through going on here anyway. So I don't have to add that. So, yeah, that's pretty much that one. So let's move on to the next one. Spaced retrieval. Spaced retrieval. Why is spaced retrieval important? Spaced retrieval is important because it is what allows you to maintain your knowledge structure. And that's the thing that allows you to have that good level of retention. So it's basically maintaining this. So now what I'm thinking about is I've got the word maintenance. And I know that spaced retrieval is going to sit inside that, like, sort of, conceptually at least. I'm now thinking about how that would actually fit together with this bigger picture, because there's a couple of things that I'm thinking about, right? Is that this allows you to have better retention. But the reason that allows you to have better retention is because of the fact that it's sort of consolidating and reinforcing your knowledge structure. And I'm thinking, do I want to create some kind of chunk structure where retention is directly linked to this idea of maintenance? Or do I want to get rid of retention and actually just call it maintenance and then have retention coming off from that? Or do I want to have maintenance leading directly to knowledge structures as an arrow? I'm not entirely sure what I want to do there. I know that there are multiple options. And I'm also starting to see that, well, spaced retrieval and interleaving are related to each other as well, right? Because in your spaced retrieval sessions, you should be doing your interleaving. And so that there is a relationship there, and that relationship is rather important. But that also kind of doesn't really fit with anything else that we've got either. So that's starting to get a little bit more complicated in terms of how do we actually fit those things. So, spaced retrieval is not really like, it's not really a technique in the same way that interleaving is a technique, because interleaving is a technique that you're applying kind of during your retrieval session, whereas space retrieval is kind of the planning of those retrieval sessions. So it feels a little bit different. So right now, what I'm thinking about is how can I make that fit? Like that's literally what I'm thinking about. I know why it's important. I genuinely understand why it's important. And I'm just trying to think, what's the best chunk structure that would represent that importance in the best possible way? And you can see that already. I've already talked about a few ideas that many other people would just be like, yep, that's good enough, and they just lock it in and then just move on. But I'm not happy to do that. I really want to create a chunk structure that feels like it makes the most sense. Okay, I'm just going to leave that for now. I'm just going to leave this on the side for now, and then I'm just going to move on to the next one. I'll see if I get any other ideas. The spacing effect, well, that's kind of the theory that allows a space retrieval to be effective. So that kind of fits into here in terms of like theory. I don't personally even know if I even need to have spacing effect as a separate thing, because it's actually so obvious if I understand space retrieval. So I think I'm not even gonna. I think, you know what? I think I'm just gonna remove that entirely, because I feel like I'm not gonna lose any value from getting rid of that, because it's already implicit within space retrieval. But it is interesting, because the application, if I put spacing here as a theory and the application is here, that's quite different to other kinds of application that the research practice gap is talking about. Because the research practice gap is talking about applications that are like at an institutional level, whereas this is kind of like an individual level. So actually, maybe it makes sense to say that there is kind of like an individual level versus a... So here, again, I'm trying to think of the most intuitive chunk. So if one chunk is individual, the other should be... Right? That's how I'm thinking about it. I'm not just thinking what is the best, like what is a word that would summarize it. I'm thinking, how do I make it as intuitive as possible? If it's individual, I want to think about something as like individual versus group. But group is not really the right word. So I'm going to use a word like system. So individual versus system. And so there's different types of applications for individuals and different systems. So that's like an interesting kind of extension of this chunk structure. And I don't know how that's going to fit together yet, but I'm just noting that down anyway. The next one is micro-learning. Okay, so micro-learning is important because it's kind of just an entire sort of strategy. It sort of sits above all of this, because it's about using spaced retrieval and interleaving, and it's about doing that in a time-efficient way. It kind of looks at self-management skills as well, and it looks at sort of scheduling and time management. So there's a lot of different things that are going on here. So I'm already thinking that, you know, if I highlight in red all the things that I feel like micro-learning would be related to, then it just becomes it becomes huge, right? Look at this. It'd be this and this and, you know, this and this. And, you know, retrieval as well. So how am I going to fit all of that together within microlearning? So I'm thinking that so microlearning is kind of like a macro level strategy. You know, it sits above this. So I might have one that's called strategies here. And again, I'm not really sure where this is leading to, but I'm at least just sort of thinking about, I'm holding on to the ideas. And the more you do this and the better you get at it, the easier it is to just hold on to multiple different ideas and chunk structures at the same time and compare them. So micro-learning, I feel like would be a strategy here. But the thing is, right, is that if I put micro-learning as a strategy, are there any other strategies? Like, would anything else fit there? Because if micro-learning is the only thing that's going to fit inside this chunk, then that's not actually a very good chunk. I'm just trying to see if there's anything else that kind of is like an overarching strategy like micro-learning is. So the only other thing would be kind of like the methods of practice that I talked about. But then there is this really great chunk structure here that makes so much sense in terms of practice leading to skill. And that just makes so much sense. I want to be able to incorporate that. So if I put practice strategies underneath here, then that's going to make it really messy, because now I've got a practice strategy, which is meant to lead to skills, but then that is going to sit as like another strategy, like encompassing these skills. I'm not really sure exactly how I'm going to, how I would show that. Another one would be note-taking, though. So note-taking, which happens to be the next word, just by coincidence. Note-taking is something that is important because it's what facilitates your ability to do like kind of all of this stuff. But it's different to micro-learning, because micro-learning is, you know, again, it's about that sort of scheduling. It's a bigger picture view of it, as opposed to note-taking, which is sort of just, you know, what you're doing in that. It's kind of like interleaving in a way that it's what you're doing during the time to facilitate the other skills. So I wonder if, I feel as though you could possibly link together interleaving and I'm hypothesizing the idea. Could we put interleaving as a strategy and microlearning and note-taking as a strategy, as strategies, and put them in the strategies chunk? And then create a relationship between strategies with the knowledge schema. But then analogous relationships comes in as well. And that, I guess, is technically also kind of like a strategy as well. So now it's starting to get a little bit messy, but because like microlearning and analogous relationships are really different from each other. So it doesn't feel right to put them in the same chunk. So it doesn't get more real than this. You know, I'm really thinking back and forth. How could I make it make sense? And I just want you to focus and notice like how much attention I'm placing on just creating what I think is like the ideal, best possible chunk. And this is really the value of it. If you're doing this for pre-study, you wouldn't necessarily have to go in as much detail as I am right now. You wouldn't have to go through, for example, every single word. You could just pick the words that you feel like kind of the most important. You could just go through a little bit more briefly. You wouldn't have to really be sure if that is the best chunk structure. You could just get to a couple of chunk structures that give you an idea about how it works, and that could be enough, you know, and that will take you much, much less time. But I'm sort of showing you the sort of perfect way that you would be able to do this. And this is what you'd be doing when you're actually sitting down to properly study it. Or if you did, you know, for example, this like a topic that's this large in reality will probably be like 4 or 5 lectures anyway. So if this is 4 or 5 hours worth of content, it's perfectly fine to spend, I don't know, 45 minutes, an hour just to do the pre-study as well. So in which case you may actually do this. And the more you do it, the better that you get. So in reality, I if I wasn't trying to speak out loud, I will probably be able to do this much more quickly. Okay, so I've got an idea. I've got an idea here, and so what I want to do is, yeah, I think this is what I'm going to do. So I think I like this idea of strategies, which kind of encompass sort of multiple different aspects of it. I like the idea that sort of these learning skills are kind of in a way like they're the theoretical principles, but then your ability to apply it is actually the strategy. So it's almost as if the individual application is the strategy. So I'm going to try to bridge together this and link it with this, and I'm going to try to reorganize this stuff as well as this stuff underneath the branch of strategies, and I might add a separate chunk here for outcome, which before I wasn't really happy to add, but now I feel like there's a way I could maybe make that work. So I'm just going to think about that a little bit, and then I'll see what I can come up with. I'm feeling like it's a little bit better. It's definitely a lot cleaner, as you can just obviously see. I've taken parts of it and I've incorporated, certain aspects of it. Now, it's important to mention right now is that I have an understanding about all of the different topics and concepts that will come up in the rest of the list as well. Because remember, at the beginning, I tried to think about other chunks and I looked at it at the big picture first. You wouldn't want to do this starting from just the beginning and then moving your way through to the end without having thought about what might come up later. So one great example of that would be, if you notice the way that I've structured it, learning skills is all the way down over here. All of this stuff is down here. I've actually left this area blank because I anticipate that there's going to be a lot more stuff to come in that space as I go into that, because of the fact that I know that's legitimately coming up from having read through the concepts and thought about it. So you don't want to start linearly and then, if you start kind of just from the very beginning and just move through to the end, it's going to blow out of proportion and you're going to lose a sense of perspective. And then you're going to end up with chunks that really should have been rechunked differently if you'd only thought about that earlier. So you don't want that to happen. So right now, the sort of disclaimer, I suppose, is that I am already inherently aware of the rest of the concepts to come, because I already thought about that I would have thought about that when I was collecting the keywords, as well as when I was thinking about some of the more obvious intuitive chunks. So in my head, I already know that there is the idea of kind of, actually, even just one thing here, like practice and skills, right? We've got practice here. That hasn't actually come up yet. We haven't encountered any keywords and concepts to do with practice. So I know that that's going to fit somewhere around here. And that's the reason I was saying is that I'm not like fully happy with this chunk structure, because of the fact that I know that it doesn't include practice. So I'm not sure exactly what's going to happen there. And also, there are a few other areas that I'm like not completely too sure about. For example, the use of outcomes here, I'm not entirely convinced that that is the best way to represent that, because of the fact that I know that there are a lot of other things to come in terms of the theory, in terms of additional techniques, in terms of self-management things, where those are also outcomes. So I'm thinking, am I going to then link that up into outcomes, or do I have like two different types of outcomes? And then I have to have essentially like the same chunk twice. And that kind of, it could work. It could work, but there might be a simpler way. So I'm sort of wary of that. And I'm not really entirely sure if that's the way that I want to do things. But I'm sort of just thinking about that. I haven't used any visuals so far because I haven't felt that my memory sort of needs that boost. One word on here, though, that I think I would use a visual for is this word here, cognitive retraining, because that's quite a specific word, and that's just the type of word that if I put this on the map, I'm probably going to forget that. I'm not entirely sure where I'm going to put that because I haven't thought about that properly yet. But when I do add that, I'll probably end up making some kind of image or something with it, and probably same thing with tug of war practice. That sort of feels like something that would be quite a specific thing. I'm likely to forget that, so having a bit of imagery just to lock that in place would be good. And it's just such an easy thing that you could draw an image about. So what I'm going to do is I'm just going to go through a little bit more of the information, and I'll just sort of show you how things just continue to develop. I think I was up to note taking, so I'm now going to move on to measurability of learning. Now, I know that this is related to the research practice gap, and I know that that's to do with sort of issues between theory turning into application. Okay, here's another thought that I'm having is that I feel that chunk structure, like whatever happens over here, I feel like that's going to end up being fairly separate from everything over on this side. So I'm actually just going to leave that out. I'm going to skip that, and I'll come back to it later, and I might just refine that chunk structure there a little bit better in the future, but I don't really feel the need to nail that down right now. I feel like the beefy part of this is over on this side, and I want to wrap my head around that first. So I'm just going to skip that for now. But I do want to start integrating this practice stuff because I want to see how that's going to frame together. So knowledge versus skill management, methods of practice, and consistency of practice, all of these things are to do with practice, and the practice developing into a skill. Now, I've laid it out in terms of skill here, and I've self-management skill here. They both require practice. And then there's tug of war practice, and there's cognitive retraining. So in my mind, I'm sort of just thinking like, well, I know that practice is going to affect, both of these. And for a lot of people, again, they may say, oh, yeah, that works, done. It's just like that. But I'm not convinced that this is as clean as it would be, because this is going to have lots of stuff coming off of it as well. So now you're going to have this random word called practice, and then there's heaps of stuff coming off of that, just like linked into the middle of that. It just feels a little bit awkward. I'm not entirely happy with leaving it like that. It doesn't feel as simple as it possibly could be. So I'm going to get rid of that. So I'm still thinking about the fact that practice is linked to those things. I'm just thinking, what's the simplest way to do that? And again, I'm thinking, do I need to actually break these structures? Do I need to actually get rid of that? Do I need to rework that? Do I need to rework this entire area to be able to make that practice fit in neatly? I feel like I don't, because I'm thinking, well, how is practice as a chunk, how is that related to application and individual and system? And I'm thinking, well, it's actually not really relevant to system level applications. It's actually really only relevant to the individual level application. So it suggests to me that there is a way that it could work. Having it divided like that is not sort of conflicting. It's not clashing. The only thing is, how do I arrange it when individual branches off into these two chunks straight away? Because it almost feels like it should be like individual and then practice and then the skills. Well, maybe that's the answer, actually. Maybe I could just simply do that. Maybe I could go individual, and then that leads to practice, and then leads to skills. See, the problem with doing that is that then you end up with individual being a chunk in itself, which we call a lonely chunk, where there's nothing in it. It would end up being a single node chain. Individual going to practice. So in that case, we want to actually bring them together, because we want to reduce the amount of like unnecessary chunks and unnecessary data points. So in that case, can I get rid of individual as a chunk? And can I just replace that with practice? Well, that seems like it doesn't really make sense, because the whole reason this is memorable is because it's individual versus system. But at the same time, there's actually nothing underneath system either. So maybe system doesn't need to be a chunk to begin with. So here's what I'm going to do. Because I'm not really sure about this, I'm just going to take this chunk here, and I'm just going to separate this out. I just want to think about it in isolation. I'm going to see what this ends up looking like if I kind of work my way backwards. If I go skills, and this is actually practice. Actually, no, because practice is the thing that happens, but the outcome is that you develop the skills. Okay, so I think I can do this. I can go practice here, and then what that actually leads to is cognitive retraining. Here we go. Get my highlighter. You guys are like, what are you doing? Right, and this is that hack, right? You just do the outline of the thing that you want to draw, and you get the black pen, you draw over the outline of it. Try to keep your lines relatively clean. And just like, it just makes your drawings look better. See, look, it just looks better. And I'll add some yellow in there as well, just for the hell of it. Just for the yellow of it. Okay. So that's going to be cognitive retraining here. So cognitive retraining is essentially what is actually the outcome of the practice. So now, I actually really like that. I actually quite like this new little flow that I've created here between practice going to cognitive retraining, because then within practice, we've got like the methods of practicing and the consistency. So that could be broken up fairly easily, I think, in terms of like the how versus the duration. That's not very intuitive. So I like duration, so I'll change the how. So I'll go, I guess method versus duration. And then within method and duration, actually, you would end up getting tug of war practice, because that's kind of relevant to both of them. So I'm going to draw two people tug of warring here. So that's tug of war. So I like that. But then what do I do with this thing down here? Let's delete this just so that it's a little cleaner because I don't need this anymore. Let's get rid of that. Okay, so theory to application and then individual and then practice. Yeah, I feel as though having the system here is not really going to be helpful. And in fact, I'm really not sure about this whole like chunk structure there at all. Like, let's go back up to the idea of research practice gap. I guess the reason it's important in the context of what we've got here, the reason the research practice gap is important with the context of this is essentially just to show why it's not common. So it ends up almost being like an entirely separate thing. It ends up being almost an entirely separate thing. What I'm going to do is I'm actually just going to do this topic without having that included in here, and then I'll think about it afterwards to see how I can make sense of it. Because I don't really see anything popping out to me, and I mean, if I continue to move on, I'll create more nodes and maps, and have a better understanding of it. And at that point, maybe some light bulbs will start turning on for me. Okay, let's move on for a little bit more. Time to mastery, time for seeing improvements, information processing. Okay, information processing, I feel, is reasonably good to add in already because information processing is basically the micro level skills. Yeah, this stuff is basically about information processing. That's that there. And then the time for mastery and the time for seeing improvements. Why is that important? Because there is right. So that's because of the difference between knowledge versus skill, I think. Between knowing something and then being able to actually do it. Okay, so that's basically the difference between practice and actual cognitive retraining. That's pretty much it, right? So this practice and the gap between it is essentially knowledge versus skill. So instead of adding an entire word, what I'm actually going to do is I'm just going to leverage the use of my visual note taking, and I'm going to create this. Let me zoom out for a bit. I'm going to move this section just over here a little bit more, and I'm going to create a windy road. Oops, that's too thick. A windy road leading to that. And it takes a lot of effort for me not to see that as a loop of Henle in the kidney. Those of you that know about renal anatomy will know what I'm talking about. So that's going to be the sort of long and windy road. And that's essentially the sort of knowledge versus skill. And so time to mastery versus time for seeing improvements is kind of like essentially like time for mastery. I think that can just come off here. Actually, it can just come off here. You could have mastery versus, actually we'll do it the other way around. So I can draw an arrow between them. We'll do mastery here, and then this is improvements here, and then there's an arrow going to that. So I'll draw a little diagram here just to remember this. I'm going to draw like a little mountain and like a little flag on top. So that's like mastery, and then improvements will be like maybe I'll draw like a little an arm getting stronger. Yeah. Cool. Okay, good. I'm pretty happy with that. Let's give the bicep a pop. Boom. All right. Yeah, the spacing on this is not so good. So let me just clean that up for a moment. Now, these little aesthetic things that I'm doing right now, you might think that it's not very important, but it just makes it a little bit easier and organized to think about it. Also gives your brain a little bit of a break as well if you're tired. Like me, because I'm very tired right now. So that I'm pretty happy with what I've got so far. And we've got a lot of self-management related things that are going to be coming up as well. So I will I'll basically feed that through. So, okay, I think that's enough for now. I don't feel the need to really demonstrate any further. I think you get the idea of it. It really comes down to the, to this here. I made some chunks. I wasn't committed to them. I was very much so going back and forth. But at the end of the day, I was making sure everything was importance-based. That's the importance-based chunking is important. It's that knowledge in itself is already organized in some way. The relationships are there. We're not creating relationships that don't exist. We're discovering relationships within the knowledge that are already inherently there. And that's the reason why you can apply this technique for any topic, because knowledge already has it. Every type of knowledge has relationships. It always can be organized in a way. So the groups and the chunks are there. The relationships are always there. We're just discovering them. So it can be applied for any different subject. Some feels a little bit easier than others, but that's usually because of the way that it was taught. If it was taught to us in a way that made it easier, we'd probably find it just as easy as any other subject. Common example will be like maths. Maths is often taught in a way that's very, very procedural, with not too much emphasis on the conceptual aspects of it. And as a result, it can be difficult to make yourself see it that way for the first time because no one has shown it to you that way. However, it can still be done. It's actually exactly the same process. There's actually no deviation from the process whatsoever. It's just that with maths, you have an additional procedural component that you'd add on with your interleaved retrieval. And as you saw, if I wasn't perfectly happy that the way that I represented the chunk was truly importance-based, if it didn't really reflect the importance that I was thinking about in my mind, then I was not happy to use that. If it didn't truly reflect importance, I wasn't happy to continue using that chunk. And that's really the critical thing, is that the standard for importance-based chunking has to be held really, really high. And it is easier the more you engage in this. It's just the default habitual way of thinking that I will engage in for any type of knowledge that I need to consume, any information, whether it's in a meeting, whether it's reading a book, whether it's taking an actual course, whether it's learning on the job. All of these things, I'm always thinking about it in this frame. And the more you do it, it just becomes a habit. And then it becomes harder to just not do it because your brain's so used to thinking this way. Hopefully that was a good insight into how I really think about every single thing and all the micro decisions that I'm making when I'm going through the chunking process. Again, a lot of nuances in this. So if you haven't had too much experience, you may want to actually come back and watch this video again, because I'm pretty sure you'll notice different things in my approach that you maybe didn't realize the first time. When you look through the other examples, I don't go through it all step by step. I sort of skip a bunch of steps, but know that in the background, this is the type of thinking that I was doing to arrive at these chunks. In the next stages, you're going to be learning a little bit more about how you can turn what you've got now, which probably won't look quite as clean as what I've got right now because I've just got more experience. You'll be learning how you can get a stronger backbone from that, how you can really clean it up. You'll learn a little bit more advanced techniques about how to create really good chunk maps and really flesh them out into proper grind maps. I'm not going to be doing the same demonstration of the curriculum with that because really that's usually not a problem. If you're good enough at the basic chunking part of it, the rest is not usually an issue. It's rare to see someone that has an issue just with the technical aspect of doing the chunk map and cleaning it up into a grind map.
Let's have a look at how we can apply the AIM step for biology. Now, this is specifically based on the IB curriculum. However, the principles and techniques and basically everything other than potentially the exact subject, the material of the curriculum itself. Other than that, it's completely relevant for all other curricula, and really it's for every other subject. Biology is one of those subjects that is widely transferable. Okay, so we have here the AIM step. Now I got this using a combination of summary sheets, other people's notes, textbooks, course guides, whatever I could really get my hands on. I don't go to school anymore, so I don't really have access as freely as you may to your school resources, but you can use any resource that you want for this. Just remember, it's not really about where you get the information from, it's just about having that bank. So you could use textbooks, you could use course guides, you could use slides, if your teacher gave you notes, if you have any other types of notes available online or anything, you can use that. It doesn't really matter. And remember, even if you miss a little something, even if it's not 100%, even if it's like 95%, that's fine. I mean, we're going to learn 95% of it. The 5%, you can just kind of get that in later. We're still saving time anyway. So I have gone through the topic and taken down all the main keywords that I think are relevant. And I've also, you can see, broken them down into these headings: vessels, heart, big picture, functions, heart rate or heartbeat control. I thought these were kind of the main four that I could group them into. And so you can do this process as you're reading, which is what I did. I kind of was writing these down and I started thinking, oh, you know what? These are all to do with vessels. These are all to do with heart. These are all to do with whatever it is. And this is a process called chunking, which we'll get to later as well. But we're basically just creating these groups, okay? And the reason we want to create these groups is because it's a lot easier to think about how these big groups relate together first, and then we can arrange those in our shoot step. It's much easier to work with when we have these headings. So you'll see me do these headings every time I do an aim step. So now that I've got the keywords, I'm now going to go and make a bunch of questions, and you can have any type of questions. So the big ones obviously here, okay, arteries. The question would be, what is an artery? And when you're collecting the keyword itself, you can actually hit this question off right off the bat, because you're looking at the keyword. The first time you encounter the word, you're probably going to have a definition next to it anyway. So as soon as you read the word, as you write it down on your AIM list, like we're doing here, as you read the word, just have a look at the definition and just keep track of what it means. Again, we don't need to actually have memorized it. We just need to know what it is enough so that we can actually think about it. And, you know, when we look at the word, it's not just this random word that has no meaning. We actually look at it and think, okay, this makes sense to me. Like double circulation. If you didn't know what that meant, you'd read a little bit about it just so that when you read this word, you're like, oh, okay, that's kind of what it's talking about. So I'm not going to go through the what is it anymore, because we have to do that for all of these. We have to know what it is, obviously. So what is it? Yep, that's all fine. The other questions that we can think of is, remember, the really important questions of, okay, why is it important? And how does it relate? Now, the question that we can really elaborate on more, the why is it important, is this question doesn't change much. How does it relate? This question does tend to change. So how does it relate? A variation of this question could be, how do arteries compare with veins? Okay, that's the same question. How do arteries versus veins, how do they compare? Okay, what's the similarities and differences? That's the same question, really, but worded a different way. How are arteries and veins different to capillaries? That's another question. So I would be writing down all of these questions. And eventually, you won't have to write them down, eventually. But when you're first starting, you definitely should, because it allows you to actually evaluate the quality of questions you're making as well. Because the quality of the aim step has a direct correlation with the quality of the shoot step, which we'll go into later. I can also look at, okay, vessel structure. Okay, how is the vessel structure different for each of the three types of vessels? How does a vessel structure allow the exchange to occur? In which vessel does exchange occur? So you can see that in all of these examples, these are all variations of the how does it relate question. What I'm doing is I'm connecting the keywords together. I'm connecting exchange with the structures, and I'm connecting the different vessels with exchange. And so I'm creating all these connections here. And you can see just from the arrows that I've drawn that we're starting to get a lot of connections. And all of these are potential, not definite, but they're potential relationships. They're like, it's basically our brain saying, maybe it's connected. Maybe there's something there, okay? And we kind of park that thought, and that helps our brain think about the material a little bit better. And when we're learning it, it starts allowing us to make some of these connections more. So maybe this connection might be wrong, but then this relationship might be really important. And because we've primed it, our brain will be able to make that faster. Okay, and we just keep doing that for the rest of it. So we should do it for the big picture one, right? Vessels. So this is the heading, vessels. How does vessels relate to heart? And how does the vessels in the heart relate to the big picture functions? And how does heart rate and beat control relate to the big picture functions as well as the heart? And then each individual one. Ventricles, why is it important? Again, you know, this is a question that we are always asking ourselves, but I'm not going to write this down here because it's the same question each time. How are the ventricles related to the valves? How are the ventricles and valves related to the vessels? How is the double circulation related to the heart and the vessels? How is the double circulation related to the blood pressure? How does blood pressure influence cardiac cycle? How does occlusion of coronary arteries relate to blood pressure or double circulation? So we're asking all of these questions. Now remember, it's important to note that not all of these questions that we ask are going to be like what we might call valid, in that we might realize that the question didn't even make sense. It's completely not related. But that's fine, okay? Because remember, what we're trying to do is we're kind of like shotgunning this approach right now. We want to see, okay, these are all the potential connections that could be made. And then when we actually go and study it properly, we'll realize, oh, these are right, but maybe this one was there. We're priming the connections. And it doesn't take too long to go through and make these questions, and it has a really great advantage. But we do want to start thinking about it, because you should know what each of the words means. So you should, when you're asking the question, you should have like kind of an inkling, okay? Maybe not a direct answer, but you should have kind of an inkling about whether it makes sense or not. And we go through and we do this, and you'll have a long list of questions. Now, the aim step is usually done on the biggest topic possible. So this is a subject on blood system. And I thought this subject is probably big enough that I can just do the entire aim step on the whole thing. I wouldn't do an aim step on something as small as just the vessels stuff, because there's just not enough material to work with. When we're aiming, it's important that we have a good level of information. If there's not enough information, then it's quite hard to work with, because at this point, there's so few sort of points of information that we actually inhibited in being able to create connections and relationships, because there's just less stuff to connect to. In the middle, it's the great area where this is perfect, because there's a reasonable amount of information to work with, but therefore there's a really high amount of relationships that can be built. And then again, if there's too much information, then this is hard to work with again, because here we've now got too much info, and so it's too confusing. There are a lot of relationships we can create, but the relationships are harder and slower to create because there's just so many that it's just overwhelming, okay? So this x-axis here is the amount of information that's available to us. If we say that this y-axis is how easy it makes it and how efficient our learning is, then the graph would look something like this, where it's, we really want to be in this middle zone here, where there's the perfect balance of information and relationships. And generally, I say do the most amount that you can tolerate, which for most students, even total beginners, is usually like an entire topic, like this. Okay, so we'll see how these questions will then relate to the other techniques that we introduce in the shoot step. Have a look at a topic in biology, asexual reproduction. This particular one is based on the VCE, Victoria curriculum, but it is extremely overlapping with basically every other curriculum. And biology as a subject tends to have skills and techniques that are transferable across the bear hunter system in general. It's a great starter topic to work on. So this is definitely relevant for pretty much anyone that's using the bear hunter system. Even if you don't do biology, I actually think that this will help you. So let's have a look at how we've done the aim step. We're doing the topic of asexual reproduction. I was able to collect all these keywords and headings from summary notes. I don't go to school, therefore I don't have free access to all of these resources. However, you can use a textbook, you can use course guides, you can use slides, you can use other people's notes. It doesn't really matter where you're getting it from, as long as you're getting a relatively comprehensive scope of the entire topic. And even if you miss a little bit, don't worry too much, because we're at least going to be learning everything that you did cover highly efficiently, and we can always cover the remaining few percent that you might have missed later on. So I've got my list here. This is made through Notion, by the way. Notion is not good for generally notes and studying in general, but it is good for doing stuff like this where you just need a list. So you can see that I've gone through all the keywords and I've arranged them into headings. Now, these headings were actually in the summary notes that I used for this. However, I also looked at a couple of textbooks And the textbook headings were almost exactly the same, so I think you'll probably find the same headings. Now, the important thing here is you don't want to necessarily make headings. So make sure the headings are not always the same as the ones that are given to you, okay? You want to make your own heading. So, for example, they may give you headings that are like vegetative propagation and types of asexual reproduction. That might be the two different headings in the textbook or in your teacher's notes or whatever notes you're using. But you want to be an independent free thinker. You want to look at the keywords yourself and think to yourself, how could you group them together? And this is a process called chunking, which we're going to cover in a lot more depth later on. But it basically just means categorizing the information and making meaningful groups. So this is really, really important. It's a critical skill. And so I've created these different headings. And it's much easier when we go on to the shoot step later to work with these headings. So you'll always see me do headings whenever I do an aim step. Remember, at this point, there are a few questions that we need to be asking ourselves. The first question that we always ask is, what is it? Okay. Now, I'm not going to be going through this for every single point here because there's no point because we have to ask it for every single word. What is fission? What is budding? What is fragmentation? Important thing here is that we're not aiming to memorize anything. The only reason we're asking this question is so that when we look at this word, it isn't just a random word. We actually know enough about this to just say, okay, fission, I generally know what that means. Budding, I generally know what that means. And fragmentation, I generally know what that means. It's just so that we're not having a list of literally random words. We have words that when we look at it, we have some vague idea about what it is. We don't need to be able to regurgitate a definition. Okay, so no definitions. We don't need to be able to recall it perfectly from memory. We just need to be able to look at these words and just think about it a little bit so that when we ask the question, how is budding related or different to fission, we actually know whether that's a question that potentially makes sense or not. If we didn't even know what the words meant, then we'd have a lot of questions that we make that don't make sense because it would almost be like saying that you don't know what the word table is and you don't know what the word chair is. And so you ask the question, how does a table eat a chair? And it's like that question is completely not relevant because a table and a chair are not foods or things they can eat. So in that way, the question itself is completely irrelevant because we wouldn't even know the meaning of the words. That's purely what we're aiming to ask this question for. Of course, the other two questions, the important ones is why is it important? Why is it important? And again, we're asking this question for everything, but remember that we want to ask them for the headings as well. Why are the types important? Why is cloning important? Why are the advantages important? Why are the disadvantages important? And why are the issues important? We want to ask that question for ourselves. And the other question, how is it related? Okay, to XYZ. And this is a question that has multiple variations. So we can ask the same question, how is it related, a bit more specifically by saying, how is fission related to budding? How is budding related to fragmentation? How is fragmentation related to spore formation? So on and so forth. But remember, again, we want to ask that question for our headings as well. How are types of asexual production related to cloning? How is cloning different to vegetative propagation? How are the advantages different to the disadvantages, or how are they similar? How are the issues related to the disadvantages? So these are all variations of the how is it related question, okay? And so by doing this, asking questions like how are cuttings related to grafting, we can start forming potential relationships, okay? So by doing this, we have created potential relationships. And by creating potential relationships, it means that our brain knows that could potentially connect to, various different points. And even if some of them are wrong, it means that we've primed our brain to make the connections so that when we do make the connections, it's going to be much faster. Now, there are a few questions that I thought were good questions that you can ask. Just to give you an example of different types of questions you can ask yourself. I thought the question I've already talked about, how is fission different to the other types? This is like asking how is it related, but I'm trying to make the question a little bit more different. So when we learn a little bit about fission, we might think, oh, this is very similar to some of the other things. And so we'd ask the question, well, how is it different then? Okay, so this is a question that's I've been able to think of because I asked question number 1, what is it, for all of these. Because I asked what is it, I'm now able to ask the question, how is it different? That's a question that now makes sense. Vegetative propagation, how is it related to the other types? Okay, fairly straightforward. How is cloning related to the types of asexual reproduction and vegetative propagation? Okay, how efficient are the different types versus each other? So I'm taking the idea of efficiency and relating that to the different types up here. Some have high failure rates. Why? That's a very simple question, but sometimes the most meaningful questions is a simple why. Why is it so? Why does it happen? Why are they concerned? So these are great types of questions as well. So these are the types of questions that are going to allow us to really start creating links between the different concepts, different keywords, different headings. And that's what's going to allow us to prime our relationships. So when we take this into the shoot stage, you'll see how all of this directly translates through. Let's have a look at how we can use the AIM step for chemistry. This is using Chemistry Area of Study 1 in the VCE curriculum. However, the same techniques will apply for any other subject as well, and for any other curriculum. This tends to be relatively consistent across all the curriculums. So no matter what curriculum, what state you're in, even if you're doing IB, I think that this will all be very relevant. So we're doing the whole area of study in one go. And that's based on the principle that we want to be able to bite off as much as we can chew. So there's a sweet spot in information where if this is information on the x-axis, and this is how easy it is to actually learn and how efficient it is to learn, there's actually a sweet spot right in the middle where if you have too little information, there's actually not enough to work with. We can't actually make enough relationships, so it becomes harder. But if we're working with too much information, then it becomes overwhelming and it's confusing. So we want to be in the middle where we've got a decent amount of information, but also a decent amount of relationships that we can create and lots of connections. And this is a sweet spot we want to be in. Okay, so it's most efficient right in the peak here. So that's why I'm doing the entire area of study 1, which covers acids and bases, properties of water, redox chemistry, aqueous solutions, and water as a solvent. And I've gone through and collected all of these main keywords and main concepts, and basically anything I thought that is relevant for me to really just have down is like, this is something that I'm going to need to know. So you'll see that it's not always keywords. In fact, I've got entire reactions written out here. I've got equations even. Now, when I write this equation, I kind of understand that this is probably something that's going to end up going onto a flashcard, or it's going to end up going onto something that's suited for memorization. This is not something that is going to go onto a conceptual style of understanding. But I'm putting it here just for my reference, just so I know to think about it as well. And maybe I'll think of something and when I go through and create all my questions. So I just put it on there. It didn't take any extra time really to chuck the equation on, but at least it's there for me to look at. I got all this information from summary notes. I also looked at a textbook for this and looked at some slides from a couple different schools that their teacher had sent out. You can use whatever information that you want. It could be summary notes, it could be textbooks, it could be slides, it could be course books or course guides, it could be other people's notes, whatever it is, whatever information it is. We just want to make sure we've got a good scope of all the information that we need. And based on that, I've just written down all the different keywords that I need. And based on this, we can start creating our questions. So obviously, the first question we're asking, as always, is what is it? And importantly, what we want to make sure is that we're not asking this question in order to memorize anything. We don't need to be able to recall or recite a definition. That's not the purpose of it. The purpose of asking what is it when we go through each of these is so that when we look at the word, we can look at it and it's not just a random word. So Bronsted, Lowry or Lowry theory, if you don't know what it is, then it would just be a random word, and we're not really even able to make questions on it because we don't even know what it means. So every time you write a word down, you want to just make sure that you're looking at the definition of it, just so that you generally understand what it means. Okay, and that's all we need. We just need a general understanding of the word. We're not out to memorize anything. Don't waste time trying to memorize it. Just learn enough to basically look at the word and be like, oh yeah, I kind of remember what that's talking about, even if you're not crystal clear. We just need to know enough to make a few questions based on them. So I basically have done that for the entire topic, okay? I've done that for all of the different topics, and you can see that some topics are a little bit bigger than others in terms of the number of key concepts and terminology and things, and that kind of relates to how difficult or easy the topic is. So if you've done this chemistry area of study, you'll know that aqueous solution is a relatively straightforward topic, whereas acids and bases is a little bit more complicated, and redox can be a little bit more complicated, but you'll know that there is certain topics that have more content than others. And we go through and make all these questions, right? So what is it? And then the next question we ask is, of course, why is it important? And we ask this for every single main point. But remember, we don't just ask it for each of the sub points here. We have to ask it for the main headings, right? So we've got the headings of acids and bases, and then we've got the subheadings of Bronsted-Lowry theory. We've got strength of acids and bases. We've got pH. We've got ocean acidity. Properties of water is a main heading. Structure of water, heat capacity, latent energy, redox chemistry, reactions, oxidation numbers. So these ones that I'm underlining, I would consider these like more so main concepts and bigger ideas than the ones underneath it. Okay, so obviously types of solutions would be not as important as like the concept of solubility in itself, right? So that's basically what I'm doing here. I'm going through and just underlining the ones that I think are really more important than the other ones. So we are asking the questions, why is it important? As well as we're asking the question of how is it related? And we can ask this how is it related question in any number of variations. So asking something like, how is Bronsted-Lowry theory related to pH calculation? That's the same question as how is it related. We're just being more specific, so that's a variation. How are acids different to bases? That's the same as saying how are they related, but we're just varying the words that we're using and being a bit more specific about the type of relationship we're inquiring about. And we're able to be specific because we know what the words mean. When we look at monoprotic, we can say, how is that different to diprotic? Or how is that different to triprotic? We can make these types of how is it related questions where we're comparing the relationships between them. How are each of these reactions different to each other? How are these reactions different to the reactions we might find in another topic? So how are acid-base reactions different to redox reactions? Because they're both reactions. So we're going through and asking questions like this. And because we're doing an entire area of study here, it's going to be quite large. Okay, we're going to have quite a lot of questions by the end of this, but that's okay. And the important thing to realize is that this is time invested. Okay, this is time invested. When we spend time doing this, and okay, to be totally honest, chemistry isn't my strongest subject. I haven't studied this stuff in years. It's been probably almost 10 years since I've touched the topic of acids and bases and redox reactions. Okay, so for me, it was actually like almost like studying this stuff again from scratch because I just studied it so long ago. So it took me a while to do this, to do the aim step for the area of study. It took a good sort of 30 minutes to 1 hour. And remember, this is not me like learning anything really. This is just me going through the material, okay? And here, a lot of people, if they're not used to this way of learning, can feel like this is where time is wasted, but it's not. This is time invested because I know that even though I spent a while to make all these questions. By the time I finished making them, I had so many things I was curious about. There were so many things I wanted to know, and there were so many, bing, 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 keyword, there were so many potential relationships that I had primed. And I knew that as soon as I started actually going into it more, a lot of these relationships would start connecting together. And then some of the relationships I'd realize don't make sense, but that's fine because overall I'd end up building a really nice, well-connected web of ideas because I just had so many questions about all of this and how it fit. Now, as a word of warning, it does seem quite overwhelming. It does seem overwhelming to not only do an entire area of study all at once, but also to have so many questions. It can feel like ridiculously confusing. You don't even know where to start. That's very normal, okay? That's a very normal feeling. And actually, that confusion is going to be energy that your brain will use as fuel to start putting the pieces together. It means that it's really, really keen to learn, which is a great state of mind for our brain to be in before we start consuming information. So we'll see how this aim step is going to allow us to create a really great shoot step moving forward. But by the end of this, I've got lots of questions that are related to why each of these are important and how they're related to each other. For example, how are these reactions related to these reactions? How is heat capacity different from latent heat? How is the structure of water related to heat capacity and latent heat? How are the properties of water related to aqueous solutions and their reactions? How are the properties of water related to water as a solvent? How are acids and bases related to aqueous solutions? How are solvent-solute interactions related to ion-dipole attractions? How are precipitation reactions related to ocean acidity? So not all of these questions will make sense. You're going to have questions that are duds. The question didn't make sense. It's not a valid question. It just doesn't make sense. That's just not how the topic works. But even if you think of dud questions, it's fine because, again, what we're doing here is we are priming our brain. Okay, we're priming our brain to be really, really hungry so that when we start thinking about the questions and when we start learning about them, we're in a great state to actually start putting all of it together. So that's the point that we'll be at the end of the aim step, and then we'll move on to the shoot step. Look now at how we can use the BHS for English. And before we get into this, I need to talk a little bit more about English and languages in general so that you understand a little bit about how it's structured, how it's assessed, and therefore how the BHS needs to be adapted, because doing it for conceptual subjects, things that are usually more straightforward in terms of how concepts are connected, typically we're talking about the sciences here, it's a lot easier to use the BHS as it is. But when it comes to English, we need to make some variations, and we need to make some variations for languages. We need to make variations for maths as well. Some of the variations are bigger, some of them are not as big, but they all follow the same principle. And that's the main thing to think about, is we need to make sure we know why we're using the techniques we're using, not just mindlessly using them. Because if we know why we're using it, then it's very straightforward to make these variations. Whereas if you don't even know why we're doing the techniques that we do, then none of it makes sense, which is obviously why we spend so long teaching you about the theory, so that you're not just like a mechanic that's just doing the action, but you're also the engineer that's designing it as well. That's what we want. So English is really divided into two different domains, basic competency and advanced competency. And when we say basic competency, we're really talking about vocabulary, grammar, syntax. So when you're learning a new language, you don't have the opportunity to do any advanced competency, which is analytical, looking at techniques that are being used, or expressive, which is actually using those techniques yourself, right? So analytic means that you're able to analyze the techniques that other people are using, literary techniques, writing styles, usage of themes and character development. That's analyzing it. Expressive means that you're actually able to take those techniques and apply them to your own writing, either persuasive or creative or whatever type of writing it is, and use those same literary techniques and write thematically. So obviously, expressive competency is kind of the highest level after analytic, and before advanced competency in general, we have basic, which is just knowing the right vocabulary, the grammar, and the syntax. And obviously, when it comes to vocabulary, you've got basic vocab, simple conversation, and you've got advanced technical vocabulary, like academic writing, scientific writing, things like that. And so if you're learning a new language, you're really in the basic level of the basic competency. You're just learning some words, you're learning the basic grammar, the basic syntax, learning to string together a sentence. And so we travel along the spectrum where we do the basic competency first, and then we do the advanced competency. And sometimes we go back to this basic vocabulary competency to get just more specialized, advanced technical vocabulary as we go, even after we have, accomplished this part. But this is kind of how we can look at English, or really any language that you're studying. Like if you lived in Japan, then you would be able to probably divide Japanese up like this as well, except, if you don't speak fluent Japanese already, advanced competency is probably out the window for you in terms of what's reasonable and realistic. But the other thing to look at is where we can actually save time. So the thing with English, especially at a high school level, is it's very important the way that it's actually assessed. And this is different compared to how your science subjects would be assessed, because science subjects are assessing you based on your understanding and knowledge of concepts in science, whereas English actually assesses you in a number of different ways. And part of that actually involves often some form of application of a particular type of skill. Okay, a skill is more like a procedure. It's a thing that we're doing. So for example, essay writing. Okay, essay writing is a skill. It's a process through which we need to use our knowledge in a very specific way. And you don't have to do this in a lot of other subjects, or at least not as technically as you would something like essay writing. So when we're developing skills, there are ways to make that skill development faster, and we will look at some of those things later on. There are things like interleaving. You can look that up if you're really curious. We will cover that later, though. If you can't be bothered, that's okay. That we can do certain things to speed up our skills development, but generally speaking, a proportion of our time is relatively fixed. We can't do anything about it. It's going to take some time to learn it. It's kind of like when it comes to science subjects, rote memorization. You can't really get much faster at rote memorization unless you have some of the advanced techniques that we're going to teach you later on. So that's kind of a fixed part. When it comes to English, learning to write good essays, learning to just develop the skill of analyzing a text and analyzing themes and things like that, actually reading the text itself to respond to. These are things that take time inherently, and so they're relatively fixed. So we can't actually do too much about that. So what we think about instead with the Beanta system is two objectives. The first objective is, number one, how do we make the parts that we can go faster in faster? So how do we speed time up during this area? So this is understanding the text, getting a deep level of interconnected understanding so that when we do write our essays, what we have actually sounds good. How do we speed up that process and make it so it's more consistent? So that instead of just doing, like 100 practice essays, we only need to do, which obviously takes a long time, we might only need to do 6 practice essays and actually get the same amount of benefit. How do we do that? And then the second aspect is, how do we practice in such a way that the skills get better and better? Because obviously if you just do 100 practice essays, yes, you might get better at writing the essay, but if you're relying on writing a different type of essay for every possible question that you might get asked in the exam, then that's obviously very unsustainable. It's very luck-based, and you're not going to be getting consistent results, especially with the way that English tends to be examined these days, where they throw you a lot more curveballs. They will assess you in ways that you didn't expect them to assess you, and sometimes it's even on the news how the questions are just, quote unquote ridiculous or unrealistic. But really, if you actually learned it properly, it's still actually very easy, and we're going to see some examples later on about how that's the case, as long as you practice the right skills. So it's a little bit different in that there are certain things, like if you want to get better at essay writing, yes, you still need to put in some time to learn the correct essay writing techniques and understand it a little bit more. But there are other areas that we can save time in so that we have more time to do this. And that's always the thing with studying, is that there are some things that are fixed, some things that are not. We work on improving the things that we can improve on, and the things that are relatively fixed, we now have a lot more time for them, which means a lot less stress. So let's have a look at Bloom's taxonomy again and see where this English fits into this. So basic competency, grammar, syntax, things like that. That's really looking at just being able to memorize and understand how to use the syntax and memorize the vocabulary. So that's basic competency. And advanced competency, analytic, is looking at apply and analyze. Can you apply the knowledge that you know about literary techniques to identify them in someone else's text? And then analyze, and can you interpret and compare one technique from another and describe or explain why one is better than another or more suited for a certain type of theme? That's what we do with analytic. And expressive is at the top, where we're creating something new based on which technique we think is the most appropriate for which situation, which requires us to weigh and justify the different type of techniques that we're using. And that's the level 5 of Bloom's taxonomy. So we're going to go through Bloom's again and again, and we'll see it coming up here and there throughout the course and why certain techniques work better than others. So let's start from the basic stuff first. We'll start from the basics and then we'll move on to the advanced ones. So how to get good at basic English. This is basically the same as saying how to get good at a language, how to get good at foreign languages. So this first part, we're actually going to be talking about how to do languages well. How we can develop basic competency and get good at a new language, developing vocabulary, grammar, and syntax. Now, actually, we can use the exact same thing here to develop advanced levels of vocabulary as well. So if you're already fluent or relatively fluent in this, for example, I would say that my English is relatively fluent. I could still use this exact same method and model to increase my vocabulary or enhance my grammar or refine my syntax or something. So it's the same exact model. Now, what this is built on is the idea of something called comprehensible input hypothesis. Comprehensible input hypothesis basically says that, and now you might be wondering what these drawings are. Don't worry, I'll explain it in a bit. Comprehensive input hypothesis says that we have these 3 different layers or levels at which we understand language. We have our current level. This is what we're comfortable with. These are the words we know and the sentences we can say. If it's a brand new language, this current level is almost non-existent. You might know one swear word that you heard on TV. The comprehensible input level is the level just above that. That's at the level where you don't actually know what they're saying. You're not really sure of all the words that are being used or all the grammar, but you can sort of figure out what they're trying to say. It's just barely comprehensible. And then after that, it's stuff that's too challenging. You have no idea what they're talking about. And so if we zoom into this area right here, this is actually a bit of a spectrum, because right here we're going to have stuff that is just understandable. So these are things that we can just understand. Whereas over here, as soon as we cross this level, we've got things that are just not understandable. And that's where comprehensible input is, and that's actually where we want to be. So we actually want to learn by being at the level where things are just not understandable. So again, that means that you don't actually know all the words that are being used. You might be having a conversation with someone, okay? So this might be a conversation. And during this conversation, you're not 100% sure. You're maybe like 50% there in terms of what words are being used. You wouldn't really be able to like write it out again and get it right word for word. But you sort of get the gist, maybe a little bit more than just the gist. You sort of understand what they're trying to get at. It's the same for written language as well, or writing in itself. So there might be writing where there's stuff that you understand, and then there's writing where you understand generally the gist of what that writing is trying to produce. Now, if you're already really fluent in this, it just means that your current level is going to be really, really wide, and then that comprehensible input is going to be really, really narrow. So for me to use this for learning better English, for example, I would need to immerse myself in exposure to language that is really extremely technical and challenging, using a lot of very highly specialized vocabulary. And then I might not understand 2 or 3% of the words that are being used, compared to normally where I'd understand 99.9% of all the words that are being used. So it changes, the scale of what's comprehensible and what's too challenging does change. But the idea is that when there's a current level of knowledge and how comfortable you are with that knowledge. There's a level beyond that, which is just not understandable, but somehow your brain can kind of piece it together. Now, the thing about comprehensible input hypothesis is that it relies on you not having memorized any words, okay? It relies on you not having memorized words. Or rather, it relies on whatever words that you might already know. There might be stuff that you already memorized before, but it doesn't rely on you memorizing new words in order to understand it. What it does is it takes your existing web of knowledge that you have, and then you apply all these other things to it. Body language, tone of voice, gestures, the context in which they're talking about it. And then based on that, you actually are able to build a sort of picture about what might be said. And you're not going to get 100% right. But because of the fact that we're now trying to create this language more organically, based on a number of different cues and signals, rather than just what we had memorized before in terms of vocabulary and flashcards, the words that we learn as a result of trying to figure it out is actually retained much more highly. So here's how it goes. We enter into comprehensible input. We are kind of not sure what's being said, and we sort of get the gist about it as well. And then from here, we learn in order to make sense of that. So we think, okay, I don't know about this, so I'm going to learn about that word. And then now, what sentence you heard or what dialogue you heard starts becoming easier and easier. And that thing that was originally comprehensible input, aka just not understandable, becomes now just understandable. And you will have memorized new words and new grammar and new syntax, and those words will actually be retained much more highly than if you had just learnt them through flashcards or rote learning like you normally would. So this is why if you go to a foreign country and immerse yourself, you will learn much faster, because you're surrounded by the entire spectrum, but because you're constantly learning for a purpose. And this is where comprehensible input is basically the same as the bear hunter system, because what you're taking in, the knowledge that you're trying to learn, has a purpose. And therefore it's relevant, it's problem solving, and therefore you're actually going to be able to retain it much more easily. And this is the theory behind how we think babies are able to learn. So babies obviously don't have any language when they're born, and so everything for them is not understandable. And as they learn one or two words here and there, babies are able to increase their language development extremely fast. And we know that, right? You get like quadrilingual babies when they're like 3 years old, just because they've heard those languages. And they're not writing any flashcards. When's the last time you saw a baby hanging from, they've got like the little baby cot thing and the mobile hanging above their head, like spinning around and around, and it's just flashcard. There's probably some parent out there that's doing that, holding flashcards above the baby's head and like spinning them around when they sleep. But most babies are not doing that. And yet they're able to develop language competency very, very quickly, much faster than most adults. And that's because they exclusively learn through the comprehensible input hypothesis. Or so we think. That's the theory anyway. It's kind of hard to figure out what a baby's doing. But this is the way that special forces agents that are deployed into new countries are taught to speak a new language. They are taught to find situations in which they would genuinely need to communicate with the locals, and then they are taught only enough to be able to do those communications, which is why they're able to have basic conversational fluency with a new language in just 1 or 2 months, which is pretty fast. So the idea here is, with comprehensible input hypothesis, when we plug this into the bear hunter system, then what we end up with is the aim step. And so the aim step is very simply, we create some kind of curiosity. The same as any aim step, right? The aim step is always about creating curiosity, because curiosity creates problem-solving mentality. The problem that we're trying to solve here is a certain dialogue or a certain writing or something. So it needs to be something that we kind of understand and kind of don't understand. Kind of understand and kind of don't understand. Same thing for the writing. It needs to be a combination of stuff that we're familiar with and not familiar with, right at that comprehensible input level. And what type of dialogue do you pick? What type of writing or essays or reading do you pick? Actually, it can be anything. It can be anything. The most important characteristic, the criteria that needs to be met, is that this is something that you are genuinely interested in. So if you are studying Japanese and you're really interested in watching anime without subtitles, then that's something that you'll be genuinely interested in. So you would take the speech and the dialogue from a particular very epic anime dialogue, and then you'd try to learn to be able to say that. And then you'd add some maybe additional variations, right? So you might actually say, okay, well, when this person said this thing, it was replied with this. But if I were in that situation, I might reply with this thing instead, or maybe this thing. And then they might reply with this thing, or they might reply with this thing. So we can take a single dialogue that we're naturally quite curious about here, that we are pretty interested in to begin with. And then based on that, we can actually start getting multiple variations. And these are effectively the questions that we have. So the questions we have are not literally like question 1, what is blah, blah, blah. Question 2, what is the word for blah, blah. Question 3, what is the correct grammar to use in this situation. These are not the questions because we don't care about these questions. They mean nothing to us. What we care about is being able to tell our anime crush that we like them, or what we're interested in is being able to write a certain piece of something, like maybe a manuscript or something by like an author written in a different language that you really, really love. Something like that. That's the stuff that we're genuinely interested in. And when we start with that as a springboard, we take that and then we write out different variations of what we want to be able to talk about. Then we get quite a long list of things, different dialogues, pieces of writing, essays even, that we can actually start learning about. And you can just write this out in English, because obviously if you were able to write it out in the language you were studying to begin with, you probably don't need to learn that anymore. So very simply, let's say that I'm learning German, okay? If I'm learning German, or let's say Chinese, and I'm learning Chinese, Mandarin, and as I'm learning Mandarin, I'm thinking, okay, well, I'd really like to be able to go into a shop and say hi to a Chinese shopkeeper. I'd like to say, do you speak Mandarin? They would respond with something. So we've got already something that I'm interested in. I'm genuinely interested in going into a shop and having a certain dialogue that says, do you speak Mandarin? And then they would probably say something like, yes, I do. And they might ask me, do you? And then I would respond again with yes, a little bit. And then I want to say, I'm looking for ice cream. Where can I find it? And then they might respond with something else. So we can end up with having like a little bit of a dialogue there that we script out in English. And we're thinking, man, if I could say this dialogue, that I've written in English, if I could say that in Mandarin, that would be awesome. And that's what we start with. Now, for this to be comprehensible input, you need to be able to say at least a few of these things. So maybe you know the word for Mandarin and speak, but you're not sure about the grammar or the syntax involved in actually asking someone, do you speak Mandarin? And you might understand how to say yes and I, but you don't know how to say do or do you, right? You might know how to say a little bit, but you're not sure about the syntax on how you'd create the sentence of, yes, I speak a little bit, or I'm looking for ice cream. Maybe you don't know the word for ice cream, okay? So here you can see that there are some things that we do know, but then there are also things that we don't know. And if we would hear this conversation, someone actually having this conversation in Mandarin, we would think, they're probably asking something about like where to find a certain item, but you'll kind of be like, yeah, I sort of get it, and then I sort of don't. And that means that you're in that comprehensible input range. If you just don't understand it at all, that means that you've gone into the too challenging range. But if you kind of understand it, kind of don't, you're in comprehensible input, and that's where you want to start creating your variations in your script. And you can take the same script, and you can create a couple other variations from this. Different ways that dialogue might have gone with the shopkeeper. Maybe it's a shopkeeper and their husband working there, and then you have a conversation with both of them. And then we go on to the shoot step, which is effectively learning in order to fill the aim. When it comes to this, I think you can probably guess how we're going to do that, but because we're just focusing on the aim step right now, we're going to end that here, and we'll carry this on later in the shoot step. Let's look at advanced competency for English, which is looking more at the analytic and expressive side of things. This is more the subject of English that you're familiar with. And so let's start with the aim step, what that actually looks like. So we'll do the aim step for a text that you've already studied. Now, this is something that you might answer a text response for. You might be asking to do ask questions about the theme of something. And the way that we need to think about this is the way that actually a lot of good students naturally already think about this. So if you're already really good at English, if that's like a strong subject for you and you already find it relatively easy, then this is probably not going to be anything new for you. It's just that a lot of students aren't used to thinking this way, and for whatever reason, English and maths as well, actually, there are some students that actually bother to think this way, and then they just naturally find that it's really easy and just don't understand when people find it difficult. But usually it's because they're not thinking this way. So what is this way? Well, the first step of that is understanding how is it all related. Now, when we normally do something in terms of a text that we study, what we normally do is, number one, obviously we have to read it to know what we're talking about. And then what's said is that the teacher will say, okay, well, there are certain themes here. Look at this technique that's used here. Oh, there's a technique over here, and it's connected to this theme here. And there's another theme here, and that's connected to that technique, but also this other technique. And it becomes really confusing, and we end up with this long list of things that we need to memorize. Themes, techniques, characters, events, developments, and the rationale behind why each of those is important. So when we're doing the aim step, we do much the same thing. We do this, why is it important and how is it related? And we ask that same question, but what we're doing is we're actually asking that along three different elements. We've talked about themes and techniques and examples already. How themes are represented in techniques and examples. So the way that the author has decided, or if you're doing a film study, the way that the director has decided to portray the themes is using certain techniques and examples. So the techniques and examples make more sense when you understand the theme. If you didn't even know the theme, imagine memorizing every individual technique and example, and maybe this is something that you're already doing. That is going to be the most random, obscure list of things. Literally just random angles and low shots and pans and lighting effects, or different scenes that are being used, or different literary techniques that are just thrown in there randomly for a poem. And you're just thinking, why? Why are we using this technique? What is the purpose of that? And maybe you're already thinking that. But hopefully you realize that it actually has a purpose. And the purpose of using those themes, using those techniques, is to demonstrate the theme. If there's a theme of something that's like foreboding, then there is a technique that we know that can demonstrate that. So that element does require a little bit of memorization here. So I would say that in this case, there's about 50% memorization involved there, where you actually have to memorize what is the technique. Okay? And what is the technique useful for? So we might have something like, okay, there's a technique of using repetition in text. When repetition is used, it creates the sense of emphasis, relatively straightforward. So you'd have a list of all of these different techniques that your teacher's probably given you, okay? And you are going to have to go through and be familiar with all of those techniques. Some of them will be easier to remember than others because it just is more logical. That's where the memorization comes in. The issue is that a lot of students will then take these techniques and then retrospectively pin them onto the theme. And now what that ends up being is a list of techniques that are used and then a list of themes that they're related to, which is the total opposite direction that it needs to be. It should be a list of themes that are connected in some way, relationships between them, that are represented with various techniques as examples. Okay? It's like if someone says to you, hey, you're walking down the street and you see someone getting assaulted. What would you do in this situation? Now, what you might do is you might call the police if you're feeling brave or stupid or highly trained. You might try to intervene yourself if you think it's extremely risky, but generally speaking, You probably do something about it. When the police get here, you might sort of stand to be a witness. You might call an ambulance as well for the person that needs care, and maybe you try to help the person from like a first aid or something point of view. These are all the things that you do. What a lot of people are doing with their English essays is they're saying, okay, that's what I do, and the reason I'd call the police is because that seems responsible and that seems sensible. The reason I'd say as a witness is because it seems responsible and it seems realistic and it's within my capabilities. And then the reason that you might interfere or intervene directly with the event is because you have a sense of responsibility, but also a sense of confidence. And the reason you'd call the ambulance is because there's a sense of responsibility, and a sense of like moral obligation and a level of concern for the person's health. This is what people are doing. And then when they write their essay, no wonder it's difficult to string the themes together and talk about it, because it's understood opposite. It's understood from the effect back to the cause, when actually it should be the cause to the effect. So the same question, what would you do in this situation when you see someone being assaulted? The better way to answer would actually be to say, well, I would probably do something. That's my introduction. And the reasons for this are because I have a sense of responsibility. However, I feel limited by my sense of capabilities and my level of confidence in dealing with this. But I am at the same time morally obligated and concerned about this person. So you've outlined your themes. And now you'd say, so, for example, because I feel responsible, I feel like I would do something like potentially intervene or call the police or call the ambulance. However, because of the fact that I am limited by my confidence and my capabilities here, I feel like the most effective thing for me to do would be to call the police and call the ambulance. And ultimately, I know that I can't walk away from this and not do anything because I have a sense of moral obligation and I do feel concern for this person. So what we're doing is we're saying, okay, this is why we think the things that we do, and we're linking it back. And it makes a lot more sense to do it that way. And when you've got an entire book that we're trying to dissect this way, there are so many techniques that are used in the book. You're going to end up with a ginormous, never-ending list of things that you're constantly trying to link back to all the different reasons and the themes, and it's going to become this enormous mess. And when you're trying to write an essay about it, you don't even know where to start. Whereas when you read an essay, like a model essay, an exemplar, then you think, wow, it just feels so clean and so well organized. That's because it's been organized in the right direction. And so this is the right direction. You want to start at the themes and understand why is not just the technique important, or the technique's important because it relates to the theme. We want to ask ourselves, why are the themes important? Why are the themes important? So this bit here is actually where it needs to start from. And this is often looking at the background of the author or the director if it's a film. Okay? We actually want to know about the author and the director. What was their life like? Where did they come from? What is their perspective that makes them think this theme is worth writing about? And when we understand where they're coming from, it becomes a lot easier because now the themes make more sense. They're not so random. And then we relate that to the techniques. So we end up drawing a web of understanding that starts from a basic level of understanding about the author and their background, and therefore the themes that they thought were important for them to really talk about, and then a few of the techniques. So we can create this tree of understanding. Now, as I said, people that are already naturally good at English, inherently it's a strong subject, they're already doing this. So unlike the bear hunter system for sciences, where it's a way of studying that most students are not using, this is something that students are already using to get top marks. And it's something that if you're not even doing this, you're actually going to be falling behind. The thing is also, a lot of students are doing this without consciously realizing they're doing this. So obviously, there's a difference between doing it unconsciously versus doing it consciously. One of the main benefits of doing it consciously is that because you know exactly what you're doing and why you're doing it, you can actually optimize it. So once you know exactly what to do, you can turn that system into something that is faster and more optimized. And therefore, you can actually be even better than the people that are naturally doing it. So there's even the opportunity for an advantage to be had. And so this is the exact same thing that you'll be doing for your creative and persuasive texts as well, both analytic and expressive, because it's effectively the same thing. The only difference is that when you're analyzing someone else's work, you're thinking, what is the author's background? Okay, why is it important why is this theme important for the author? When you're expressing it, you're just saying, you're the author now. So you're just saying, for you, why is it important? So why is it important for you to talk about the themes? Why are the themes important for you? And when you actually relate it that way, rather than just saying a random list of themes and being like, okay, I'm just going to talk about these. When you say these themes are important for me for whatever reasons, and then you talk about those, it's going to give you a bit of backbone to frame an essay or a creative piece or a persuasive piece around. So for a creative piece, that looks like saying, okay, well, what are the themes that you're maybe that are more personally relevant? Or what are the themes that you feel are the ones that just kind of resonate with you the most, that you maybe agree with the most, that you just feel more aligned with? When it comes to persuasive, it's what are the points of argumentation? Okay, what are the argumentative points? What are or otherwise, what are the themes that you find the most persuasive? Okay? The most persuasive. And that's why you think it's important, right? When the purpose is to persuade, why is it important? Well, it's important because it helps me persuade the most. So then we think, what are our most persuasive points? And so writing an essay becomes very logical. It is a technical skill, but it's fundamentally very logical. So take the text that you're studying, and we'll look at some examples of that. Take the text that you're studying and then go into why is that important, all right? And we can actually do this very easily by doing it in this order. So we go themes, then the author, and then go back to the techniques and the examples, okay? So we're going to say, number one, what are the themes in the text that are important? Number two, why are they important? Okay, so we're now going towards the author's perspective. And number three, how are the techniques related to the themes / author's preferences, or maybe their own literary influences. And actually, you can often find, if you read like a Wikipedia page about the author, you can often find they state what their literary influences are, and you're like, oh, that's why they write in that very particular, peculiar way that they're famous for. So we follow these questions, and doing that, we're going to be able to build a map later on in the shoot step, and we'll have a look at how to do that. But for this, let's say we're going to use the example of 1984, the book, which is written by George Orwell. So in this example, we'll use 1984 by George Orwell, a very famous book. You maybe already know it. Maybe you're studying this at school. It's a very common book to be studied at school. Obviously, every school studies a different text, so I can't go through an example of every single text that you've studied. But it's the same principle. So what we'd say is, what are the themes in 1984? And we'd write down what the themes are. Why are they important? Why are those themes important? And then how are the techniques that we have learned about and studied and the teachers told us about, how are those techniques related to the theme and the author's own influences? That's the aim step. We create curiosity around these questions, and then we go to answer them. And remember, again, it's not going to help you straight away craft the perfect essay. We still need to spend now a little bit of time spending time on developing the fixed portion here, which is developing that technical skill to do the essay writing. But it means that the content of your essay, the actual things that you're trying to say, your ability to link ideas together, this is going to be much faster. You're going to be able to develop that skill much faster because your understanding is much deeper and more flexible, and you can answer a lot of different curveball type questions based on it, because your understanding of this text is now going to be almost like you are the author yourself, because you're really seeing it from the author's point of view. So imagine if you were the author and you were answering an exam question about your own text. How easy would you find it? That's kind of what we're trying to do here. We're seeing it from the author's perspective. Let's have a look at how we can apply AIM step for maths, or the BHS for maths in general. Now, there's actually a really important thing we need to talk about when it comes to maths. Like English, it is a fairly specific type of subject that has a few nuances that we need to understand first. Otherwise, we're going to have difficulty applying the BHS for it. As you know, maths is not like science or English or really any other subject that you learn probably. And there are a few defining characteristics that we need to really nail in first. So the way that we learn maths typically is in this black text here. We learn a little bit of the theory behind it, but we really quickly rush into the equations and the formulae that we need to use, and then we apply those in practice questions. And usually the time that we spend up here is very, very short. The time that we spend here is really just a minimum amount required to be able to apply it. Now, the thing with maths is that that's actually kind of a good thing, because as we know from Bloom's taxonomy, and the way that our brain works, is that actually it's more effective for us to be applying our information as quickly and as early as possible. And so this is actually good from a learning point of view, that we're applying the information. The issue is that we are spending a little bit too little time on the theory, and we're not trying to see how the theory actually connects together, which makes it so that maths is really extremely procedural, followed by memorizing the different equations and the formulae, and there's not a lot of knowledge around it. Most students don't really understand how maths works. They don't even sometimes know what maths really is. It almost just seems like magic. You kind of just have numbers and you do things with them, and then just things happen, and it seems very irrelevant to real life. And so normally what happens is that we start from this top here and we go down here. So there's a couple things that we need to realize. First of all is that the time that we spend on this procedural application, learning to use the formulae and the equations and all of that sort of stuff, that's time that we do have to spend. Okay, that's time that's relatively fixed. However, there's a big difference here. So this is the amount of time that we normally spend on all the knowledge and the memorization. So I'm just going to call this knowledge. And then this is the amount of time that we normally spend on the application. Now, normally speaking, this would be good because you go and apply the information very, very quickly. But there's a couple changes that we actually need to make. The first issue is that we're often not coming back to the knowledge in the cycle. We're simply just staying inside this application, and we're kind of just doing trial and error. So through applying it, we're not actually learning it deeper. We're just sort of doing the same thing again and again, and seeing that sometimes it works and sometimes it doesn't work, and then that can seem a little bit random at times. And so that's kind of the first main thing, is that we spend a lot of time applying, and instead of doing Kolb's experiential learning cycle, where we're experimenting with applying our knowledge a certain way and then coming back to what that means for the way that we understand it, we're literally just like blindly just applying it again and again and again, and just memorizing new ways to apply it. And so the number of questions that we're able to confidently answer is directly proportional to the number of different questions that we practiced on. There's no scalability. There's no, oh, I learned how to do this question, so therefore I know how to do all the different questions of this type. It usually ends up being somewhat of a one-to-one relationship, which is why it can be very time-consuming. This is why a lot of people really struggle with maths, because they don't have any first principles understanding to really fall back on to problem solve if something doesn't go well. Whereas people that find maths relatively easy or straightforward, they're really strong at it, they understand how maths works, they understand how and why the equations work, and so it's very easy for them to apply it
because they know in what situations to apply it, because they have a first principles understanding of the equations and the formulae from the theory down, rather than purely just back and forth between the application and the equation and just applying a different equation for a different application, so on and so forth. So the reason that I'm emphasizing that is because that actually dictates one of the first most important changes that we need to make. And I'm going to get to that very shortly. But very quickly, there are two different types of problems that we tend to get in an exam. And the different types of problems are what I would just call standard problems. Standard problems are usually ones that people are generally pretty okay at. These are the ones where the way that you're assessed is very similar to the way that you learned it. So if you learn a particular equation a certain way, then that equation is assessed to you in a very similar way. And so we think, oh, okay, I know the answer to that, and we can just directly apply it. The second type of problem is applied, when we're taking this and we're saying, okay, so now let's attach some scenarios to it. Let's attach some words. Let's make it more contextual. So now it's no longer the function of x equals y. It's like a car is accelerating down a road at a certain speed, and we want to find out at what time it will be when it is, x distance along a road, something like that. We're now applying these equations, and we have to apply it in real context. So why do we struggle when we do this? And this is usually the one that people, very, very often, this is the one that people are struggling with. It's not here, it's actually here. And the reason is because we're learning it simply this way. We're learning purely that application, and if we didn't apply it in that type of scenario, we just wouldn't know. And obviously that's very unrealistic to think that you're going to be able to apply maths in the same way for every single scenario, and it just doesn't work that way. So moving forward, when we look at BHS for maths, we're going to be making a couple changes to how we fundamentally actually tackle maths from the ground up, which is going to make it so that this trial and error is not so meaningless and actually allows you to understand the topic of maths a little bit more clearly. You are still going to have to do lots of practice, okay? That's relatively fixed. You're still going to have to do a lot of practice, but it just means that as you practice, the number of questions that you can answer is going to be more than just a 1-to-1 ratio. It means that after answering 10 questions, you'll be able to answer 100 different question types. After doing 100 different questions, you'll be able to answer 10,000 different question types, rather than needing to do 10,000 questions. Okay, so let's move on to the aim step and see how that works. So when it comes to the aim step, I mentioned that we go to the application very, very quickly. The issue is actually that we still do it in the wrong order. And you're going to see this come up a lot. You may have already heard me mention it if you've seen the other videos, is that the order actually matters a lot. So the order, as in we need to make sure that whatever we're learning is purposeful. We want to make sure that whatever we're learning is problem solving. Okay, this is from the cave theory. And it's the same thing with maths. In order to understand maths better, in order for the equations and the formulae to all make sense a little bit more, we need to know why we're learning it. We need to have a purpose behind it. So if we're learning the theory, then the equation or the formulae, and then we're seeing how we can apply it. And even if this process here is only, let's say 10% of the amount of time, and we're getting to this within the first, let's say, 20 minutes after we've learned it, we're already trying to apply it. This is still not the right way, because this application is now framed as an example of this, which means that in our minds, it's like, okay, there's a theory, I need to memorize that. This is the equation, I need to memorize these, and these are the different ways that we can apply it. And therefore, the more ways that we can apply it, the more we know. What we need to do is we need to do it the opposite way. So this is where the order really matters. We need to think, okay, we're going to learn this theory. Stop. How can we apply this? Why do we need to know it? Okay, why is it important? So you'll see that we're covering the what is it, why is it important? And then how are all the different theories and different equations related to this big picture? And by doing that, we're going to be able to build an understanding of maths that's saying, okay, we're learning about something in calculus right now, or about complex numbers. Why this is important is because it allows us to do this, and it allows us to do this in the real world. We can use it for these types of different applications. And the way that we actually do that is by using these types of various equations. And then these are how those equations work. And then we can reapply it. So this is the order that's very important. What is it? Why is it important? And then, how does it relate? What's the relationship exactly between them? And now once we've understood that, when we learn about, okay, so what are the equations? And why are the equations important? Relating it back here, okay? Doing the relationship again. So we do this kind of back and forth where we start with what is it? And then we go to the big picture straight away before we actually try to understand the equations at all. So normally what we're doing is we're going through this linearly, but we're just going through it very quickly. We need to flip that. We need to actually start from understanding the problem that we're trying to solve, and then try to solve that problem by learning the theory and the equations in order to solve the problem. So it's the same as any other subject. We need to learn in order to solve the problem. We need to learn in order to solve the problem. So obviously we need a problem. And that's where the aim step comes in. So what we're going to do is look at this topic of differentiation and integration. And we're going to ask these questions. What is it? And why is it important? And then how does it relate? And I've put a star next to the why is it important, because that is, especially for maths, this is the most important question that you need to think about. So I've gone through the topic of maths, and I've written down all the main concepts and equation types and keywords and things that I've been able to get. I've gotten this from looking at a combination of summary notes written by other students. I actually had a copy of paid notes that people were selling as a service. They weren't particularly good. In fact, I think the summary notes that the student made were actually better. I also used just Wikipedia and Google, and I compared this against the curriculums. So this particular one is based off a combination of the VCE, HSC, and WA WACE curriculum, but I've also compared it with the IB curriculum, and although the subject material is slightly different, the way of thinking I can verify is exactly the same. And actually, having done also multiple other curriculums and taught students in multiple other curriculums in other countries before, I can actually say that it's pretty much the same in every single country that I've ever seen the curriculum of, or at least any decent, half decent enough curriculum. So it's basically the same process. I just got these notes, I laid them out all open, got the resources out, and then I put down all of these keywords. Now, for me, it's been a very long time since I've studied maths. A very long time. I studied maths in my final year of high school. I haven't really even touched maths at all, calculus especially. I haven't touched calculus since then. I was reasonably okay at calculus when I was in high school. And having said that, it's been over 10 years since I've studied it. So this is old news. And trust me, back when I was learning this, I was not an efficient learner. I didn't have ultra high retention. So just like you, how if you don't study calculus for like 6 months, you forget like 60% of it. If you don't study it for 10 years, you basically forget 99% of it. So looking at this was almost, not quite, but almost like me studying this topic all from scratch. So I can tell you that while doing this aim step and collecting all of these, I felt the urge to look at the equations and really get into the nitty gritty. And I thought, oh man, there's so many different keywords and concepts here. It's starting to get overwhelming. But I know, as a more experienced learner, I know that that feeling of overwhelm is normal. And I know that that is going to allow me to learn much faster in the shoot step. So all I'm doing is I'm going to go through all of these and I'm just going to ask these questions. That's it. Differentiation. What is it? Why is differentiation important? If I can't find it in my notes that I had, I will simply Google it. I will Google, why do we need to know about differentiation? Why is differentiation important in real life? And there's a bunch of Google results that come up. Some of them are way too detailed, and just by reading the little excerpt that comes up on Google, I can tell whether it's going to tell me the information I need or not. If it doesn't tell me the information I need, I'm just going to go back and find a different resource. I'm not going to read everything that's on the page purely because it's there. I have a question in my mind. I want to know why differentiation is important. I want some real world examples of why we need to know this. And until I get that answer, I'm going to just keep looking and scouring and skimming all the different resources, which is exactly what I ended up doing. And it was very quick to do that. I often find that students spend too long on a resource that doesn't answer the questions for them properly. Don't spend longer than you need to. If the resource that you're looking at, is not answering the question, if your resource is not a good match for this, skip it. Find a different resource that is a match, because this is all time that is wasted, and there's no point. There's a question you need answered. You don't need to get sidetracked. You can go back to those details later when it's the right time. So I went through all of that. I went differentiation. What is it? Why is it important? I then went application of differentiation. What are they? Why are those applications important? And I thought, how do they relate? That was relatively straightforward. Integration. Why is that important? And what is it? And how does it relate to differentiation? And then applications of it. Why is it important? And how do they relate to the applications of differentiation? And what are the similarities and trends between them? And then going through each of these. What is a derivative? Why is a derivative important? How does that relate to differentiation? What is a chain rule? Why are chain rules important? How does that relate to differentiation? How does that relate to derivatives? Operations. What is an operation? Why is an operation important? And how does it relate to chain rules, derivatives, and differentiation? So on and so forth. I did that for every single word. And as you go down, you don't need to end up asking the exact same questions because you will have already kind of covered it. So by the time you get down to operations, you kind of already understand how it's related to derivatives purely because you happen to have read it while you were searching for one of your previous questions. So it's generally speaking, when you first start, especially on something like this, where it can initially be very confusing, like maths, we often don't have any prior knowledge on any of these before we learn it. The initial time is very slow and then it speeds up very, very quickly, okay? So expect it to be slow. But just keep at it. So doing that for all of these things took a little while, going through all the questions. And then what we're going to do is we'll see in the shoot step how all those questions that we're asking and all that curiosity that we're building allows us to build a really simple structure of learning, and then how that allows us to then apply the equations and things in a much easier way. So let's have a look at that when we get to the shoot step.
Lesson, we're going to do a deep dive into how we can apply the chunking approaches for a subject like anatomy. And this is a popular request because anatomy is one of those topics that is inherently fairly memorization heavy. And I will say that off the bat is that anatomy, like some other subjects, does require more memorization. So you will need to use more memorization techniques, such as flashcards or other techniques that you learn throughout the course. However, you can still reduce the load of memorization substantially through proper execution of other encoding strategies. The difference with how we apply these strategies for something like anatomy and with frankly any other subject that has this high memorization load is much the same as how we would apply it for any other subject. The only difference is that when we do it for a subject like anatomy, we have to be more decisive and selective in terms of how we chunk things. And rather than there being a inherently correct way of chunking something, it's more so the way that we decide is going to be the most strategic for our learning needs. Normally when I do a demonstration of a specific subject, I prep everything in advance and then I just show you exactly how I do it. But for something like this, I think a lot of it comes down to how I am thinking about it. So what I'm going to do here is I'm actually going to study something completely fresh, something that I have not prepared before, something that I have not actually touched or even studied for a very long time. And I'm going to walk through my thought process behind how I am looking at the material and the decisions that I'm making. And hopefully you can see how you can apply that approach to your studying as well. You will notice that it is essentially the same strategy. We are still going to be scanning through the material, picking out the parts that we think are more or less relevant, and forming that overall backbone between the ideas that we can then chain together and then build everything off of. A few things that we're going to need to place front and center of our mind. These are principles that you should already be familiar with. The first thing is that knowledge and information that is isolated will not be retained as a rule. If we decide that something we learn is not something that we can retain through connecting it and creating relationships or groups, then we will have to memorize it. But we have to accept that we want to reduce that as much as possible. Yes, sometimes we will need to isolate it because there's no other way that we can think of to integrate it. But if we can integrate it, it's always going to be better. So sometimes there are multiple ways that we can integrate the knowledge, and it's just about deciding which way we want to use and what is going to reduce our memorization volume as much as possible. And this goes for any aspect of anatomy, right? So again, this is the rule, is that when you're learning it, we want to find some way to prevent that information from being isolated, and it will provide some level of memory benefit, okay? And actually, the ways that I'll teach you and some of the examples that I'll give you that you're free to use, obviously these frameworks, they will allow you to retrieve the information to a deeper level and a more clinically relevant level as well. So I'm going to be using the 6th edition of Clinically Oriented Anatomy by Moore, which is just a textbook that I happen to have on hand. And I'm going to pick a type of anatomy I think that maybe many people struggle with, which is upper limb. And so I'm just going to go and start studying through upper limb. I've got my tablet in front of me so I can write my notes. I also have just, an internet browser as well, so in case I need to look up anything. So because this is just a demonstration, I'm simply just going to start from the beginning of this chapter, which gives an overview of the upper limb, a comparison of upper and lower limbs, and then it goes through the bones of the upper limb. So the first thing that I'm going to do is scan through the information. And it's very easy to get overwhelmed by the amount of information because there seems to be so much specific detail that there's no possible way that we can learn this outside of just learning it in isolation. And that's really the trap. We can acknowledge that there is a lot of memorization, but we still need to find a way to try to integrate it as best as possible. So while I'm reading through this, I'm going to be thinking, what are the possible ways that I may be able to integrate parts together? And I'm just going to leave some notes as I go about this. You'll see that this is effectively the same thing as keyword collection, but while I'm collecting the keywords, I'm kind of doing a semi-aim step at the same time because I'm thinking, how is this important? How are all of these things important? And I'm trying to think of multiple different ways that I can integrate them together, giving it some kind of purpose, some kind of context, some relevance to some level of importance. I'm not necessarily settling on chunks or chunk structures, but I am giving myself ideas in terms of how I may or may not chunk it. And this is really the same exact process that you would go through if you were to just do a normal aim step on any other subject. The only difference is that there are many more chunk structures that you could potentially form, and there is a lot more keywords and terminology. But this is still the perspective that I've got in my mind. So I'm just going to go through this chapter, and I'm going to basically make that list. One thing I'll note, though, is that a benefit of anatomy is that the chunk structures and the patterns repeat heavily. There's really only just a few different ways that you can kind of look at things, and it will start making sense. The other thing is that you already know, usually, how to think about anatomy once you learn how to think about it one time. Which means that when you're skimming through it, unlike a more conceptual topic where you may see a new word and you don't know what concept that means, in the case of anatomy, when you see a new word, it usually just refers to another specific part of the anatomy. And so conceptually, it's not very difficult to understand. It's just like it's talking about this knob versus this knob. It's the same concept. So it means that when you're skimming through it, even though the total number of possible keywords is higher, the cognitive load that is involved in thinking about why they're important is not really as high as you might think compared to the number of keywords you're collecting, because they're all kind of just different flavors of the same thing, at least conceptually. So it means that you're able to do this quick skim for example, upper limb, but you could do the same thing for lower limb. You could do this for thorax, the cranial vault, whatever type of anatomy that you want to do it for. You can kind of apply the same thing because you know what to expect when you're going into anatomy. Not necessarily the case for something like physiology or for other subjects. Now, as I'm going through here, I am not letting myself get too bogged down by a lot of the additional things. So for example, even in the earlier paragraph, I'm reading here shoulder, and then it's going into pectoral, scapular, and then deltoid regions. So at this stage, I'm not really worried about the pectoral, scapular, and deltoid regions, but what I am writing down is the idea that there are different regions, and I'm wondering, what is the significance of having different regions? Why is that important? How is that going to play into anything? And then I'm writing down arm and then shoulder. And again, I can see that arm is divided into different regions. Here it's just posterior versus anterior regions. But again, I'm thinking, well, what's the significance of understanding the different regions of the arms? And I have some ideas. Could be due to, you know, the function and the motion of it, or it could be due to something embryologically. I'm not really sure exactly. So I'm just going to leave that as a question mark, and I can always come back to learn that later. I'm also seeing that there is a diagram here, and this diagram is fairly comprehensive. It's a typical anatomy diagram. You know, you see the picture of the bones and lots of different labels coming out of it with lots of different terminology. And at this current stage, I'm not really going to worry about that too much until I've got a better, higher level schema of how to think about anatomy and how to think about all the different components of the anatomy. What I am going to look at is the words that are bolded to give me a general sense for it. When I'm looking at this right now, I'm not really learning anything new because it's the upper limb. I'm seeing a shoulder, arm, forearm, hand. It's kind of what I would expect because I've been looking at my arm for, you know, my whole life. I'm not learning anything new there. So I'm just going to carry on and see where the next part is. Now, right here, there's a comparison of the upper and lower limb, and this is a type of detail that a lot of people would often sort of skip over because they don't think it's contributing to their learning immediately, because it's not like a new keyword or terminology or anything. But actually, this is the type of thing that is very helpful. It draws a comparison between the nature of the upper limb and the lower limb, and talking about how the upper limb is not involved in weight-bearing motility usually, and so it sacrifices a lot of the stability in order to gain mobility. And so from my perspective, I'm also thinking, well, what would that look like anatomically? What would I expect to see for an upper limb versus a lower limb where stability has been sacrificed in lieu of mobility? I may expect to see that the joint capsule is looser, the range of movement is going to be wider, and that may be because the joint space in itself might be a little bit larger potentially. There's likely going to be, less kind of encasing around the joint structurally from a sort of like a bony point of view, and potentially maybe even the insertions and the origins of the muscles themselves. Maybe the muscles themselves are actually a little bit thinner. Maybe they're arranged in a way that compensates for some of that stability. Are we compensating with a bit of active stabilization by having muscles involved in stabilizing the joint instead of having bones involved in stabilizing the joint? So these are sort of questions that I might have in my mind. And then now when I'm looking through the anatomy, you can see already that this is allowing that information to have more relevance. Whether I'm right or wrong, the insertion and origin of a muscle or the nature of a muscle or something is going to be a little bit different, right? It's going to feel a little bit more relevant. It's testing a hypothesis. So let's just continue reading. And here again, I'm just reading very, very quickly. I'm skimming through this. I'm not settling on any singular part of it. I'm just skimming through it and just seeing, is there anything else that's sticking out to me? Is there anything that's pretty interesting or relevant or something that allows me to just understand the bigger picture of upper limb anatomy? And after skimming through this, it wasn't really, it was kind of just talking about the same thing. And I spent, not very long, like, I don't know, 10 seconds, 15 seconds just skimming through the rest of this page just to see if there was anything that I missed. And there wasn't anything particularly that I caught. So I'm going to move on to the next part, which is just the bones of the upper limb. And I'm going to skim through this as well. Now, I did actually at the beginning when I was explaining the chapter, I actually skipped through this very, very quickly, as you saw. So I already in my mind have an idea about what is going on in the chapter. Literally just this very, very brief, just literally at this speed, just getting an idea of what is going to be introduced in what order throughout the chapter. This gives me more of an idea about what to expect, and it helps with my order control as well. And it can be done in sort of seconds. If I hadn't flicked through it before, I would always make sure to flick through it first. I know that there is this blue page here in the middle, which gives me some clinical correlates and some clinical application, that's going to be very useful as well to help with my chunk structure later. So I'm just parking all this information for now. Okay, but I'm just going to carry on through here. Now we're looking at some of the bones of the upper limb. It's starting to go into just listing out some of the particular processes, but I'm going to just chase down that route that I thought of now, which is the idea of like, what's the relevance of the different regions of the shoulder, and how are the similarities of the upper and lower limb represented in the anatomy that I'm seeing right now. So I've sort of skipped that, just this whole paragraph, and I'm just going to go straight to this diagram to have a look at the annotations there and see if I can see any patterns or trends, any similarities and differences, any way that I can make this huge diagram, this massive list. Can I make this just a little bit clearer, a little bit more obvious, a little bit less something that I'm going to have to memorize? So let's just have a look through that now. Okay, so now I'm hitting this point where I'm thinking there are a lot of things that need to be known here. And it's a good segue into another major pattern that you can leverage when you're learning anatomy, which is that anatomy often occurs for a specific reason. So if you think about anatomy in terms of just the grossest level, most macroscopic, it's not really too hard. Clavicle, scapula, humerus, and then you've got the articulations involving in the elbow, and then you've got the radius ulna, and then the various bones of the hands. So that is not usually too difficult to wrap your head around. What makes it difficult is where are each of the individual fosses, where are the individual tuberosities, where are the specific ridges. These are the things that can be, very time consuming to wrap your head around. So here is the point where we should really be integrating it. When I read something like saying shaft of the humerus, I may ask myself, well, why is that important? Well, shaft of the humerus is important because it's literally, that's just what that's the bulk of what the humerus sort of is. But if I'm reading something that says deltoid tuberosity, in my mind I'm thinking, why is that important? Well, most likely because I have a general physiological understanding of how bones form. I know that bone is a dynamic tissue, and I know that it responds to forces and force patterns. I know that the collagen and the fibers arrange themselves in response to stresses. So the fact that there is a tuberosity most likely is a result of some actual force that's been acting on it, right? And so I'm thinking, well, why is there this tuberosity? So this is likely going to be either the origin or the insertion of some kind of muscle that is pulling on it to create some kind of force. It's called the deltoid tuberosity. Through just common knowledge, I know that deltoid muscles are the sort of shoulder muscles, grossly speaking, without going into the different heads and all the other stuff. I know the deltoid is going to be a shoulder muscle here. And it makes sense. Do I expect that the origin of the deltoid muscle is going to be starting from the middle of the arm? Unlikely, right? It's the shoulder muscle here. So it's probably going to be the insertion. So already I'm thinking, well, I already know intuitively that the deltoid is going to insert somewhere in the middle of the arm. It's probably going to be in the sort of middle upper part of the arm rather than right in the middle of the humerus. So again, that's where the deltoid tuberosity is. Which border is it going to be on? Just instinctively, I can already say it's probably going to be in that lateral section. So without really looking at anything, without reading anything, I can hypothesize that the insertion of the deltoid muscle is going to be in that sort of lateral edge of the sort of upper half, upper third of the humerus. Right? So it's already starting to sound like something that most people would start to memorize, but I'm making sense of it. I'm not having to memorize that because it is already intuitive. So, well, where's the origin of that going to be? So I know that it can't be, originating from like the neck because the deltoid muscle is not like the neck, right? So it has to be originating from somewhere within this shoulder articulation. And where exactly is it originating from? I'm not entirely sure. Is it from the clavicle? Is it from, one of the superior borders on the scapula? If it's attaching on the scapula, I'd expect the scapula to have a similar tuberosity or something sticking out where it can attach from. So now let's look at the scapula. I'm going to look for is somewhere where the deltoid could actually originate from. And if I can't see that directly at an immediate glance, that's the type of thing that I could just Google straight away. What is the origin of the deltoid muscle? So we're basically going to go through in this way. Each tuberosity, each groove, each ridge, we're going to try to make sense of. Ridges and grooves tends to be there because there is some kind of thing that prevented the periosteum from just building up in that point. It sort of built around it. And therefore, that usually indicates either like a tendon or a ligament or a blood vessel or some kind of nerve or a combination of all of them or some kind of fascial sheath or something. So every time that there is some kind of like condyle or a groove or a ridge or something like that, I'm going to think, what is there that helped to form that ridge in the first place? So instead of just memorizing the medial supraepicondylar ridge, I'm now going to think, well, what was it that what travels in that space to make that happen? So you can see now that what I'm doing is I'm taking parts of the anatomy. For example, here we're learning about the bone of it, but I'm actually attaching and integrating it with the muscles as well as with the tendons and the ligaments, as well as with the blood vessels, vascular supply, as well as with the nervous supply. And I'm integrating what I'm learning here. So I'm starting to already create these basic sort of webs of information. And it's not complete yet, but again, it does allow the information to be a little bit less isolated. And here I'm exercising order control. I'm not just learning it in terms of like all the bones first, memorize that, and then all the muscles, and then attach that to what I know about where the bones are. I'm not doing it that way. I'm doing it in terms of where I feel is going to allow me to integrate this knowledge in the best possible way. I'm asking the question, why is the tuberosity important? Why is the intertubercular sulcus important? Why is the lesser tubercle important, right? And by doing that, I'm able to consolidate that with muscles, tendons, blood supply, and nervous supply. We can then use other aids. For example, we can use 3D digital modeling systems. For example, and there's various ones that are out there, biodigital human, zygote body, and these allow you to have a 3D view of the human body. If you have cadaver labs and dissections, you can also get a 3D understanding spatially of how the muscles and everything work, and also anatomical variation between individuals. One thing that you should keep in mind is that there is actually natural variation in anatomy. Like you may learn textbooks that, for example, one particular nerve travels through one particular ridge and penetrates the muscle at a certain point, but there is a spectrum there. Not everyone will have that exact same pathway. There is going to be some anatomical variation. So what's less important is for you to memorize exactly that. But what's more important is to memorize what are the implications or the consequences of something like that. So for the sake of time and for the example, I'm not going to go through literally everything, but this process of thinking and looking things up, going back and forth between muscles, tendons, blood vessels, nervous supply, and the bones and all the different things, that is going to take us a fair amount of time. If I were to do this entire page when it comes to arm anatomy, just purely using this, it will take me a solid, probably at least 1 or 2 hours to get through that. And you may be thinking, well, that's a lot of time that I don't have. But actually, it's not really that much time, because it would normally take you maybe sort of 15 to 20 minutes to get through this page at a passive level, just looking at everything in isolation. But then it's going to take you another 15, 20 minutes to learn the muscles and then the tendons and the blood vessels and the nerves. And it's going to take you another hour to consolidate that, and you can forget half of it and you have to spend another hour relearning it again. So again, when you're looking at across a span of things, it's better just to learn it deeply in an integrated way from the get-go, from the very, very beginning. So I would do this, and I would form these basic groups. In the beginning of doing something like this, especially for something like anatomy, you are not going to get very extensive, well-connected mind maps and chunk maps like you would with other topics that are more conceptual. Because the main reason here is that when it comes to anatomy, there is no real logic to it at a higher level. The logic is just whatever you choose to help you make sense of something. So you could divide it into whatever way fits for you. You could divide it into anterior versus posterior, if that makes it feel easier to remember and less something that you have to just memorize. You could divide it into function, contraction versus extension versus torsion. You could even divide it into, for example, size. For example, like the bones or the features that are larger, or the ones that you feel more functionally important. So these are all different ways that you can try to group information together. And again, it's just about what you feel is going to help you reduce the load of memorization. One great example of this is when we're trying to group information for anatomy where there are lots of things happening in a very small space. So for example, if we were to look at the anatomy of the trunk and the torso, or just generally things around the axial skeleton, the anatomy there tends to be a little less detailed. There's sort of less going on intricately in a small space, and is less important to remember all of those intricacies. Compare this with something like the anatomy of the forearm. The anatomy of the forearm involves multiple muscles, each having a fairly distinct pathway. There's nervous supply, there's blood vessels, there's tendons, and there's ligaments, and obviously the bones and things that it attaches to, which is, fairly straightforward. And then there's stuff in the hands as well, in terms of the bones of the hands, as well as where each different muscle attaches to. When we're looking at anatomy that is very dense, it can be difficult to form these integrations because everything seems integrated with everything else, and it's all integrated in such a close space that it doesn't really feel any different from just learning it in isolation. It's in a way overly integrated because there's so many connections. So if we're choosing a chunk structure for something that is anatomically dense, that does not make the density easier to remember, and that's unlikely to be a good chunk structure. So, for example, you could chunk the entire logic of the forearm in terms of contraction versus extension, or you could do it in terms of sort of things that are more medial to more lateral, and you could do it that way. However, the difficulty there is that when you do it that way, you are not actually including the information related to the things that make this topic the most difficult. So for example, all those tricky origins and insertions and the vascular and nervous supply, or the myotomes and dermatomes related to that, or the specific nerve branchings that occur and when that occurs and where it penetrates through a muscle body and things like that. All of that information ends up being lost in the chunk structure because that's not represented in purely just anterior versus posterior division or purely a medial to lateral division. And so as a result, that information is going to have to exist later downstream. That's going to be stuff in the leaves of the tree. You're going to have to then say, okay, well, this is this particular nerve and that travels this particular pathway, and this particular branch, penetrates through the muscle body at this particular point, or this muscle originates and inserts in this particular place. So all of that stuff that actually makes it difficult to begin with will end up being in the leaves, which means that your chunk structure is not really leveraging that knowledge in a good way. It's not providing you that much benefit because, realistically, are you going to really forget that there is an anterior versus posterior part to your arm? Is there that there's a medial to a lateral order that you can remember things? No. So that's the type of thing that you don't really want to have in your chunk structure. Instead, you might want to look through a different method of integrating the information. So what is that different method? Well, I mentioned before that there are some clinical correlates that are represented in this book. And this is the reason why I like a textbook like Moore's Clinically Oriented Anatomy, because it does orientate the anatomy clinically. So what is the clinical application of anatomy? Mostly, when we're looking at it, especially musculoskeletal anatomy, we're thinking about it in terms of injury and surgery. So that's the clinical approach to it. It's different for a different system. So for example, gastrointestinal anatomy, we're looking at that potentially differently because there's a surgical aspect of it, and then there's also the medical aspect of it, which allows you to form a better differential diagnosis. So again, it's the same method of thinking. So we're thinking about, well, what is the anatomy? How does the anatomy help us with our clinical reasoning? If someone has left upper quadrant pain, we can use our understanding of anatomy to think about the different ways that that pain could be caused. What are the areas that could cause pain? Is it musculoskeletal at the skin level? Is it like some kind of dermatitis? Or is it a little bit deeper? Is it something subcutaneous? Is there anything really subcutaneous that could cause something like that? Maybe an intercostal nerve pinch? Is there anything deeper to that in terms of the muscles themselves? Is there some kind of muscular tear? Is there some kind of costochondritis that's radiating down? And then we can go even deeper into that. So now we're looking at, is there something to do with the omentum? Well, the omentum doesn't really have any pain receptors in itself, so it's unlikely there. Is it something to do with the actual intestines themselves? Is it to do with our other related, a blood vasculature or something? Is there some kind of ischemic episode going on? Is there some kind of nervous thing? Is there some kind of obstruction? Is there something that's going to be to do with one of our more solid organs? So again, we can continue that sort of checklist to identify where it could be, and then we can categorize that alongside the parts of the history and the examination that we're getting to form this overall picture. So you have to think about anatomy when you're learning it like this. Anatomy serves a purpose. It serves a purpose in terms of either your clinical reasoning or your clinical management. For example, your ability to operate and do surgery, your ability to relocate a bone, your ability to interpret an x-ray, your ability to form a differential list for a medical pathology or a medical versus surgical pathology. So without thinking about how anatomy is going to be used in clinical practice, we're missing a whole branch of how it can be integrated. Most medical schools teach anatomy in a way that is very isolated. It's disease focused. And there's a lot of criticism in the research and in the general academic space that medical schools should not be arranged that way. And indeed, a lot of the more progressive universities are now implementing what are called integrated curriculums, where you are exposed to the clinical application of your knowledge at a very early stage and very frequently to prevent medical students from learning things in a disease focus. But if your university doesn't teach you that way, well, it's still up to you, because you still need to have your knowledge that way. So it's a little bit more effort for you, but again, it now means that you have a competitive advantage. Most other students aren't going to do that. So if you can do that, not only will it help you to learn the anatomy pre-clinically, but also in the clinical years, you're going to excel because the knowledge is much more versatile and you can use it much more fluidly, right? You really want to be thinking like a doctor while you're a student. You don't want to think like a student and then eventually get to the point where you need to think like a doctor and you've never done that before and your knowledge is now useless and you've got to repackage that. It's a very time-consuming process. So when we're thinking about why anatomy is important and how it can be related, yes, one of the ways is to think about it in terms of, well, how did the bone or the muscle or the tendon or the blood vessel get there in the first place? We may want to Google it a little bit in terms of the embryology. We may want to Google a little bit in terms of, sort of the, not going into, very, very deep embryology, but just very basic embryological principles that may help you to understand how it is that this structure kind of formed. And actually, that is one of the frameworks that I recommend that you run through is there a way I can understand this embryologically? And you can actually just Google that for like sort of 5-6 minutes for that region of the muscle or region of the upper limb or lower limb or whatever you're looking at. So for example, if you didn't have a chapter in here talking about the embryological origin of upper versus lower limb and how they're very similar, which can help you to learn it and now create correlations between upper limb versus lower limb anatomy, and therefore that would have a memory and benefit for you. Well, even if it wasn't explained, you should, think about that. Is there some embryological method of understanding upper limb that makes it a little bit easier? It makes it less just random words, and it just makes a little bit more sense. And then you can Google that. And if there isn't, then that's fine. Or if there is, but learning the embryology is going to take you hours in itself, then that's not going to be worth it. So you just leave it. And if that doesn't work, then you can come back and you can look at it in terms of just connecting it in itself, like what I've demonstrated before in terms of connecting the bones to the related structures. Or the other way, which is often very high yield, is relating it clinically. So what would happen if there is a fracture of the clavicle, or what happens if there is a fracture of the scapula or the humerus? Where are the fractures likely to happen? What are the fractures likely to look like? How are the fractures likely to displace? You can imagine that if a fracture is going to happen across a bone, the lines of tension around where the muscles are attaching, where the support is or isn't, is going to dictate where that fracture is most likely to take place, the type of fracture you're going to get. Is it going to be like just a clean, full-on break, or are you going to get something that's more like a volar end plate fracture, or something that is more about just a connective tissue ripping through and ripping off the attached part of the bone? So we can think about it in terms of what types of fractures are more likely, where those fractures are likely to occur, and if there is a fracture, how might we see that presenting? And we can take that to the next step. If we were to repair this fracture, or we were to examine this fracture, what would that mean? So for example, if you had a laceration of the wrist, well, there's lots of different things that are going to occur at the wrist. So instead of memorizing the anatomy first and then thinking, well, what happens if there's a laceration? Instead of that, think, what happens if there's a laceration? Try to figure out and piece together from what you know and can make sense of, and then learn the anatomy with the view of examining a laceration in mind. Almost imagine that you are a medical student in the emergency department who's never studied anatomy before, and then your doctor who's supervising you says, hey, look at that patient, examine them, and tell me what you learned. And you've got 15 minutes to learn the anatomy before seeing that patient and examining it to this doctor who's going to grill you on it afterwards. Put that as kind of like a sense of pressure or a lens to view things through. Now, when you're looking at the anatomy, it's not just here are these muscles and veins and blood supply and things like that. You're looking at it and you're thinking, well, how deep does that go? How deep would the cut have to be? How am I going to test for that particular function? And so now we're able to integrate even more things into this. So this opens up the branch for a whole new type of chunk structure, which would be the clinical type of chunk structure, as in if in the case of this type of injury, these areas of anatomy are affected versus these types of injury, this part of the anatomy is affected. So if you look at it that way, that's very, very different to how you may normally learn anatomy. But actually that is very close to how you may use your understanding of anatomy to perform an examination on a patient. But let's say that that's still too complex. We're not able to get something through an examination. Well, in that case, we may want to move to like a management approach. How would we operate on someone that has an issue over here? So let's say that we're creating some kind of incision in the lateral aspect of the pectoralis muscle. So if this person is on the operating table and we're going to make an incision right over here, let's say we're making some kind of 5 centimeter incision. And this is a hypothetical situation, and you can actually just look at real operations and the things that they're careful of. Then we're thinking, what do we need to make sure we're not cutting into? Is there a blood vessel here that I need to be aware of? Is there some kind of nerve here that's really important that I need to make sure I don't sever? How deep should I cut? And at what point should I get rid of the scalpel and just use my fingers to blunt dissect? At what point do I need to really slow down? Where do I want to make that cut versus where should I not make that cut to avoid certain areas? Right? For example, putting a chest drain in. Where do you put a chest drain and why? What are you trying to avoid there? When you're operating on, someone's arm, where do you go about trying to, for example, fixate a bone again? So when we're thinking about it in terms of an examination point of view, it's a slightly different lens compared to if we're thinking about it from a management point of view. How would we fix issues to do with this anatomy, right? So you can see that for any given piece of anatomy, there's multiple ways that we can chunk it. The just purely isolated, here is the anatomy, memorize all of it, and then start thinking about clinical correlates, that is a very ineffective way of doing it. That is the equivalent of learning in isolation and then trying to consolidate afterwards, which is going uphill. We want to use higher order thinking at an earlier stage. And that means creating integrated knowledge earlier on. And we can integrate that knowledge in multiple different ways. We can integrate that just in the context of its relevant surrounding anatomy. We can integrate it in the context of embryological origin and development. We can integrate it in terms of the potential diseases or clinical presentations that we might see it in, which is often a very high yield way to look at it. We can do it in terms of how we may examine a patient with issues in this area. And we can think about it in terms of how we would manage a patient with certain issues in this area. And often what we will do is we will combine these together. So even in just the upper limb, we may decide that for everything from, brachial plexus right down to the olecranon, we're pretty happy to do this in terms of a combination of just anatomy and how it's related to each other, and then embryological origin stuff. And it's relatively straightforward that we can do that. To memorize the brachial plexus, we may use a little bit of memorization technique combined with a little bit of pathology related issues. If there's a problem in some place, where, what would I expect to see? So we can do a disease focus of that. What would happen if, this particular trunk is gone versus this particular trunk? Or what if there was a gunshot wound here? What would I expect to see? How would I examine someone to see what parts of their brachial plexus have been affected? So we can combine it like that. But then let's say that in the forearm and the hand, it's a little bit too complex. That's not getting us to good yield anymore. So we may use a different chunk structure for that. We may swap to one that is more clinically oriented. We may do it based on presentation, right? A person presents into ED with a wrist laceration, with a swollen elbow, with a with a crushed hand injury, with a dislocated finger. So we can think of some of these characteristic, you don't have to have hundreds, just a few of these clinical presentations, and that's going to allow you to integrate the knowledge more. In real practice, you would have to go through many possible presentations and many possible diseases or injuries or surgical management options in order for you to be able to integrate knowledge to the point where you don't have to memorize anything anymore. That's not feasible time-wise, and also in terms of just the fact that preclinical knowledge, it's arguable whether you can even get to that point without substantial clinical experience. So the aim here with these kind of pockets of more integrated knowledge is that we're creating these sort of landmarks. This is more memorable because we spent more time to integrate it. This is more memorable, but there might be parts in the middle that are less memorable. And these are the things that we will have to use memorization techniques for. But by creating these sort of big landmarks where some of the more complex anatomy, the most forgettable parts, the things that you would normally struggle the most with, by spending more time and effort to integrate that, that means that we're not only saving time in the future because we're reducing what we're forgetting, but it's making all the other parts around it easier to remember because you can integrate it together, right? So you may remember that a laceration over here in the forearm is important because you have to, when you're repairing it, or examining the patient, you have to make sure that they still have contraction function at the hand and at the wrist, and that they still have sensation over here in their fingertips and things like that. Or you may have found that, through a management approach, that if someone has sutures here that are too tight or something, that it can cause some kind of like compartment syndrome or something if it's, starting to get too swollen. So, we're thinking about things in a different kind of angle. And then we may have a really good understanding of some of the things that happen at the hand. We may understand like a base of scaphoid fracture. We may think about things like boxer's punches. And so we have a good understanding of some of the implications in the anatomy in some parts of the hand. So now we can put two and two together. We can say, well, we know that the blood vessel runs like here up to this point, and we know that that blood vessel is important here because that's something that we test and examine. So logically speaking, between here and here, it's probably going to just continue here, right? And we know that there may be a tributary coming out from it, going down back to the dorsum of the hand, for example. And that's maybe something that you may memorize. But by having kind of landmarks of stronger anatomy, we can kind of link together the parts in between. So we want to prioritize the parts that are the most forgettable. We want to integrate them. We want to use multiple different possible chunk structures and evaluate them. Does it take longer to get through a single region of anatomy doing it this way? In a single session, for sure, easily. It can easily double or triple the amount of time. But take it from me, someone who has studied anatomy a lot, and starting from in 2012, when I first started learning about MSK of neck down, anatomy is something that most people just study and learn again and again every single year of medical school. And then at some point, you just stop studying it because you're not going to become a surgeon. But if you are going to become a surgeon, then you just basically have to study everything again. It is well worth the time to know your anatomy well and to learn it properly the first time. Even if it takes a little bit longer the first time to do it, it's still well worth it. When you are in the pressures of preclinical and you've got heaps of stuff to study and you just do not have the time to integrate everything, integrate the best you can. In the time available, pick the parts that you feel are the most difficult to remember. At least integrate those parts. Later, when you're relearning it and when you're revising it, you can start integrating more parts and just add to the network and the connection, and you can build it over time. And maybe in the meantime, you are having to rely heavily on flashcards and memorization aids and things that you just have to cram. Maybe that is something that you have to do in the short term. If you're a busy preclinical student and you just do not have time to integrate everything, but integrate what you can. Integrate the low-hanging fruits. Integrate the things that are going to be the most forgettable. Spend a little bit of time, maybe not 2 to 3 times longer, but spend 25% extra time on just really deeply integrating certain parts of it. And at a certain point, that's going to start snowballing. It's going to get easier and easier to study anatomy. And then especially in the future years, you're going to thank yourself 100 times over because you're going to be the only person that actually is in theater looking at an operation happening and knows what is even going on. You're not going to have to revise the anatomy the night before. When you're assessing someone in ED, you're not going to have to revise the anatomy every single time. This is the case for a lot of medical students. The anatomy that you learn in the preclinical years is almost out the window by the time they're actually using it in clinical, or at least they're not able to use it at this level of depth or as fluently. So it's a worthwhile investment, even if you're not investing in it fully, at least within the amount of time that you have. And hopefully you're using these approaches, these chunking approaches and what we teach in higher order thinking to learn your physiology and your other subjects as well. And those you can leverage a lot more. So you should be able to save heaps of time with all the other things. So therefore you will have a little bit more time that you can invest in learning something like anatomy. So I know I didn't go through literally and make like a mind map for every single thing, but that was less important. I think what's important is just talking about the approach and the different chunk structures that you can apply for anatomy. And also, there's the same case for dermatomes, for myotomes as well. We're thinking, how is this important? How is it relevant? How am I going to use this information? And those different frameworks that I gave you, that's still just as applicable for something like gastrointestinal anatomy, for head and neck, for thoracic, for upper and lower limb. Whatever you're learning, it's all still going to be incredibly relevant. That is how doctors and surgeons and radiologists know their anatomy.
So by now we've got a pretty good understanding of the first step towards more efficient studying, and that is the aim step, the ability, the skill to create curiosity, which is so important for basically every single effective studying technique out there. It all comes back to this foundation. But obviously, there's no point in learning any of that if we're not even able to concentrate for long enough to even use these skills, if we're not able to just focus and not get distracted after the first 15 or 20 minutes. So let's take a little bit of a detour and talk about how we can improve our focus and remove distractions. So the topic we're talking about is distractions and distractibility. And there's a little bit in terms of the anatomy of a distraction that I want to focus on here first before I tell you the components that we can actually do something about and improve on. So distractions are an important thing to reduce, obviously, but are really formed from a two-step process. Okay, so what we need to do as a student who's being distracted is we need to enter into a state of focus. And when I say a state of focus, I'm talking about a state where the distractions don't really bother you anymore. And we're talking about a state where you're able to really just zone into your work and just completely connect. Okay, we're talking about a state of flow, sometimes people will call it. So that's what I mean when I say that we want to enter into a state of focus. And you know that feeling when you're really into it and you're able to get a lot of work done and you're very productive. We want to be able to create and enter into that state. So that's actually part one. And then we want to stay in that state for as long as possible, which is part two, aka maintaining focus. And there are a few beginner techniques that we can do that I think it's important for you to get familiar with. And then, as usual, we will build on this even more in the later courses. Okay, so we'll go over what we can do with those beginner techniques soon, but I want to explain why it's so important that we maintain this focus at all costs. And this is actually the most important part. So between entering into focus and maintaining focus is actually more important, primarily because of the fact that most people find it reasonably okay to actually enter into focus as long as their environment is set up to do so. And the issue is actually not in terms of entering into the focus. It tends to be that after the focus is entered into, we're easily broken out of it. And there are also a lot of misconceptions around maintaining focus as well, which we need to really correct. So in my experience, although this seems like it would be the one that is the most important, and yeah, it's a prerequisite, you can't maintain focus if you never entered into the first place. But for most students, I'd say around sort of 70% of the students that I work with, the real issue that cuts the productivity in the most is actually being able to maintain that focus for a longer period of time. So the thing that I want to point out is this concept of what's called a cognitive switching penalty. So a cognitive switching penalty is how should we call it? It's a sort of psychological phenomenon. It's just one of those things that actually happens as a result of multitasking. Okay, so multitasking is, if we've got a brain here, okay? Multitasking is when we're trying to focus on multiple things at the same time. Now, it's not possible to really focus on multiple things at the same time. So if, for example, you're like reading something and then you're like reading another different page, you can't really read both pages at the same time. Okay, not like a normal human can't do that. For example, you can't really focus on speaking French
while at the same time playing the piano or something. It's not actually possible to do what we sort of think of as like pure multitasking, where the brain is doing literally more than one thing and focusing on both of them at the same time. What we end up doing in reality is what seems like multitasking, but what we're actually doing is just rapid switching. So rapid switching is when we are focusing on one thing and then we rapidly change our focus to another thing and then rapidly change our focus to another thing. So it seems like we're multitasking, but what we're actually doing is just rapidly changing our focus. So for example, that's why you can baking something, okay, which might require a certain element of focus at a certain point, but then also at the same time have a conversation, which also requires focus. But if you're really concentrating on something with your baking, it's hard to have also an engaging conversation at the same time. And what we end up doing is we just switch back and forth. And when one thing requires more focus, the other things reduce in focus. And that's just the way that our brain works. So back in the day, I think maybe 40, 50 years ago, the science at the time theorized that the human brain is capable of focusing on anywhere between 10 to 13 tasks simultaneously, even including rapid switching, actually. So even including not pure multitasking, even just rapid switching, we thought we were able to do 10 to 13 tasks with minimal reduction in our efficacy, and that the quality of our work would be still pretty high. Modern research on this actually shows that this is completely not the case. So what we know now pretty definitively is that actually the human brain is only capable of focusing on around 2 or 3 things at any given time, and that's including switching. Like, as I said, pure multitasking doesn't really exist. It's just not something that our brain is really capable of. But when we're talking about rapid switching, that gives the illusion that we're multitasking. We used to think that we could do 10 to 13 things and just switch between them very, very quickly and still maintain decent efficiency. But what we've found is that we can only really manage and switch between 2 or 3 things at any given time. And actually, the quality of what we're doing reduces after 1. Okay, so what that really means is our brain is a machine of focus, and it operates the most when there is only really 1 thing to focus on, although we can stretch it to 2 or 3. But if you're stretching it to 2 or 3, there is a reduction in the level of quality of the work. And when it comes to something like studying, we really don't want to be reducing the quality of our work, because again, that just means that we're spending time on studying, but that also means that we would have a reduction in the actual learning that the studying produces, okay? So if we are getting a reduction in quality in our studying, what that really means is that the learning that we get for the time that we put in is lower. So we spend 1 hour studying. If it's high quality, then we're getting the full hour's worth of learning. If the quality of studying is low and it drops by 20%, that means that the amount of learning that we get, aka the knowledge we retain and apply, has also reduced by 10 or 20%. So we obviously don't want that, right? We want high retention as early as possible. We want this learning quality to be high. We do not want to be reducing the quality of our study. So we don't really want to be doing this rapid switching and reducing our focus. Now, what's the cognitive switching penalty? So the switching is referring to this process here, rapid switching, switching from one task to another task to another task, focusing on multiple things at once. Every time we switch our focus from one thing to another thing, what we have found is that there is this thing called the cognitive switching penalty that occurs every time we switch. So what the cognitive switching penalty actually is our brain trying to effectively load the task again, okay? Load the task again, like a computer loading something. So have you ever been to like a web page, and the first time you load the web page, it takes a really long time to load it, but then if you refresh the page, it loads, instantly. It's much, much faster.
And that's because what your computer has done is that it's downloaded all of this and it saved it onto your computer. So when you're refreshing it, it actually just pulls it from your computer again. So it's much faster. It's not downloading the whole thing all over again. And actually, this is called a cache or a cache. And so you may have seen this on your computer, clear your browser cache. It's basically saying, your computer has downloaded a bunch of stuff, you can clear it and save some space. It turns out that your brain works quite similarly in that when you're focusing on a task, it kind of engages itself in a way where it gets better and better at doing that task. And so your efficiency goes up. Now, when you break out of that task to switch to another task, your brain now needs to start loading up this new task. And so it takes a while for it to start getting more and more efficient at it. Okay? And when you return to the previous task, you don't carry off from where you left off. You actually need to build this again from scratch. So you have to do this process again. Okay? So the idea is that when you focus on a task, as you focus, okay, as time goes on, as you focus, your brain is getting more and more efficient at doing it. It's entering into a flow state and it's faster. Every time you break this, your brain needs to reload that task. And then you have to start building this efficiency all over again. So if you never really let it get to this point where it's, the slope is a little bit faster, the efficiency is a bit higher, and you're always breaking the task off, like here or here, then you're basically always working within a low level of efficiency. So everything takes you a lot longer and it's harder to focus and it's easier to get distracted as well. So cognitive switching penalty is actually quite a big thing and it's best to avoid it at all costs. So you really do not want to switch out of things. The reason this is important because every time you get distracted, so let's say you're studying, and then you get a phone notification. Okay, your phone goes off, and you check your phone, and you spend the next 2 minutes scrolling through Facebook or Instagram or answering messages and stuff. Okay, 2 minutes of studying. Okay, so let's say that you were studying for 20 minutes, and you spent 2 minutes getting distracted. Normally, people would say that's pretty good. Okay, and in terms of time, it is pretty good. Right? You spent only 2 out of 20 minutes being distracted, which is, 10%, which is actually, honestly, to be honest, that's probably pretty high, 10% of all your time being distracted. But, 2 minutes is not a big deal. But actually that 2 minutes does more harm than just the 2 minutes because this is the 2 minutes that you spent checking your phone. However, it might take you another 10 minutes to get back into your flow and concentration. So even though you spent 20 minutes studying, then 2 minutes of being distracted, and then let's say another 20 minutes of studying, for example, in reality, what that would have been is you, in the first half here, were building up that efficiency. So you really only got, let's say, a 60% level of efficiency for that first 10 minutes. And then you were at a let's say, 99% efficiency for the remaining 10 minutes because you were in flow. You break out of that, you have to do that again. So now that's 60% and then 99%. So 10 and then 10, which means that of the 40 minutes that you spent studying, 20 of those minutes were only spent at an average of 60% efficiency, which means that if you really look at how efficient you were with the use of your time, it really drags it down by a lot. And that was just from this 2 minute break. Okay. If it was a 2-second break, probably wouldn't have made a big difference. Probably not enough time for your brain to actually let go of it. But as soon as you give your brain time to let go of a task, break out of flow, and then get into another task, which 2 minutes honestly is more than enough time for, then you then need to spend another period of time building up that efficiency again. So cognitive switching penalty is basically that phenomenon where every time you switch, you suffer a consequence of it. So we want to reduce that as much as possible, which means we want to, number one, stop ourselves from getting distracted. And number two, never try to actually multitask. So highly efficient people, despite whatever weird myth this has come from. Highly efficient people do not multitask. Highly efficient people are able to focus on a single activity deeply for a prolonged time. Okay? And this is the formula for having high levels of focus. You want to be able to create focus for a single task for a prolonged period of time deeply. That is the foundation of focus. Okay? Never forget that. The foundation of focus is dictated by your ability to focus deeply for a duration of time on a single activity. And that's what I'm going to leave you with before we move on to the very simple techniques that we can actually use to increase our efficiency and focus. At the actual techniques we can use to increase our focus and remove the distractions. So there's 4 letters you can see that have been pre-filled out here. Again, these are just the basics. They're just the basics. They're not going to be the full system. What you're going to see is that when I introduce later techniques, they will build on these basics. So you need to be, really good at this to begin with. The first thing that you should do is what I call intention setting. So intention setting is actually a very simple technique that you can use whereby before every focus session or something, you're simply, setting your intentions. So let's say that your focus block is, 20 minutes. You've got a 20-minute block where you're going to focus for, okay? Or a 30-minute block or a 1-hour block. It doesn't really matter, okay? You're setting a certain amount of time. And I will go into rest and work timing. How long should you work for? How long should you rest for? All of that. I'm going to go into that, okay? But it's not as important. It's not as important as the stuff that I'm going to be talking about right now, okay? So stuff like Pomodoro technique, blah, 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 all of that sort of stuff, it's not as important as doing these basics. Pomodoro technique is honestly a little bit overrated. So intention setting means that before each block of focus or study, you are just saying, by the end of this block, I will have achieved something. And you're just making it clear and explicit what you will have achieved. And intention setting is a technique because it has to actually be a conscious process. And I would actually say you want to write it down. Okay? And it might seem like, childish to write down your goals for study or whatever it is, but it really works. Okay? So who cares if it's childish? Do what works. Do you care about seeming childish or do you care about succeeding at life? Okay? I know which one I would rather. So write down your goals. And when you write down your goals, you want to make sure that they are very specific and achievable. You may have heard of SMART goals before. S-M-A-R-T, SMART goals. It's a very well-known way of goal setting as a basic framework. It's, it's pretty good for setting goals. And I'll make a note of that underneath this video just for your reference. I'm not going to dive into that in full depth because even though it is, fairly useful, especially for beginners, it's not fully relevant for this. The most important parts for this particular technique is that your intentions and goals are specific and achievable. So don't just say in the next hour, I'm going to study biology, because that's not at all very specific. You don't want to just say study biology or study maths or do English. You want to say by the end of the next hour, I will have finished my aim step for the biology chapter 23 and have started on the shoot step, okay? And we'll talk about the shoot step later. Or I will have revised and done 3 practice papers within the next 1.5 hours. Something that feels achievable for you and something that is very specific so you know exactly whether you failed or not. Okay, and that's the main thing. You need to make sure that you know, did you fail or did you succeed? That has to be very clear. And the reason is because, like I've said before, your brain operates the best when it has a very single direction to think about, singularly focused. And so something like do biology may seem singularly focused, but that's really vague, actually. Study biology, it's very vague. So you want to give yourself very, very specific intentions so that your brain doesn't actually have to think about what to do. All it has to worry about is singularly worry about doing it. You don't ever want your brain, while you're actually working, to think about what is it that I'm meant to be doing right now. You do not want your brain to ever think that. You want to know exactly what you're doing so that any given time throughout your focus, you're able to just refer back to the intention that you had. And this is not only going to help you enter into focus in the first place, this is also going to help you actually maintain your focus as well. Okay, so I'm going to just copy that down here just so that you know. Intention setting, being able to refer back to these very specific goals is helpful not only to enter into focus to begin with, but also to maintain that focus throughout it. So write them down, make sure they're specific, make sure that they are giving your brain a very, very clear focus about what it's meant to do. This is what you will focus on for the next 20 minutes, super, super specifically. And don't like overload yourself. Don't say in the next hour, I'm going to study my entire year's worth of chemistry. It's just not possible. So be realistic. The next thing that we want to do is we actually want to do something which is called ritualization. I'm not talking about getting a sage stick and burning that over your head before you study. Ritualization is a process through which you create a certain, it doesn't even matter what it is, but certain steps or a certain routine that you do before every time you focus. And so the brain does this very interesting thing in which if you do certain steps, so let's say, just for example, let's say that the steps are that you, number one, okay, sit down, you take 3 deep breaths, you pick up your pen, and then you tap it 2 times on your desk before you study. Now you'll be thinking, Justin, what in the heck are you talking about? You're going to look like a mentally unstable person before every time you sit down to study. You're just like, and then you tap the pen. So it seems very weird, but the brain, like I said, is really good at creating patterns. And so what it will do is actually, if you create this routine every single time you study, and then you enter into a state of focus, your brain will actually start activating a deeper level of focus every time you do this. Okay? It's really like a magic trick. It's just one of those things in psychology that we have discovered about the way that our brain works. It's almost like a bug or a loophole or an exploitation that we are able to use for our advantage. So for whatever reason it is, our brain just does this thing where if you have a certain routine before you study or actually do any task, if you do it again and again and again, you will actually start activating that method of thinking purely by doing the routine. So you actually see this a lot, most commonly with professional athletes. So if you've ever watched someone like a professional like basketball player, just before they're about to do a free throw, you'll often see what they do is they sort of stand there and then they bounce the ball. And you'll see that they bounce the ball, different players bounce the ball differently. Or if you watch tennis, they bounce the ball or like throw the ball or do a certain spin with their racket. And it's the same exact movement, the same number of bounces with the same hand every single time. And this is actually them doing their ritual, because by doing that, it actually increases the chances of them landing that throw or hitting it properly or hitting the serve well when they actually do it. So this is something that's well known in sports. By having a very consistent, what's called a consistent setup, it means that there's almost like a mentally very solid platform to then execute off of. It's a weird psychological phenomenon, and it actually works with studying as well. So the idea of creating rituals or pre-routines before doing certain activities Like golfers will do this with their swings, basketball players with their free throws, tennis players with their serves. Basically, in every sport at a competitive level, every athlete has something of a ritual. And in fact, if you're an athlete yourself, you already know what this feels like. And the cool thing is that it's not limited to just sports. You can actually do routines and rituals for entering into focus. So I know a lot of very top students, what they'll do is before every exam, they have a certain routine. I had my own routine. In fact, I had this very specific song that I listened to only before exams, and listening to the song, even actually to this day, that's how hard the routine was embedded into me. To this day, when I listen to that very specific song, I will feel as if I'm about to sit an exam. I feel my focus just tunneling in. So I had a Muslim friend who prayed before every single exam, and that was part of his routine and ritual, and that is what helped him just develop that focus. I had another friend, very intelligent guy, very, very smart guy. What he used to do is he used to always shower and then take a 20-minute nap. Always shower, then take a 20-minute nap before every single exam. And well, needless to say, he crushed his exams. So everyone has their own little routine. It can be small, it can be big. Mine was relatively small. Some people have relatively big routines. Meditating before exams actually is a very common and effective strategy. In fact, there's even research on that to show that it's a very effective routine because it just focuses in your mind. So creating these rituals, and again, it doesn't really matter what the ritual is per se, but it's just something that you think you'll be able to do consistently, pretty easily, every single time you focus and study. So for me, the ritual that I used to use was a particular breathing exercise. And I'm actually going to teach you the breathing exercise as well, because I normally teach all my students and they find it pretty effective. The third thing is to create focus zones. Now, a focus zone is an environment which is protected. And I actually have talked about this before when I talked about the just basic quick tips to increase your focus and remove procrastination. Is you really want to be very cognizant of what are the distractions. So in this case, you've got a phone here. You want to be removing this phone. You want to create a zone of focus where, you might be getting distracted by things, but you want to just kind of cut off as many of these as possible. So you create a isolated zone of focus where there are just no distractions. So feel free to go to extremes to remove distractions in your environment, because remember, every single distraction that enters into your zone has a potential to make you activate a cognitive switching penalty, which is going to have pretty detrimental effects to your overall productivity. Okay, this is relatively straightforward. A lot of students don't take this very seriously. Mature students, advanced learners, high-level learners realize how big of an impact this makes, and they will go to lengths to remove distractions. Often mature learners, who have been studying, like for example, law students, later year engineering students, medical students, doctors and lawyers, people that have studied for 10 plus years and really know how to study to a high level, they will really go to extremes to make sure that their zone of focus is optimized, because they just realize that it's almost, there's no point trying to focus when the zone is not there. And it just makes a huge difference. And to supplement that zone is something that you should already be using, the distractions cheat sheet, right? These are the distractions that you didn't remove in your zone that will affect you, and you get distracted by them during your study, and you write them down as you go to say, these are the distractions that I need to make sure that I remove from my zone next time I study, which means that every single time you study and focus, your ability to create this zone of focus gets better and better over time. So these are the basic strategies. Some of them will be familiar already. Some of them you might already be doing. Some of them you may have heard over it, like the ritualization. You may have heard of this before because it's pretty well known. A lot of research behind that. But, obviously you can't study if you're not able to even focus to begin with. And these are some of the basic foundations behind developing good focus and removing distractions that are a minimum foundation that any high-level learner or any productive individual will be putting in place, okay, as a basic minimum. And then once you're able to do these, I can teach you some more advanced foundations
and more advanced techniques later on that are going to be, again, even more effective and build on these foundations.